Yes, hi guys. Good morning everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, that is the BYJU'S Exam Prep, and welcome to the GATE EE mock test. Yes, it's December, mid-December, and I think we all think that this is the very appropriate time to start solving the mock, and you might be, I believe, definitely solving mock test in your regular routine also, right? Yeah, I know the frequency of mock test will more increase when you are towards the month of January, but still you might be solving it. And that is why for all EE students, we have brought this live mock test to change the atmosphere, to change the mood regularly. Yes, you keep giving the mock test, and you should be giving the mock test as a computer-based test regularly with the virtual calculator practice and all those stuff. Okay, but just to, get into a little interactive mode, just to change up your mind. Right, we planned that we'll have a live mock test for the EE. That's live on the YouTube. So one by one, all your favorite faculties will come up and discuss several subjects, and let's continue forward then. Just a moment, guys. All right, quickly update all your friends that the session is live. Do not forget to share the session. Okay, so that many can join this mock test. More the students joining, more will be the fun, more will be the competition, right? And just one request. Yes, good morning, Bhargav and Pankaj. Just one request, that do not forget to note down your marks. I'll tell you the procedure also quickly. Let's get started. Okay, before we get started, this is a quick update for all of you that yes, if you are one of those, yeah, your juniors, your colleagues, somebody planning to prepare for GATE 24 but slightly confused whether they should or they should not, in this particular workshop that is coming up tomorrow, that is Sunday, on the BYJU'S Exam Prep app at 12:30 p.m. where I'm going to discuss the 7 key important career prospects through GATE. There will be many career prospects directly, indirectly, but there are 7 major key career prospects that can help you secure a bright future in this examination, and we are going to discuss that tomorrow. Right, in the workshop that is going to occur on the app. And also, guys, right, for all of you, okay, bringing up a new and different type of series. Very good morning, Ravi, Sahil. Bringing you a new and different type of series. Yes, the GATE PYQs. If still you have not attempted or you have some doubts in the PYQs, let me tell you, the previous 5 years will give you the more perfect analysis, okay, of what GATE is looking into, what is the level right now, and what areas they're more targeting. And that is why, especially last 5 years, 2018 to 2022, all PYQs for ECEE, we are going to discuss subject wise. This is going to be a live subject wise session, and this starts tomorrow, that is 18 December. Tomorrow there will be the first session of control systems. Yes, tomorrow there's going to be the first session of the control systems, and that's going to be at 6 p.m. tomorrow. Okay, so yes, and step by step all subjects will be coming up. Okay, your technical subjects, your core subject, common subjects, core subjects, everything, including machine, power systems, all those subjects will be covered in this PYQ series. Subject to subject, it will keep going on. And also, guys, the mega mock challenge. Okay, this is one full mega mock. This is live. But other than that, yes, to make you, compete between thousands of students, BYJU'S Exam Prep has brought you the Mega Mock Challenge, All India Open Mega Mock, which is live on the app. You have to just register on the app and appear at any time, any day at your convenience between the 13th to the 20th of December. Right. Chalo, guys. So slowly, other people are joining. Everybody, okay, share the session so that more and more can join. And let's get started then. Let's get started. Now, this is going to be exactly as per the GATE pattern. You are going to have 65 questions in this mock test. Okay, we are going to have all the 65 questions in the mock test, where the 10 questions will be GA, 5 1 mark, 5 2 mark, and the remaining 55 questions will be technical, of course, including the engineering maths. And of course, this is as per the GATE pattern again. 25 1 marker and 32 marker question will be there. Right. Good morning, Nagasri. Okay, this is what is exactly the pattern we are going to follow. We are first going to wrap up the GA. First, let's start with GA and then one by one technical subjects. So we'll move on towards. Okay, the first one is GA. I'll only request, with every question we have mentioned the mark and the type of the question, because the type of the question will be, okay, can be MCQ as well, can be NET, and can be the MSQ as well. All three types of questions will be there. Okay, take a separate write down, just maintain a separate notebook. Whatever question comes, start solving immediately and see whether you are able to solve it or not, in how much time you are able to solve, and write down your score on a separate page. Right, for every question, how much marks you have secured. If it is negative, write down the negative so that at the end you can total it up. Right, so guys, quickly, first of all, right, good morning Raghu and Karthik, very good morning all. First of all, starting with the general aptitude. Okay, here it is, the first question. Now guys, quickly, ready everybody, pointing towards Sumit, Anuj said, he is my mother's father's son's brother's son. If Vinita, who is married to Karthik, is the mother of Anuj, Anuj was the speaker itself, then how is Vinita related to Sumit? Come on everybody, quickly a blood relations question. You must be familiar with this. Okay, nothing difficult here. Come on everybody, keep doing that quickly. Start doing it quickly. Okay. Iske baad next one jo aayega, that is even pretty much more easy. Pointing towards Sumit, Anuj said, right? And he's pointing towards Sumit. Okay, so the reference person is Sumit and Anuj. Acha, last में भी बोला है Vinita, who is married to Karthik, is the mother of Anuj. Okay, chalo, तो Anuj said he is my mother's. Okay, guys, come on. Quickly keep solving and I'll also start approaching the question. By that time, if you're solving parallelly, you can put the video on mute for some time. Don't listen. Let me also try down so that finally we both come to the correct answer. You also take your time. Okay, so there is the Anuj and he is my mother's. Who is the mother of Anuj? Clearly mentioned Vinita, right? Okay. That means female. Okay. Mother is the female. He is my mother's father. So now this mother also has a father. So this becomes the grandfather relation. Father is male. He is my mother's father's sons. Right? Mother's father's son. What is this statement, guys? My mother's father's son is my brother, no, actually. My father's son, actually. I want to listen to this. Mother to ho gaya, Vinita. Father's son. My father's son is just like my brother. Okay, so my father's son. So here there will be a son. Okay, which is going to be the sibling to Vinita, right? Sibling, brothers and sisters are represented by the arrow relation. So this is the sibling to Vinita. Okay, father's son's brother. Now this son has another brother. Okay, this son has another brother. So both of them are actually son to this father. Let me call it as son 1 and son 2. Okay, so again, another sibling pair. And that brother has a son and he is Sumit. Achha, anyways, this has nothing to do with question, but here I will not mention the gender of Anuj because the question is insufficient to say the gender of Anuj. What one common mistake that we do here, Anuj looks like a male name, right? Dekha hoga kahi bhai dost kisi ka naam hoga Anuj, right? But who told that there is no rule that Anuj can't be a female? Maybe a female's name is Anuj, na? There isn't any rule, there isn't any law in the world. So unless and until it is clearly specified by the question, okay, you can't specify the gender of Anuj. It is not required, but just I am adding on. Dhyan rakhne ke liye, just I am adding on. Okay, if Vinita, who is married to Karthik, Vinita is married to the Karthik, marriage represents equal to relation. Okay, then how is Vinita related to Sumit? So this is not actually required. Vinita related to the Sumit. Okay, how is the Vinita related to the Sumit? Okay, tell me. Right, Sumit has a father. That father and Vinita are brother sisters. So Vinita is who? Sumit's father sister. Sumit ka father ki sister. So correct answer is C, everybody. Yes, guys. Yes, Ashish correct. Devashish correct. It is the father sister. Bahut badhiya. C is the correct answer. Let's go for the next question and keep noting if you have rightly answered this question. Keep noting 1 mark in your register. Select a figure. Spatial aptitude question. This is very simple. This can be solved in seconds. Select a figure from amongst the 4 alternatives, which when placed in the blank space of the figure X. So figure X has a blank space specified by the question mark, which when placed in the blank space would complete the pattern. Right, would complete the pattern very clearly, very logically. Here horizontal, yeah, let me complete this curve, and then here you have to place a square. Which one it is? It is clearly option number B. Just completed and seen. isn't it? It's option number B. Very simple. So if there is a question coming from special aptitude category 1 mark, very simple. So this was a 1 mark MCQ question. It is very simple. Next question की तरफ जाएंगे, number 3. Right. So although I don't usually deal with verbal, but yeah, since it's a mock test, so I will make your verbal part also complete for this particular session. Select the most appropriate word from the given group of words. Something of little value. Something of little value. Something is less important, less significant. What is that word which means something of little value? Anybody? Any idea? Now, usually, I'm telling you, I don't usually deal with verbal. ये आपके लिए मैं complete करा दूंगा because mock test we have to complete all. But let me tell you one thing here. You know, this is something I usually keep referring in the maths as well when we study trivial, non-trivial solution. Homogeneous system of equation, when we study trivial and non-trivial solution, there also I explain you in a sense what trivial means, right? Why do we call it as trivial solution? Ax equal to 0 when x is equal to the only solution. When x is equal to the only solution, okay, that solution is little of less value, little less important, insignificant, because ax equal to 0, right? X is equal to 0 will always satisfy, na? A into 0 is always 0, that is independent of the system then. Okay. Trivial, something less significant, something of less value. The more important thing is that if there is a non-zero vector x, which will satisfy ax equal to 0, that is known as a non-trivial solution. So you can try to relate these concepts something. ये click हो गया. Okay, so it is a trivial, option number A. Next जाते हैं. Fill in the blank with the most appropriate alternative. Okay, a light breeze dashed the forest fire and made it more dangerous. Made it more dangerous. So what is the intent? See, a light breeze dashed the forest fire and made it more dangerous. Okay, there was already a fire. Okay, a light breeze, एक हवा का झोंका आया. Something like that. एक हवा का झोंका आया, right? Already there was a fire, and what will that हवा का झोंका do? Made it more dangerous. So what should be the correct word? मतलब in a sense उसने आग को और भड़का दिया, right? You know, आग को और भड़का दिया. ना. It is fanned. Okay, it is fanned. It is the correct answer. Fanned. Okay. The correct answer is yes. Pankaj has come up with the correct answer. Fanned, right? It is A. A to bilkul nahi hoga. It has not exposed. There was already a forest fire. Okay, it fanned it up, right? It increased its intensity. And next question is here. Next question is here. Identify the incorrect statement. Identify the incorrect statement, right? Now -1, -1/3. For 1 mark, the negative marking is -1/3. So that is what crazy I told you, no? Making it more intense, increasing its intensity, crazy machine. Okay. Simon's looking very pleased with himself today. Okay. Right. Like sometimes you also can be looking very pleased with yourself today. Okay. You can go out and play unless it gets dark. Next statement. I haven't seen her ever since she returned from the far east. Okay. She returned from somewhere. उसके बाद से मैंने उसको देखा नहीं है. He could sense their presence behind the door. Which of the statement is incorrect? Come on, quickly share your opinion and then I'll let you know the answer. And just place your answer. Just don't look into the comment box what others are telling you. Also will have to take that. Some common patterns keep coming. Some common patterns keep coming here. Okay. You can go out and play unless it get darks. It's talking about a time. जब तक अंधेरा नहीं हो जाता तब तक खेल सकते हो. Right, Aruna, very good. You can go out and play until it gets dark, isn't it? Until it gets dark. जब तक अंधेरा नहीं हो जाता. Right, unless it's for a specific condition. Right, I will not do this work unless I get a good pay. Unless I get a good pay. Okay, I will not do this work unless I get a good pay, right? कि जब तक वो मुझे इतना पैसा नहीं देता, I'm going to not do that work. But this is about a time mark कि जब तक अंधेरा नहीं होता, until. The correct word here is until. Okay, that is why option number B is an incorrect statement. You can go out and play until it gets dark. Okay, it's not unless, it's until. That can make the statement correct. That can make the statement correct. It's option number B. Okay, no problem, Devashish. Okay, verbal, whatever you are confident, attempt. Otherwise, You can leave that as well. Next. A cistern is filled by 3 inlet pipes A, B, and C. Now coming to the 2 marks MCQ question. Right, coming back to the quant once again. A cistern is filled by 3 inlet pipes A, B, and C, and pipe B takes 5 hours less than pipe A and 4 hours more than pipe C. So there are 3 inlet pipes, and all are inlet pipes, all are filling. There is no negative work here. There is no negative work here. So let's say A takes X hours, B takes Y hours, and C takes the Z hours. This is the number of hours, let's suppose. X hours, Y hours, Z hours, right? Okay. Pipe B takes 5 hours less than pipe A and 4 hours more than pipe C. Okay, one of the argument is coming up here. That is pipe B. That is the Y hours. It is 5 hours less than time taken by A. So 5 hours less than X. And the same time is 4 hours more than the time taken by C. 4 hours more than Z. Y is X minus 5, and that is equal to the Z plus 4. Okay. If pipes A and B together takes as much time as C alone. Okay. एक तो ये statement हो गया. Then what is there? A and B together. Acha, what is A and B together? What is the time taken by 2 persons together to complete a work? If there are only 2 persons working together to complete the work, then the time is given by the X plus Y upon X plus Y formula, just like the parallel resistance, 2 persons working in parallel, XY upon X plus Y. If A and B takes as much time as C alone, okay, so if they work together, they take as much time as C alone, and this is given to be equal to the time taken by C, that is Z. Okay, that is Z. If you can make everything in one variable, so then the things will be slightly simpler for you. How? Okay, yahan se Y is X minus 5, so what is going to be Z? Z plus 4 is X minus 5, so Z will be X minus 9. So dekho, X into Y is equal to X minus 5 divided by X plus Y is equal to Z, which is X minus 9. Or I can say that X into X minus 5 is equal to X minus 9 is multiplied by 2X minus 5. Now one of the approaches, solve the quadratic equation quickly. Solve the quadratic equation quickly and you will get the answer, right? Another approach is, देखो x cannot be, okay, यहां से ये तो समझ में आ गया, x cannot be 3 or 8. Sir, why? If x is either 3 or 8, na, you are going to make the answer as negative. Okay, well, you're going to make it as negative. X number of hours can't be negative. Na, 3, negative 3 to not possible, Devashish. That is not at all possible. So x cannot be 3 or 8, otherwise, okay, you are going to make one of the equation like X minus 5 is the time taken by Y. Time taken by Z is X minus 9, and that will become negative. Okay, so time can't be negative here. So that is definitely not equal to 3 and 8. So you are left with the choice 12, 15. I'm again telling you, either solve the quadratic equation or either you can just substitute, right? Okay, you can try X equal to 12 or X equal to 15. You can just try here X equal to 15. The correct answer is 15. मैं आपको बता देता हूँ. Right, just try X equal to 15, because when you try 15 into 15 minus 10 is 10. Right hand side 15 minus 9 is 6. 2 into 15 minus 5 will be 25. 6 into 25 is 150, which is again 15 into 10. The correct answer is going to be C. A time and work fundamental question. But more than time and work, here it is the equation that is involved here. Because 2 persons working together, that you should clearly know that the time taken by 2 persons working together is xy upon x plus y. These quick things you must know. Otherwise, we can solve by concept of efficiency. But there has to come a time where you don't have to solve detail, right? Otherwise, you will lose time in the GATE exam, right? Slowly you can solve question, but you will lose time in the GATE exam. So you have to take care about both the things in the GATE exam, the concepts, your accuracy, and as well as the speed. Now it is the time to speeden up the things. Next question, number 7, 2 marks MCQ. Okay, it's a counting question, but achievable. Okay, simple hai, dhyan dena. A new flag is to be designed with 6 vertical strips using some or all of the colors yellow, green, blue, red. Then the number of ways this can be done such that no 2 adjacent strips have the same color. No 2 adjacent strips have the same color. Just start trying it. A new flag is to be designed. A new flag is to be designed with 6 vertical strips. Okay, there has to be 6 vertical strips. Okay, using some or all of the colors. What are the color options with me? Yellow, green, blue and 4, right? Okay, so yeah, correct. These are the 4 color options with me, and there are the 6 strips. Number of ways this can be done such that no 2 adjacent stripes have the same color. I think you must have solved. Parallelly I'm writing, and again I'm telling you, when I'm writing parallelly, if you want, you have the option, put the sound on mute, so that if you are also trying, you try by your own method with full concentration. मैं parallelly इसलिए लिख रहा हूं so that we save little bit of time, such that no 2 adjacent stripes have the same color. That means think with respect to the first option. Think with respect to the first strip. How many options? Right. If I want to talk about the number of options here, the first one has how many color options? 4 color options. First stripe has the 4 color option. It can be yellow, green, क्या लिखा? Yellow, green, blue, red, anything. But there is one small condition. No 2 adjacent stripes have the same color. No 2 adjacent stripes have the same color. That means what could be the color of the next stripe? What could be the color of the next stripe? Okay, it can be anything except whatever you have selected here. That cannot come here. Okay, so how many color options are there with the next? How many color options are there with the next? 3 color options are there. Done. 3 color options are there with the next. Because no 2 adjacent stripes have the same color. Now, how many color options here? Okay, suppose I have selected green here. Okay, and suppose this was blue. Okay, this is green. So what can come up here? It can be anything except green, na? Adjacent stripe should not have the same color. It's not telling that you can't repeat at all, right? So here what can come? Here what can come is blue can come here. Blue was there in the first, so it can repeat in the third because that is not adjacent. Blue can be here, yellow can be here, red can be here. Anything except green is allowed. So this also has 3 options, sir. This also has 3 options, right? So in short, all other will have 3 options. All other will have 3 options. 4 minus 1. Right, this is 4 minus 1. ये 1 जो है ये adjacent वाले को छोड़ते हुए. Okay. 1 which is occupied by the adjacent previous one. Because we are going from left to right to make sequence. Okay. So what's the answer then? What's the answer then? Then your answer, dear, is simple. That is 4 is multiplied by 3. That is 5 times. 4 into 3 power 5. But if I have to match the options, it's looking like 4 into 3 into 3 power 4. 4 3s are 12 and 3 power 4 has to be the 81. Option number A. It is 12 into 81. It is a 12 into 81. Option number A. Done. Option number A. 12 into 81. Next question की तरफ चलते हैं. In the given figure, AB is the diameter of the circle. AB is the diameter of the circle. C and D lie on the semicircle. Angle ABC, this one, angle ABC is 65 and angle CAD is 45. What is the measure of the angle DCA? Measure of the angle DCA, this angle. What is the measure of this angle? Expected. Geometry questions are very much expected. The geometry questions are very much expected for us. Come on, everybody. What is the measure of the angle DCA? Everybody, come up. Right? Come on, quickly try that, guys. Quickly try that. And answer me. Quickly try and answer me. Just a moment also. Yes, guys. Let's see, anybody? Okay. All right, Aruna has come up with some answer. Come on, others. Let's have a look into it quickly. First of all, AB is the diameter and C and D lie on the circle. Okay, so AB, diameter also means touching the circle only, no? It is the chord of the circle, largest chord of the circle. So what about ABCD? ABCD is actually a cyclic quadrilateral. Can I say like that? ABCD. What is a cyclic quadrilateral? One whose all the vertices lie on a circle, lie on any circle. That is a cyclic quadrilateral. Okay. Now, if it is a cyclic quadrilateral, now please see. Number 2 point that I can use here is this angle C, right? Angle ACB is 90 degree. Tell me why? Because it is the angle within semicircle. Any angle within semicircle is always a right angle. Some properties of circles will be used here, right? Like if I tell you what is angle ADB, agar ye banaya maine, suppose, listen to me. If I talk about ADB, this will also be 90. If I take any other angle, okay, suppose this is AFB, that is also 90 degree. Any angle within a semicircle is going to be the 90 degree. Okay. So ACB 90 ho gaya. So this is 90 degree. So what is this much of the angle then? What is this much of the angle? Okay. 90 plus 65, 180 में से subtract करेंगे because all angles of a triangle sum up to 180. Okay, this becomes 90 and 65. This is 25, right? This is the 25, correct? So this much of the angle is 25. Then they are asking what is this angle? Angle DCA. This was the theta. Okay, because of cyclic quadrilateral property, I can say opposite angles of cyclic quadrilateral always add up to 180 degree, right? So 45, पूरा लिखेंगे. If I talk about complete angle A plus complete angle C, it has to be 180 degree. Opposite angles of cyclic quadrilateral, right? That is 45 plus 25. That is the angle A. And what is the complete angle C? That is theta plus 90. The total sum here has to be 180 degree. Solve कर लेंगे यहाँ से theta 90 minus 70, 90 minus 70, तो बचा 20. 20 degree has to be the answer. Option number C. 20 degree has to be the answer. Yes, Pankaj, correct. Praneeth, correct. Right? Aruna, anyways, was correct. Chalo, it's the option number C. Good question using slide some of the properties here. Okay. Moving ahead to the next question then. Coming up here. In a certain year, 30,000 city cars are produced. Okay, a line chart question, data interpretation. In a year, 30,000 city cars are produced and are sold at 9.3 lakhs per car. If 2% of the total profit is given as a bonus to 2040 engineers, what is the amount received by each engineer as bonus? 30,000 city cars are sold. Now, which cars? City cars. Right. So the question, now this is a line chart which is showing the manufacturing cost and advertising cost of the various cars like Zen, City, Zing, Lancer, Versa and Optra. The question is focused on City. Take it, City, Honda City. Okay, it has the manufacturing cost of 5.6 and this is in lakhs of rupees. Okay, this is in lakhs of rupees. ये यहाँ पे mentioned, I think miss हो गया है. This has to be in lakhs of rupees. Okay, 0 lakh, 1 lakh, 2 lakh, etc. Okay, and the advertising cost of this particular city car is 2 lakhs. Correct? This one is equal to 2 lakhs. Okay. Profit के लिए we need the cost price also. They have told the selling price. So what is the cost price of each car is the manufacturing plus advertising cost. And this one is 7.6 lakhs. Only two types of costs are given to you. Okay, so 7.6 lakh is the cost price of each car and selling price of each car is 9.3 lakhs. What is the profit per car? It is 9.3 minus 7.6. ये होता है 1.7 lakhs. This is the 1.7 lakhs. If 2% of the total profit, now total profit कब मिलेगा when you are selling 30,000 cars. So this was the profit per car. Keep solving, है ना? I again repeat, if you want, put me on mute, keep solving so that you and me parallelly come to the final correct answer and then you can match up your answers, right? So if I want to talk about the 30,000 cars, what is going to be the profit? Calculations एकदम last में करेंगे. So it's 30,000 into 1.7 lakhs and this much of the profit Okay, 2% of this much of the profit is given as a bonus, okay, to 2040 engineers, right? 2040 engineers. Total bonus which is given to 2040 engineers is 2% of this value, is 2% of the profit, right? So what is the bonus for each engineer? Dear, how much is the bonus for each engineer? Number one, 2% is 2 by 100 of the profit, which was 30,000 into 1.7 lakhs, is divided by the 2040. Is divided by the 2040, right? Do it up in one single shot. Use your virtual calculators. Use your virtual calculators. And this is 50,000. This is rupees 50,000 and it's option number B, dear. It is rupees 50,000 and it is the option number B. 50,000, option number B. Done. 50,000, option number B. Done. Next question, right? Next question, the last of the general aptitude, and then we move towards some technical subjects quickly. The child stood on the sidewalk clenching her ice cream cone. Once again, a verbal ability question. Clenching her ice cream cone, holding very tightly. Clenching means something holding very tightly. So a child stood on the sidewalk clenching her ice cream cone. Beds of sweat collected on her little nose as she furiously licked at the ice cream, dipping down her hand. Ice cream dipping down her hand, right? She's furiously licking it because ice cream is dipping down her hand, melting. Okay, and because of that, furiousness or anxiousness, you can say there are sweat that is collected over her little nose. Okay, which of the following can be best inferred, concluded, can be best concluded from the above statement? She likes to eat many ice creams. Can I conclude this? She is eating one particular ice cream cone, but can I conclude she likes to eat many ice creams? I don't think so. I don't think so. Okay. Step by statement jate hain. Yes, Raghu and Devashi has an answer. Let's read this next. It must be cool outside and her nose is running. Nose is not running. Okay, there is a sweat over the nose. So it's the opposite ho gaya. If it is very cool, there's less chances of getting that sweat. Wrong. Wrong. It must be early in the morning hours and therefore she is sweating. No. How much early? If it's pretty early, there is no sun, then there is no sweating also. This is also incorrect statement. And even if it is early in the morning in the winter season, then there is no or less chance of sweating. So this can't be concluded. It must be a hot day because her ice cream is melting. Ice cream dripping down her hand. Right? Pigal ke haathon tak aa gaya because the ice cream is melting. Okay, and ice cream is melting, so it must be a hot day. That is what we can assume, and that is why she is sweating as well. Okay, that is why she is sweating as well. Ice cream bhi pighal raha hai, pasina bhi aa raha hai, sweat is also there, melting is also there. So what is the best possibility out of the four options? That yes, it must be a hot day. It must be a hot day. Correct? Okay. So sometimes you can handle these questions logically. You just have the patience of reading this comprehension, nothing more than that, and you can get the 2 marks. Now, let's move towards the next one. That is the questions of digital circuits. Number 1 here. That is the question number 11. The sequence will be mentioned. It is a 1 mark MCQ question. So we know digital circuit has a very little less weightage for EE, and all the questions are as per weightage only. Don't worry. It is as per weightage. Okay. So the input to the circuit are as follows. Okay. This is the circuit and this is a OR gate, whose output will be A by B multiplied by complemented inputs, that is A bar plus B bar, and this is nothing but, if you know, this is nothing but this is a POS form. This is a POS form of the XOR gate. This is just a POS form of the XOR gate. Nahi dhyan aa raha hai to multiply kar lenge. A into A bar is 0. You get A into B bar, right? Then next term is A bar B. Then B into B bar again 0. And this is what is just A XOR B. So what is given to you is the POS form of the XOR, but you can convert it into SOP also. Okay, so this is the XOR gate. Eventually, this is a XOR gate. Okay, and this is the waveform given to A and B. Okay, this line is low 0, and then the above one is the 1. Okay. What is the correct output waveform? Simple one, guys. अभी तक solve हो जाना चाहिए. Simple one. XOR will give high output only when both the inputs are different. Only when both the inputs are different. Okay, so look into this window. Both the inputs are different. Then they are again same. Whether they are 1 or 0 doesn't matter. They should not be same. So यहाँ पे 1 1 same हो गया. Now again look into this window. Again look into this window. They are different. Right. Now this is again 0 0 same. Look into this window. They are again the different. Okay, so T1 to T7 it should be high. Okay, then T2 to T8. T2 to T8. Then it is T3 to T9. T3 to T9. Option number A. Matched, na? Fine. It's option number A, correctly matching our calculations. Okay, correctly matching our calculations. T3 to T9. Then T4 to T10 completely. There will be a larger window also coming up. T4 to T10. Right? Correct? T4 to T10 where both the inputs are different. Chalo, done. Simple one. Okay, it's a simple 1 mark question based on the XOR functionality. Okay, next one. 2 marks MSQ question. Guys, please note that as I told you, MSQ, NAT, all variety will come. Usually general aptitude, because we started with general aptitude. Usually general aptitude will have MCQ questions. Usually, ऐसा कोई rule नहीं है, but usually that is the pattern. Okay, but now technical we have started, so you can see MSQ, NAT, all questions coming up. Don't worry. Which of the following statement is or are correct? A 8-bit counting type ADC has a resolution of 30 millivolt. Its digital output for an analog input of 2.86 will be now. MSQ question. Okay, usually I know counting type ADC students will start making the truth table, but then you go into a lengthy procedure. Yes, that is the basic concept. But now I'm telling you now, this is the time where you have to apply the quicker calculation, assuming that we have practiced a lot, we have understood counting type ADC. And if you have understood counting type ADC, now what you can only do to solve the option number A, what you can only do to solve the option number A, dear, what you can only do to solve the option number A, given the analog input, I will divide by the resolution. The resolution is 30 millivolts. Millivolts hai, so 30 by 1000, 0.03, and I will take the ceiling function of that. Okay, the integer above this value. So if I divide this, na kitna aa raha hai? This is 95.33. This corresponds to a value 95.33, and when I take the ceiling, the upper integer of that is 96. So your answer has to be a conversion of 96. Your answer has to be a binary conversion of the 96, and 96 is like 64 plus 32. So 64 is 2 power 6. 1, 2, 3, 4, 5, 6. ये 64 हुआ plus 32 2 power 5. तो 1, 2, 3, 4, 5 zeros यहाँ रहेगा और ये आएगा. This should be the 96 actually. Right? This should be the 96. This should be the 96. I don't know why, in my session sometimes glitch at the automatic level. Every apparatus is the same. After I don't know why, in my session sometimes glitch at the automatic level. It automatically will be rectified also. Okay, let's not waste time. Just keep focusing. Okay. So this is 0, 1, 1 and all other zeros. All other zeros. So it should not be option number A then. It should not be option number A. That is what is not mentioned. I think just the previous count is mentioned. Now that is what? That is what you have to take care, right? If you take 95, so this is what is going to come. Okay. क्योंकि जैसे इसमें 1 increment किया, when you increment 1, you get the answer that I have written. So this is the value previously to what I have written, that corresponds to 95. But in counting type ADC, it's going to be the above integer, 95.33 का ऊपर वाला integer, and that is why this is wrong. You have to be very careful. This is what is the binary conversion for 95 given to you. 95 given to you, but answer is corresponding to the 96. Next step. Cool. Next, a 4x1 multiplexer is used to implement 3 Boolean function as shown in the figure. Okay, right. The f is equal to summation m0156. इसको quickly कर लेंगे ना. Guys, you also keep trying. I'll not write down this answer here. Forget. I'll write down the answer at the last. Okay, you also be in mute and keep trying and match the option. Okay, so what is this? Select line पे BC है तो 0 0 first combination पे I0 आएगा. I0 is 1. Next is 0 1 B bar C. With that you get A. Next is 1 0 BC bar. BC bar, with that also you get A. And next is 1, 1, BC, with that you get I3, which is 0. I3, which is 0. So what is the F equal to, dear? If I rearrange this, देखो ये हो गया B bar C bar plus A B bar C plus A B C bar. अब बताइए, sorry, right, A B bar C 1 0 1, this is 5. A B C bar, this is 6. B bar C bar, so A bar is missing here, so A bar and A is missing here actually, right? तो ये तो हो गया 0 0. A can be 0 or A can be 1, right? So 0 and 4, 0 4 5 6, 0 4 5 6. This looks good. This looks good. Okay, this looks good. A 4:1 multiplexer without using any extra gates can implement a Boolean function of 3 variables. Can implement. Now this is a factual question actually. If I have studied the multiplexers, the factual question. If I want to discuss the option number C, right, a 2 power n cross 1 mux, if it is given to you, how much function can it implement? Okay, right, without extra gates. Without any extra gate, clearly बोला है, without any extra gate, right, n variable function can it can implement. If you allow inverter, it can implement n plus 1 variable function, right? If you allow other extra logic gates like and on and, अगर आपने allow कर दिया तो then definitely you can implement a Boolean function of any number of variables, more than n plus 1 variables. Okay, this is what a multiplexer can implement. So yes, it's a 4:1 mux, 4:2 power 2, right? So it can, without any extra gates, it can implement a Boolean function of 2 variables only, not 3, right? Not 3. It can implement a Boolean function of 2 variables. Last, a 1-bit full adder takes 5 nanoseconds to generate the carry output bit and 10 nanoseconds for the sum bit. When 3 1-bit full adder are cascaded, what is the maximum rate of addition per second? Okay, what is the maximum rate of addition per second? Option number D पे जाएंगे. First of all, the total propagation delay, as we all know, is given by the formula n-1 Tc plus max of Tc Ts for the ripple adder. Okay, full adders are cascaded, means it is a ripple adder only that is being formed here. So this is going to be 3. It's a 3-bit adder given to you. 3 minus 1 into carry delay is 5. Plus max of 5 and 10, some delay is 10, so this is 2 5s are 10 plus 10, total 20 nanoseconds is the TPD, right? So what is the rate of addition per second? All this we know, guys. I'm not explaining in detail, I'm just giving you the quick solution for the question. Rate of addition per second is 1/20 nanosecond, right? 10 power 9 by 20, 10 power minus 9 ऊपर चला गया, and you have to split into 10 power 2 and 10 power 7. Right, 100 by 25, 5 into 10 power 7, the D option looks correct. 5 into 10 power 7 looks correct. So what are the options that is correct? A was incorrect. This is 95. Okay. B was correct. These are the numbers correct. Right. This is also incorrect. It can implement a Boolean function of 2 variables. It can implement a Boolean function of 2 variables without using any extra gates. Right, and yeah, this is just we have calculated 5 into 10 power 7 is the rate of addition correctly specified. This can be as the MSQ question. The correct answer for the MSQ question here is B and D. You get full marks, you get 2 marks if you select both of them. If you miss any one of them, yeah, if you choose any other incorrect answer also, you get 0 marks. There is no negative marking also, right? Suppose somebody selected A and C, opposite select kar liya. Somebody selected A and C opposite, then also you get 0 marks only. If you select only B, suppose you selected only B, right? Then also there is no marking, no partial marking also. No partial marking also allowed, right? So it is A, it is B and D, then only you get the full marks. Otherwise, no partial marking, no negative marking. ऐसा नहीं कि आधा number मिल जाएगा. No, you're not going to get that. Be careful, right? Be careful. चलो, next है. Right. Next, let us take up the question. Now, as we know, digital weightage is very low for electrical. So it was a 3 marks, 1 mark and 2 marks, 3 marks for digital. Let's go to EMFT, whose weightage is slightly increased from the past 3-4 years. Okay, so electromagnetic theory. Number 1, the value of the capacitance. As you know, capacitance is an important area for electrical especially. The value of capacitance of spherical shell consisting of 2 concentric sphere of radii 60 mm and 80 mm with the air as the dielectric. okay, is given by what? So what is the formula for capacitance of the spherical, concentric spherical capacitor? It is given by the formula 4 by epsilon upon 1 upon A minus 1 upon B, where A is the inner radius, right? A is the inner radius, 60 mm, and B is known as the outer radius, that is the 80 mm. Okay, and air as the dielectric, and because air is the dielectric, epsilon will be taken as epsilon naught. Let me just place down these values. 4 pi epsilon naught can be taken as 1 upon 36 pi 10 power minus 9, so that pi cancel, or you can also use 8.854 10 power minus 12 divided by 1 upon A का value है 60 mm, 60 10 power minus 3 minus 1 upon B. So 10 power minus 3 को ऊपर सेंड करते हैं, 1 upon 4 and 36 cancelled, 1 upon 9, 10 power minus 9, 10 power minus 3 भी ऊपर गया तो 10 power minus 12 divided by 80 minus 60, 80 minus 60 20, and 60 into 80 को भी ऊपर शिफ्ट किया तो it's multiplied by 60 and 80. Just solve it up. It's cancelled as 4. This is 4 into 60, 240, so it has to be 240 divided by 9, 10 power minus 12 farad, and they are asking in terms of picofarad. Okay, so 10 power minus 12 is already there. So what is the value of this division? 240 by 9, 26.67. Okay, so this is 26.67 picofarad. 26.67 picofarad. The correct answer for the NAT question here is 26.67. Simple one, a simple calculative question. Spherical capacitor. It's on a spherical capacitor. Okay, done. 26.67 picofarad is the answer. Let's move ahead to the next question then. Let us move ahead to the next question. A charge of 2 microcoulomb is placed at A equal to 10 centimeter from an infinite grounded conducting plane sheet. The total work required to move the charge slowly to an infinite distance from plane. Okay, infinite grounded conducting plane. As soon as there is an infinite grounded conducting sheet given to you, okay, the question takes you towards method of images. That is what directly should click into the mind. Method of images. This is a question based on method of images. Okay. So, look into this, guys, everybody. A charge of 2 microcoulomb is placed at 10 centimeter from an infinite grounded conducting plane sheet. What is the total work required to move the charge slowly to an infinite distance from the plane? Infinite distance from the plane. Come on, everybody. 2 marks MCQ question again. Tell me. Okay, you can also again be on mute and let me draw the picture. There's an infinite grounded conducting metal sheet. And there is a charge of 2 microcoulomb which is placed at a certain distance, and that is given to you as 10 centimeter. Okay, let's say this charge is equal to some charge Q. Okay, now as per the method of images, how do you approach this problem? We create an equivalence of this problem by removing the grounded plane, by removing this infinite conducting grounded plane, and assume it to be mirror, and this mirror will create the reflection. It will create the image charge. If this is the charge of Q, there will be a charge of minus Q, and since I'm calling it as image, so if this distance is the 10 centimeter at a symmetric distance, that is 10 centimeter below the sheet, 10 centimeter below the sheet, there will be a charge which is equal in magnitude but opposite in sign. That is known as the image charge. That is known as the image charge. That is known as the image charge. So this becomes the minus Q. Okay. Now, what is the total work required to move the charge, the same charge, slowly to infinity from the plane? It's moving to infinity. Okay. So let's say this is some point P. The question is actually asking you what is the work done in moving the charge from infinity to P. Nahi, from the particular point to the infinity, and that is given by the formula work done is Q into potential, because potential is work done per unit charge, and this has to be Q into V infinity minus Vp. V infinity is 0 by default. Okay, so this is minus Q Vp. Now let's place down the value. let's place down the value minus of q vp. What is the value for vp actually? अच्छा, what should be the formula for vp? ये यहीं पे लिख देते हैं. Potential at the point. Now forget the grounded plane. Let's look into the equivalent picture. Yes, Surajit, very correct. Crazy machine, very correct. Very good. Right. What is the potential at this point? Can be taken as the potential at the point due to the image charge. Now this has been removed. This sheet is removed. There is no sheet. There is only an image charge. So what is the potential at the point P? You can calculate this as the potential at the point P due to the charge, due to the minus q wala charge, due to the image charge actually, right? Due to the image charge, and the formula corresponding to it is, formula for potential due to point charge is kq by r. K minus q by r, the charge is minus q. Okay, now let me just write down the values, right? Minus minus plus ho jayega, the value of q, so it's directly k q square by r. The value of k, 9 into 10 power 9. I directly use it. Otherwise, you can write down 1 upon 4 pi epsilon naught as well. Okay. Multiplied by q square. Q का value है 2 micro. Whole square divided by the distance. Now, actually, what is the distance? The total distance is the 20 centimeter. You have to take care about that. The total, it is a distance of 20 centimeter, 20 10 power minus 2. Right. So, this is 10 power minus 3. Cancelled with 10 power minus 2, so 10 power minus 1 से cancel होगा, तो 10 power minus 2 will still be left. And what else is left? One of the 2 is cancelled. 9 2s are 18. 18 into 10 power minus 2 joules of work, or that is 0.18 joules of work. 0.18 joules of the work. 2 marks question based on the method of images. A 2 marks question based on the method of images. A 2 marks question based on the method of images, electromagnetic. Next question, guys. Number 15. Number 15 again from electromagnetics is like, an infinitely long wire carries a current of 100 ampere along the z-axis. What is the total magnetic field passing through the surface bounded by rho between 0.1 says 0.01 to 0.1 and z is between 0.06 to 0.6. All right. The current is along the z-axis. There is a current which is along the z-axis. Let us say this is the z-axis. Okay, this is the z-axis. The total magnetic flux passing through the surface which is bounded by the radius rho. Rho is the perpendicular distance from the z-axis and z will be the z coordinate itself, and rho is 0.01 to 0.1. Rho is 0.1 to 0.01 to 0.1, sorry. Okay, so it's going to be a constant phi and it's going to be a rectangular sheet because just show, oh sorry, इसको ऐसा नहीं लेते हैं. Let's say z-axis पे this is 0.06 and let us say this is the 0.6. यही था ना? Correct. This is 0.06 and rho, which is the perpendicular distance from the z-axis, 0.01 up to the 0.1. 0.01 up to the 0.1. Right. So comprising all of this, what is that you're actually going to get here is a rectangular sheet. Okay. Now, what is the current? इसकी भी बात करते हैं. Current is a current of 100 ampere, which is flowing along the z-axis, and it's an infinite long wire. First of all, for an infinite long wire, the magnetic field H, the magnetic field intensity H is given by the formula I divided by 2 pi rho A phi. I divided by 2 pi rho A pi, and then we can write down the formula B is equal to mu into H. We can write down B is equal to mu H, right? If nothing is mentioned, of course, we'll take mu naught, air as the medium. Okay, and the total magnetic flux. Surajit has the answer. The total magnetic flux. What is going to be the total magnetic flux? The total magnetic flux is the surface integral of B. The surface integral of B, right? And it's going to be, what is the B? Calculations exactly at the last. It is I divided by 2 pi rho A phi, right? Right. What about ds along the A phi direction? Yes. What is the ds? What is the ds? ds is given by ds a n cap, and what is a vector normal to this surface? Right, since it's phi equal to constant, so vector normal to it is going to be in the A phi direction. Okay, it's going to be in the A phi direction only, and the magnetic field is also in the phi direction. तो यहाँ पे इसको place कर देंगे. अच्छा, one more thing. What is the ds then along the phi direction? It's going to be d rho dz. Cylindrical coordinate system के correct parameters use करते हुए, it's going to be d rho dz. So I'll place down that value here. D rho dz A phi, and let's solve the double integral here. Okay, so A phi dot A phi is 1, I divided by 2 pi outside, sorry, mu naught I, B rakha hai na, mu naught I, B is mu naught into H, 1 upon rho with d rho integral will be ln rho, dz integral will be z, z is 0.06 is 0.6, right, and rho is equal to 0.01 is 0.1, okay, so the value mu naught is 4 pi 10 power minus 7, divided by 2 pi, I का value है 100 ampere, right? Ln of 0.1 minus ln 0.01, तो directly ln 10 log of A by B, and Z is 0.6 minus 0.06, so 0.54. Just complete this calculation. Okay, let's quickly do that. How much is the answer coming up? 4 pi, 2 pi also cancelled. This is 200, and then log of 10 and multiplied by 0.54, 248. कितना है 248.6 248.6 10 power minus 7 Weber. It's flux measured in Weber. They are asking in the unit of micro Weber, micro milli सब कुछ है, but yeah, we are able to with this value convert into micro Weber. तो 10 power minus 1 divide किया 24.86, 10 power minus 6 is the micro. So 24.86 micro Weber. Correct approximately. It's option number C. It is the option number C, everybody. This one is the option number C. Okay. Chalo. Next question, moving ahead. Right. So these are good questions that you can, standard good questions from the magnetism. Now, control system, guys. Question number 16 now starts from control system. And for the signal flow graph shown below, what is the graph determinant delta? Simple one, the graph determinant delta. The graph determinant delta. Okay. Clearly you can do this very quickly. फटाफट से बोलेंगे how many loops are there. If I just want to write down the count of the loops, keep solving parallelly with me. Okay, you can put me on mute as well and keep solving parallelly. Okay, the loop number one is clear, right? B and minus C, B multiplied by minus C, which is the minus BC. Loop number 2, this is also very clearly seen. F is multiplied by minus G, the branch F and the branch G, so minus FG. And the loop number 3, is there any loop number 3? Yes, there's going to be a loop number 3. See, if you start from here, C, then you take J, then you take minus G, and then you take I. Okay, so that is minus C, then I traveled J, then I had minus G, and then I had the I. So minus cancelled, C, J, GI, right? अच्छा, also at the same time आप लोग का आंसर हो गया होगा. See, you don't have to describe this much to somebody. Okay, I'm just writing it for your convenience. Out of this, L1 and L2 are clearly non-touching to each other. L1 and L2 are clearly non-touching to each other, right? और ये जो L3 है, I'll just highlight this separately. This is what is the L3 so that you remember it. Okay, this is the L3 that we have taken here. Okay, signal can only flow in the direction of arrow, ये ध्यान रखते हुए. Okay, now tell me what's the answer. So what is the graph determinant delta then? The graph determinant delta is 1 minus sum of all the loop gains, right, plus the product of non-touching loop pairs, if there is any non-touching loop pair. So yes, this is non-touching, so product of minus BC and minus FG, right? Right, L1 and L3, ये L3 का भी पार्ट है, ये L3 का पार्ट है, तो L1 L3 are touching, L2 L3 are touching, so no other non-touching pair. There is no other non-touching pair. So it is 1 plus BC plus FG minus CGJI, and this is also plus BCFG. Right, 1 plus BC plus FG plus BCFG minus CIGJ. Yeah, whatever you arrange is D. Some of you are confused between C and D just because of a plus minus sign. See, it's D. It's going to be D. It's going to be D. 1 minus sum of loop gain. So it's going to be D. Right? Yes, Surajit, it's going. No, it's going to be D, Surajit. Check it out once again. Check it out once again. 1 minus sum of the loop gains, and the loop gain CIGJ is positive. Minus C and minus G cancelled, and that is why it is the positive, Surajit. Okay, that is the option number D. Just check it out once again. It is the option number D. चलते हैं next question की तरफ. 1 mark MSQ question. 1 mark MSQ question. It is the 1 mark MSQ question. Okay, so what we are going to get here? Which one of the following statement is true about the proportional controller? Right? Yes, Surajit. No issues, guys. Let's just keep learning. Which one of the following statement is true about the proportional controller? Assuming unity feedback, standard unity feedback system, which one of the following is true about the proportional controller? Right, proportional controller which has the gain, constant gain given by the KP. Right, correct. Constant gain given by KP. Done. Which of them is the correct option? The controller transfer function is a complex variable. No, it's a constant. It's a constant value. It's a constant value. No, this is wrong. It would lead to zero steady state error. No, it is going to reduce steady state error. Okay, sometimes if it was zero, it will remain to be zero, but it doesn't change the type, so it cannot make it zero. अगर कोई पहले से zero था, तो it would be zero only, but usually it will reduce the steady state error. The steady state error will be proportional to 1 by Kp actually, but it cannot make it to zero. So this is also wrong. The control input. Okay, let's say the control input at this point, इसकी बात कर रहे हैं. Okay, is inversely proportional to the error? No, actually that control input is proportional to the error signal, and that is where we get ut is equal to kpet. Ut is equal to the kpet. Okay, so it's directly proportional. So the control input at any instant of time, is dependent only on the value of the error at that instant of the time. Yes, it is the D. C be wrong. It is not inversely proportional. It is not inversely proportional. It is directly proportional. It is directly proportional. So what is the correct answer? D. Now you will say, sir, how it is MSQ question then? Then how it is the MSQ question, you will be thinking, sir, how it is the MSQ question? So guys, why not? Why not? Why not it can be MSQ question? What is MSQ question? Multiple select question, clearly mentioned by IIT. Intentionally as a question liya hai where one option is correct. Clearly mentioned by IIT that one or more options can be correct. So you need to know these questions as well. MSQ question is one in which one or more option can be correct. One or more. एक या एक से ज़्यादा. So it may be possible only one option correct. That is where the MSQ questions can catch you. That is why they are tricky. Sometimes we get only one option, and it's a normal psychology that if you're getting only one option and it's a MSQ question, you will rethink 2 times at least कि भैया कुछ मैंने मिस किया है क्या. You will rethink. It's a psychology. So be aware that this can happen. Just be very confident about your concepts. Okay. So D is the only correct answer for this MSQ question. D is the only correct answer for this MSQ question. Yes, Surajit. Yes, correct. बहुत बढ़िया. Let's move ahead to the next question now. It's a 2 marks NAT simple question. Simple question, 2 marks NAT. For the closed loop system with the open loop transfer function GSHS 25 upon S plus 5, if the system has unity negative feedback, what is the value of TR by TP? What should be the value of the TR by TP? What should be the value of TR by TP? Tell me. What should be the value for TR divided by TP? Right. Rise time. Pi minus phi by omega D. Peak time is given by the formula pi by omega D. So what is the TR by TP, dear? When you divide omega D to cancel. So it is pi minus phi by pi. Finish. It is pi minus phi by pi. What is the value of phi? What is the value of the phi? What is my characteristic equation? 1 plus GSHS equal to 0. S square plus 5S plus 25 equal to the 0. Right? S square plus 5S plus 25 equal to the 0. Right? तो ये आ गया 2 zeta omega n is 5 because this is the omega n square and this is 5. So from here clearly zeta is 1 by 2. Zeta is 1 by 2 and zeta is also known as the cos of phi. That means phi हुआ 60 degree, cos 60 degree is half. Cos of 60 degree is half. Right? Here put down in radians, 60 बोले तो pi by 3. Pi all cancel, 1 minus 1 by 3. Your answer is 2 by 3. Numerical answer type question, 0.67 is the answer. 0.67. This is the 2 marks NAT. 0.67 is the answer. ठीक है dear? 0.67 is the final answer. 0.67 is the answer. 0.67. Done. Chalo, done. Next question, guys, ready for you here is the value of K1 and K2 so that MP with unit step input is 0.25 and the time to reach first peak is 0.8 second. Tell me. The time to reach first peak is 0.8 second. Okay. And MP is 0.25. Quickly. Keep solving with me parallelly. Sure. चलो, let's check it out parallelly. Okay, first of all, इसका characteristic equation अगर बना लें, so that is going to be 1 plus GSHS equal to 0. So if I solve it up, this is going to be S square plus 2S plus K1 plus K1 K2S equal to 0. अच्छा. That means this is S square plus 2 plus K1 K2, 2 plus K1 K2S plus the K1 is equal to 0. Okay. So now K1 is omega n square, 2 plus K1 K2 is 2 zeta omega n. But what is zeta? What is omega n? For that we'll have to use zeta directly can be obtained by overshoot. What is the overshoot given to you? With the unit step input here, 0.25. Right. So what is going to be the zeta? See now, you can I can use this formula e raised to the power minus pi cot phi. Okay. And then calculate the zeta from there, or else you can directly apply the zeta formula. That is minus log overshoot divided by under root of pi square plus log MP whole square. It's not always suggestible to remember all formulas. If you remember the zeta formula in terms of overshoot, you can use this. Or MP is given from here. You can first calculate cot phi. Phi आ गया तो zeta is cos phi. So either ways you can do. Either ways you can do. ठीक है. Directly भी कर सकते हैं और यहाँ से वो भी कर सकते हैं. Right. यहाँ से first you can find phi and then zeta will be cosine of phi. ठीक है, zeta will be cosine of phi. So that is also one option. यहाँ पे अगर if I put down the value minus log of overshoot 0.25 divided by pi square plus ln 0.25 whole square का under root. Tell me dear. Let's calculate this. Let's calculate this everybody quickly. Yeah, nearly 0.4. So solving this, zeta is approximately coming to be 0.4. ये तो zeta आ गया. Now this is overshoot. What is the next thing given to you? Time to reach the first peak. Time to reach the first peak, TP, which we have just used in the previous question also, pi by omega d, and that is equal to 0.8. That is equal to 0.8. So what is omega d? Okay, which is omega n under root 1 minus zeta square is pi by 0.8. Solving it, यहाँ से omega n आ जाएगा. Let's calculate that as well. Yeah, this turns out to be 4.28. Just keep checking the calculations once, है ना? 4.28 is the omega n, and that is why k1 आ जाएगा and 2 plus k1 k2 आ जाएगा, right? So what is the k1? Is omega n square, इसको लिख लेंगे, and then 2 plus k1 k2 is equal to 2 zeta omega n. Okay, so 18.3 nearly. This is 18.3 and then 2 zeta omega n. Omega n 4.28 था. This is 3.424. Right. Subtract 2 and divide by the K1 obtained. 0.077. 0.078. Okay. So 18.3 and 0.078. Approximately option number C. Approximately option number C. Yes, Surajit. Correct, guys. It is the option number C. It is the option number C. चलो चलते हैं next question की तरफ. It's option number C. The next question here is on the screen. The Bode magnitude plot of an open loop transfer function of a certain system is shown below. A very simple question on Bode plot. If the system is of minimum phase type, then the open loop transfer function GS. Then the open loop transfer function GS will be. Very clearly the initial part is parallel to x-axis. The number of poles at origin is equal to 0. N ka value 0. Initial slope 0, so n is equal to 0, right? And the initial part magnitude formula, which is given by minus 20 n log omega plus 20 log k. This is a quicker way to obtain the value of k. This is a quicker way to obtain the value of k. Initial part ka magnitude actually constant hai because n is 0, so that is 40, and this part is 0 plus 20 log k. So first of all, what is going to be the value of k? ये हो गया 40 by 2 and k is equal to 10 square. K is going to be 100. You keep solving parallelly, है ना? You don't listen to me. Keep solving parallelly. We have to come to the common answer. Okay. So k is going to be 100. Now, what is that you get here? Slope change of minus 40. So this has to be 2 poles, right? Slope change minus 40 says 0. So increased by 40. So 2 zeros. Again minus 40. So 2 poles here. Minus 40 to minus 60. Single pole here. Single pole here, right? Okay. And the time constant is 1 upon corner frequencies. All of these are corner frequencies. So in the standard form, okay, पहले standard form लिखेंगे because I have the k of the standard form, and then I'll get the non-standard S plus A format. Okay. Definitely there is only a 0 at 20, and that is a repeated 0. So S plus 20 whole square in the numerator. ये तो wrong है. बाकी सब जगह S plus 20 whole square. The rest all is matching. So now let me write down quickly GSHS. Quickly GSHS. K, which is 100. 1 plus st. Time constant is 1 by omega c. 0 is at 20. 0 is at the corner frequency is 20. So 1 by 20 ka whole square. 1 plus s by 20 ka whole square, because it is the two zeros. Divided by, coming to the pole terms, 1 by 1. 1 plus s by 5. S by 5 whole square, because that is also a double pole. Next है 40 पे pole. So 1 plus s by 40 whole square. Next है 1 plus s by 100 power 1, because it is a single pole. Then now only thing you have to manipulate the constant 100 divide by the 20 square. Denominator से आएगा 5 square 40 square into 100 into 100. Then you are left with the expression. Numerator s plus 20 whole square, denominator में s plus 5 का whole square, s plus 40 का whole square, s plus 100 की power 1. Okay, how much is this value equal to? ये फटाफट से करेंगे. 40 by 22, 2 square is 4, 4 into 25. ये तो पूरा आ गया. This value, if I write down this value separately ना, this is turning out to be, once again, this was cancelled as 2, 2 square 4, 25 for 100, 10 power 6 होना चाहिए. So it's only 10 power 6. It's option number C. It is option number C. Done है. Shubham Dayal, Surajit, correct answer. It's option number C. I hope you have given for this one only. Previous का भी C था. Right. Done. It's option number C. Very quickly करना है. This is how you can approach this question of Bode plot quickly. Next question पे चलते हैं. Right. Next question पे number 21, coming up from root loci. Consider the open loop transfer function of a unity feedback system GS equal to k s square minus 6s plus 10 upon s square plus 6s plus 10 for k less than equal to 0. What is the angle of arrival of the root loci at the zeros, at the complex zeros? Angle of arrival at the complex zeros. Yes guys, let's do it up. Consider the open loop transfer function of a unity feedback system GS equal to k s square minus 6s plus 10 upon s square plus 6s plus 10 for k less than equal to 0. What is the angle of arrival? देखो, what are the zeros actually? First of all, if I want to discuss about the zeros, that's going to be s is equal to minus b plus minus root over b square, 36 minus 4ac, that is 40, divided by 2a, that's 6 plus minus under root of minus 4 is 2j, divide by 2. So the zeros are actually 3 plus minus j. So poles s is equal to, only difference is 6 replaced by minus 6. So minus b में ये minus 6 आ जाएगा, divide by 2, it is going to be minus 3, rest is same, plus minus j. Right? Okay, it's minus 3 plus minus j. Yeah, it's injured right now from past 8 to 10 days, but no problem, we are all managing, Nitin. So 3 plus minus j and minus 3 plus minus j. That is the complex zeros and complex poles. And let us take about the quick method of solving that angle of arrival. How can you deal with this one quickly? एकदम quickly कर लेते हैं. So we have the zeros which is in the RHP, 3 plus minus j. Right. This is 3 plus j and roughly this is 3 minus j. The poles are in the left half plane. Okay. इसको मुझे ओरिजिन से पास करा लेना चाहिए। अरे भाई, just wait some. Okay. Right. Thank you, Nitin. Hope you learn something and hope you're able to perform in the mock test. Now, what is the angle of arrival? Dear, what is the formula that you're going to apply here? Angle of arrival formula. Be very careful. This question, NAT question especially, this can make you commit the mistake. This can easily make you commit the mistake because if you don't notice this condition, k less than equal to 0, right? K less than equal to 0, it is the root locus for negative values of k, signifying complementary root locus case. It is the root locus for negative values of k, signifying complementary root locus, and that is why your angle of arrival will be minus of phi z minus phi p. If it was the regular root locus, okay, if it was by chance the regular root locus, then you use the formula 180 degree minus of phi z minus phi p. See, this is the shortcut. You can also calculate by the concept of angle GSHS is equal to even multiple. This is complementary root locus, even multiple of 180 degree. But this is the direct, quicker way of calculating the angle of departures or arrival. हमें ये वाला formula यहाँ पे use करना है complementary root locus के लिए. Now, what is the phi z? Right? What is the phi z? Everybody. Okay, we are calculating the angle of arrival. Suppose for this pole. For this 0, okay, दूसरे वाले का नेगेटिव हो जाएगा. Okay, what is the angle of arrival here? So everybody, the angle of arrival, first I calculate phi z, and phi z is the sum of angles subtended by the other 0, and that is clearly a perpendicular line, vertical line 90 degree होगा, right? 90 degree. Then what is the phi p? Phi p, sum of the angles subtended here by the remaining two poles. So let's say this is phi p1 and phi p2. Okay, what is phi p1? Let's say this is the pole number 1 and this is the pole number 2. What is the angle subtended by the pole 1? It's a line parallel to x-axis, so 0. Line parallel to x-axis. What is the angle subtended by this one? Okay, ये हो गया phi p2. What is the angle subtended by the pole 2 with respect to this 0? Okay, it is tan inverse height divided by the base. Height 1 unit है, base 3 unit है. Correct है, tan inverse 1 by 3. And how much is this value? Let me write down this quickly. एक बार निकाल लेंगे इसको तेजी से. 18.44 approximately. This is 18.44 degree. So the net phi p is 18.44 degree. So dear, what is going to be the angle of arrival is complementary root locus case, very important. Complementary root locus case, minus of phi z minus phi p, तो minus of 90 minus 18.44, तो ये was 72, 71.56, minus 71.56 degree. Okay, now this is the angle of arrival for the complex 0 3 plus j, that is minus 71.56 degree. So dear, angle of arrival for the conjugate 0 3 minus j is going to be same in magnitude but opposite in sign. No need to calculate that separately. It's plus 71.56 plus 71. Some voice issue suddenly came. Chalo, anyways, I'm done with my part. No. So what is the answer? Plus minus 71.56. Plus minus 71.56 degrees. They have specified plus minus clearly. Okay, that is why they didn't specify with 0. Okay, if they specify what particular 0 they are looking for, so then they can expect the answer with the sign as well, whether it is minus 71 or plus 71. This is a root locus 2 marks numerical answer type question. Please pay attention about this one. Okay, otherwise your answers can go wrong and there is no option to save you because it is the NAT type question. Because the k is less than equal to 0. Everybody done? Right, so these are 21 questions from my part. Guys, a quick update that tonight, right, all ECW. You can inform to your EC friends as well that tonight all your favorite faculties of ECW, we are going to come live together 8 p.m. tonight at 8 p.m. to talk about a smart strategy for the remaining 45 days. A smart strategy for the remaining 45 days. Everybody, do not forget to join live on the same channel. Okay. Chalo, yes, Surajit, you added 360. अब इस पे भी मैं comment करता हूँ. Okay, I'll just comment on that. Okay, guys, the same channel. Do not forget to subscribe in case you haven't subscribed, right? Because it's the end game going on. What should be your perfect and smart strategy? Okay, for this. And then tomorrow, guys, 18th December, that is just tomorrow, we are starting the very special GATE PYQ series for you to cover up past 5 years subject-wise live discussion of the question. In case you haven't still done the PYQs, in case you have some doubts, you want new approaches, you want live interaction of the 5 years PYQ, you can join live tomorrow. Tomorrow will be the first session of control system at 6 p.m. Okay, for the control system at 6 p.m. Okay, and questions of PYQs will be covered. Yes, Surajit. So you have added 360, correct? By 360 add to kar sakte hain. Okay. And it's a NAT question. You can add or you can subtract 360. It is mathematically correct. An NAT question, there isn't any option. But by default, what is the answer you should enter? Think about that. Principal argument. What is the concept of principal argument? Right. What is the concept of principal argument? So 360 minus 71.56 is some answer that you are giving. ये कितना आ जाएगा? This is 288.44, right? That is what you are giving, I think. Correct? But, and there is no option mentioned, so you might feel that this is also correct. But is this the principal argument? If not, nothing is mentioned. By default, enter the principal argument. Acha, what is the principal argument? The angle in the range of minus pi to pi, minus 180 to 180. That is the principal argument. Okay. The phase which is in the range of minus 180 to 180 is the principal argument. So, ये ध्यान रखना पड़ेगा Surajit. So, if nothing is mentioned, please do answer the principal argument only. And the principal argument is between minus 180 to plus 180. And now, guys, within 1 minute, here I invite Ashu Jhangra Sir to take up the next subjects. All be ready. Okay, I think next what is going to come is network. Okay, and within a minute or so, guys, just don't worry, maybe a 10 seconds of buffering will be there when we switch it. Okay, Okay, so do not panic, do not worry in that time. Let me just call up Ashu Sir, and here it is.
जी कर दिया. Okay, everyone. So good afternoon, and I hope everyone is fine there. So you enjoyed control system with Rakesh Sir, and now it's time for the network theory. Okay, so I hope audio and video is clear to everyone. So in my part, I'll try to solve network theory and power electronics. So first we'll start with the network theory. So let's start solving the questions, guys. But let me tell you, please tell your juniors about GATE 2024. There is one mega workshop which is going on 18th December, again with Rakesh Sir, so they can be benefited. And from 18th of December, we are going to start a PYQ series. So it will be a live series, so you can join this series also, where we are going to solve some questions like past 5-year questions. We'll try to solve. Okay, and there is one mega mock test for 2023, so you can register now, and you can register up to 20th December. So the link is given in the description. So let's start the session, guys. So we have the network theory now. Okay, start with the first question. The first question is in front of your screen. So now there is a correction in this question. So let me first tell you about the question. Actually, the height is changing between 10 and minus 10, but this point is at 1 second, this point is at 2 seconds, this point is 3, this point is 4, this point is 5, 6, 7, 8, 9. So actually the axis given is not correct. This point is 2, this point is 3, this point is 4, this point is 5, this point is 6, this point is 7. Okay, so be careful, and we need to calculate the RMS value of this signal. Now you know that the period of this signal is 6. The period is 6. So maximum student will apply the formula for RMS, and the formula is 1 by 6 integration 0 to 6 ft mod square dt and take the root. This is the formula for RMS. But this is very lengthy formula, guys, because up to 6, if you try to solve it, then it will be very lengthy, because you have to break this integration into 0 to 1 and then 1 to 2, then 2 to 4, then 4 to 5, 5 to 6. It's a lengthy process. But this is a 1 mark question. So obviously we have to solve in less number of time. So how to do it? How to solve it in less number of time? What you can do is you can rectify this signal. If you rectify the signal, RMS will not change. Now let's rectify the signal. If you are going to rectify it, the signal will look like this. The signal will look like this. Now the time period is decreased. This is 0, 1, 2, 3, 4, 5 and 6. Now you can see that the time period is 3 now. Again, it's a lengthy process. Because up to 3, you have to break 0 to 1, 1 to 2 and 2 to 3. Again, it's a lengthy process. So what we can do is we can further do some manipulation like this. What we can do is, at 1.5, you can see that about 1.5 it's symmetric. About 1.5 it's symmetric. You can see that. So what I'm doing is, this is 1.5 and this is 1. What I'm doing is I'm drawing the wave like this. This is 10 height. From 1 to 1.5 it's constant. Now what I'm doing is I'm flipping this part. If you flip this part, it will become like this. Up to 2.5 and then up to 3, it will be like this. Okay. So what I have done is I have flipped this part. Okay. So the wave will look like this. And then again from 3 to 4, it will be like this, and then again. Okay. So what I have done is I have flipped this part. And if you can flip this part, RMS will not change. But the good thing is, now it will be simple. Now it will be simple to calculate. Now it's simple to calculate its RMS value. How to calculate? It's very simple. The period is 1.5 now. Look, from 6 period, we came to the period 1.5. Now the period is 1.5, and if you look at the equation of this line, then the equation of this line is 10t. So the RMS value is 1 over 1.5. Now we can integrate from 0 to 1, 10t square dt, plus from 1 to 1.5, height is 10. So 10 square dt. And you can take the root. This will be the RMS value. Okay. So this way you can make this question very simple. Let's try to calculate this value. So it's 1.5. From this side and this side, you can take 10 square common. And here you have t square. And the integration of t square is t cube by 3. So if you put upper limit minus lower limit, it will be 1 by 3. Plus, here you have 1. So if you take 1 dt, then the integration will be t, upper limit minus lower limit is 1 by 2. Is it fine? So this will be the RMS value. Now you can calculate this value. Let me calculate for you. So it will be 100 divided by 1.5, and it's 1 by 3 plus 1 by 2. Okay. So the value came out to be 7.45. This is 7.45. Okay. This was 1 mark question. Okay. I hope you can solve it. So 7.45 is correct. Subham Dayal, Ravi, Surjit. Very good. So answer is 7.45. But look how simple we made this question. First, we are looking at this period, 6 period. 6 period is very large. So it's very difficult to integrate this part, no? Because you have to write equation for this line and this line. And again, you have to break from 0 to 1, then 1 to 2, 2 to 4, then 4 to 5, 5 to 6. So what we did is we rectified it. With rectification, RMS will not change. Now, the good part is after rectification, the period is 3 now. If the period is 3, then again you have to integrate it up to 3. 0 to 1, 1 to 2, and then 2 to 3. Again, it's a lengthy process. So what we will do is, we will further at the middle of this period, it is 1.5. If you can flip this, the front wave is repeated again. Now you can see that the period is again half. It's half of this 3. So you can say the period is 1.5. Now it's very easy to solve. Okay. So this way you can solve this. Okay. So I hope you understood it. So it's very simple. Okay. And the RMS value came out to be 7.45. Let's come to the next question. So this was 1 mark question, guys. Let's come to the next question. And the next question is, let me change the slide. Yes. Next question is this. Again, it's a 1 mark question. In this circuit diagram, it is given that this point is A and this point is B. This is not A, by the way. Let me remove this. This point is not A. Okay. So actually this point is A and this point is B, and we need to calculate VAB. Let me check the original file. So that I can verify the question. So please solve it, guys. Please try to solve this question. Yes, the point A and the point B. I think it's correct. So please solve this question. It's very simple. Try to solve it. We need to calculate AB, VAB, VA minus VB. Now you can see that in this circuit there is no independent source, but it doesn't matter because these quantity V0 and I1 are decided by this circuit. You can see that. So you can say that we can solve this circuit now. So first we'll solve this circuit, and then using this circuit we'll come to this part. Is it fine, guys? So let me correct this question because there are some correction. I think there are some correction in this question. This is not V0, by the way, because there is a typing mistake. I'm looking at the original file. So this point is not V0. Okay, this point is not V0. This is just only 5 ohm. So now we need to calculate VAB. So how to calculate, guys? Let's solve it. First of all, we need to solve this circuit. Apply KVL in this circuit. If you apply KVL in this circuit, calculate this I1 using KVL. So let's apply the KVL. So if I apply KVL, it will be 20 plus 4 V0 minus this drop. This drop will be 5 I1 because I1 is coming like this now. So wherever it enter, it will be plus, wherever it leave, it will be minus. And this will be 15 I1. So if you write KVL in this loop, then it will be 20 plus 4 V0 minus 5 I1 minus 15 I1 equal to 0. Okay, and this is the KVL for this loop. I hope you understood it. Now come to this circuit. In this circuit, current is fixed as 2 I1. This current is 0 ampere. We know that. Using KCL, you can say that this current is 0. So in this circuit, 2 I1 will circulate. Okay, now if this current is 2 I1, this voltage V0 must be equal to 4 I1. You can apply Ohm's law. This current is 2 I1. So you can say that the V0 will be 4 I1. Now what we can do is, we can put this V0 in this equation and we can calculate for I1. So let's try to put it. So 20 plus 4 into, in place of V0, I have 4 I1. 4 I1 or 2 into 2 is 4. Yes, that's correct. 4 I1. So it will be 4 I1 minus 20 I1 is equal to 0. 15 minus 15 minus 5 is 20 I1. Okay. So from here you can say that 20 is equal to, this is 16 I1, this is minus 20 I1. So it will be 4 I1 here. So I1 came out to be 5. I1 came out to be 5 ampere. If I1 is 5 ampere, then this current is 5 ampere. We know that this current is 5 ampere and V0 is 20 volt and this current is 10 ampere. Okay, because we have calculated I1. So using I1, we can calculate V0 also. We can calculate this 2 I1 value and this I1 value. It's simple. Now we start from this point A and we will go to the point B and we will apply the KVL in open loop, and then we can find the voltage, then we can find the VAB. Tell me guys, what is the answer? Have you done it? Have you solved it? Tell me everyone. Have you solved this question? Okay, you are getting D answer. Voltage across dependent source is unknown, sir. Voltage across dependent source. Which dependent source? There is no problem. Okay, let's try to solve this. So we calculated I1 first. Once you get this I1, then this current will be 10 ampere. Now, if this current is 10 ampere, this voltage will be of 80 volt. Since V0 is known to us now, V0 is 20 into 4, this will be 80 volt. Now, we know that this current is 10 ampere, so this voltage will be 100 volt. In this branch, there is no current, so this is 0 volt and this is 10 volt. Now, we know that this current is 5 ampere, so 5 into 15 is 75 volt. So this is 75 volt and this voltage is 5 I1. I1 we have already calculated 5. So again, it will be 25 volt, okay? So now what you can do is, you can start from this point and reach to this point and you can calculate VAB. Let's start from A point. So VA, we started from A point, VA plus 80, VA plus 80, minus 80, plus 100, minus 0, minus 10, come to this side, plus 75, and plus 25 is equal to VB. Okay, so we have written the KVL in open loop. Okay, now you can calculate VA minus VB. So VA minus VB will be equal to, you can calculate VA minus VB, that will be this is 90 and this is 100. Okay, so it's 190, and if you take this 190 on the other side, it will be minus 190. So the answer is minus 190. Answer is Calcutta. Okay, you can see that answer is Calcutta. Good morning, Abdul Razak. Good morning, everyone. Good afternoon. So answer is minus 190. Answer is Calcutta. I hope you understood this question. So it's very simple question based on KVL. Let's move to the next question. In this question, what is given is, we have a linear circuit, okay, and here the load is connected. In this load, we have this voltage VL and IL. This load is non-linear. It is given that a linear circuit is shown below. This is the circuit. Load is non-linear. This load is non-linear. The load characteristics are given as V is equal to 5I square. It means the voltage across the load will be 5 times of I square. Whatever the current through the load is, take the square of that into 5, will be the voltage across this load. Okay, so this is the load characteristics, guys. Now a table is provided for IL. For different value of VS and IS. We are going to change this VS and IS, and for different value of VS and IS, IL is provided to you. Now it is given that find the value of IL for the last case. This is case 1, this is case 2, and this is case 3. For the last case, we need to calculate the value of IL. What will be this IL? Okay, let's see. Remember, this load is non-linear, but this circuit is linear. If the circuit is linear, then we can replace this circuit with its Thevenin equivalent. So in Thevenin equivalent, we have RTH and VTH. Okay. So what we have done is, we have replaced this circuit with its RTH and VTH. This is my VTH and this is my RTH. Okay. Now we are not, we don't know this VTH and RTH. We have connected this non-linear load here. It is given that in the first case, this current is 2 ampere. Okay, if the current is 2 ampere, then the voltage across the load will be 2 square into 5. 2 square into 5 is 20 volt. It means this voltage must be 20 volt. Is it fine? Because the load characteristics is non-linear. It means whatever the current through the load is, the voltage across the load will be 2 square into 5. 2 square into 5 is 2 square is 4. 4 into 5 is 20 volt. Now, if you write the KVL in this circuit, in the first case, I'm solving for first case. In the first case, VTH is VTH and RTH, let's say RTH, and the current IL is 2 ampere. So this voltage is 20. So if you write the KVL, you will get VTH. You will get VTH minus 2 RTH is equal to 20 volt. Is it fine, guys? This is equation number 1. So we have calculated equation 1. Okay, we have derived equation 1. It's very simple. Now come to equation number 2. Come to case number 2. In case number 2, we have changed voltage and current. Voltage source and current source. And be careful this time. Voltage is doubled and current is also doubled. You can see that 5 to 10, 10 to 20. It means both the sources are doubled. If both the sources are doubled, then RTH will not change. The Thevenin resistance of this circuit will not change, but the open circuit voltage will double because you are doubling both the sources. You are doubling every source. If every source is doubled, then the Thevenin voltage will also be doubled. So you can say that in case number 2, RTH will remain same. RTH will remain same because RTH is independent of voltage Vs and Is. But the VTH will be double, 2 VTH. It will become 2 VTH. It will become 2 VTH. In case number 2, it will become 2 VTH. Why? Why it will become 2 VTH? Because we have doubled the voltage source and doubled the current source. It means input is doubled directly. Okay. So input is doubled. So you can say that it will become 2 VTH. Now I have connected a non-linear load here. And across this non-linear load, the current is 3. In this non-linear load, the current is 3 ampere. If the current is 3 ampere, then 3 square is 9. 9 into 5 is 45. It means this voltage is 45. So we can write the KVL equation for this circuit also. So if you write the KVL equation, then you will get 2 VTH minus this current is 3 ampere, na? Minus 3 RTH is equal to 45. I hope you understood it. Okay, this is my equation number 2. Now using these two equations, what you need to do is you need to calculate VTH and RTH. You need to calculate VTH and RTH. How to calculate this VTH and RTH? You just double it. You just double it. If you double it, it will be 2. It will become 4. It will become 4, and this will be 40. This will be 40. Is it fine? This will be 40. Okay, now if you subtract it, then it will become minus RTH is equal to minus 5. So from here you can see that RTH is equal to 5. Is it fine, guys? Tell me. So RTH is 5. It means we know this RTH. Now the question is, what is VTH? VTH you can calculate easily. RTH is 5, then VTH will be, you can put this RTH here or maybe in this equation. So it will be 15. 5 into 3 is 15. Take this 15 on this other side. So it will become 60 and divide by 2. So VTH came out to be 30. Okay, VTH came out to be 30. But this 30 is valid for case 1 only. For case 2, this VTH becomes 60. Okay, for case 2, VTH becomes 60. I hope you understood it. Now we know the RTH of this circuit and we know the VTH for case 1 or case 2. But in case number 3, voltage is tripled and current remains same. Now the circuit is like this. RTH is 5 ohm and VTH, this is VTH. VTH is unknown for the third case. We need to calculate this VTH, and here we have the load. In this load, V and I characteristics. V and I, whatever this V and this I, this V must be equal to 5I square. Okay, so we need to calculate this VTH, and this is not easy this time because we don't have two equations. VTH is 30 for this case and 60 for this case. So if we write the linearity equation on VTH, if you apply the linearity equation, then you can say that 30 will be equal to 10A plus 5B. 10A plus 5B. In the second case, you can say that 60 is equal to 20A plus 10B, but this is the same equation. So using the above equation, you cannot find VTH, because in the third case, you have 30A plus 10B. 30A plus 10B. We are not aware of A and B. We don't know about A and B. If A and B is not known to us, then we will not be able to calculate the VTH for the third case. VTH3, let's call it. So VTH3 is unknown to us. We can't calculate VTH3. If VTH3 is not known to us, then we can't apply KVL in this circuit and we can't calculate this IL. This is the problem with this question. Okay. So you can say that this is non-solvable. Okay. You can't solve it. You can't solve it because the problem is with VTH. The problem with VTH. We can't solve for VTH3. The third case VTH. If somehow we know the third case VTH, in third case, let's say if we know the VTH, then we will be able to solve this. Otherwise, we can't able to solve it. Okay. So this is the main reason behind this question. I hope you understood it. Okay. But you can write the KVL in terms of A and B. There is no problem. Otherwise, you can't solve it. Let's move to the next question, guys. So again, this is very, you can say, a typical question. And in this case, though you are not able to solve it, because whenever you design a good question, then you skip some point and you don't be aware of that. That's why this kind of mistakes came into picture. But anyway, this question was good and I hope you learned some new concept. Let's come to the next question. Next question is, look at this circuit. For a linear circuit shown below, the source power factor is unity. Here the source power factor is unity. Source is Vm sin omega t. Okay. And its power factor is unity. It means the current will be in phase with this voltage source. Current will be in this phase with this voltage source. Okay. This current will be in phase with voltage source. Now, find the power factor of the unknown linear circuit. We need to calculate the power factor of this circuit. How to calculate the power factor? Tell me, guys, how to calculate the power factor? Okay, look at the circuit and how to calculate the power factor of this circuit. It's very simple, guys. Look, we know that, let's say this is Vm angle 0 and let's say this current is Im angle 0. Now, this voltage will be Vm angle 0 minus this drop. If you write the KVL and if you look at this voltage, let's call it V1 and let's call it 0. So if you write for V1 will be equal to Vm angle 0 minus R into Im angle 0. Now you can see that this is 0 degree, this is also 0 degree. So this V1 will also have the angle at 0 degree. It means this voltage will be in phase with this source voltage. Because power factor is unity. Unity means current and voltage are in same phase. The source power factor is unity. So source voltage and source current will be in same phase. So you can say that if this is at 0 degree, then this drop will also be at 0 degree. So if you apply the KVL, then Vm angle 0 minus this drop will be V1. V1 will also be at 0 degree. V1 will also be at 0 degree. Okay. Now you can say that this voltage, this source voltage is at 0 degree. This V1 voltage is at 0 degree. And it is given that this current is 5 ampere. This lagging current is 5 ampere. Okay. This is my V1. This lagging current is 5 ampere and this current is unknown to us. But it is given that the sum of this current and this current has to be at 0 degree. It means this 10 ampere should be in this direction. This 10 ampere should be in this direction. So that if you take the projection of this current cancel and the resultant current came out to be in phase with V1. Because we know that the total current is Im. It should be at 0 degree only. It should be at 0 degree. So the sum of these two current should be at 0 degree. If I take this 10 ampere downward, then their sum will not be 0 degree. Will never be at 0 degree. That's why I have to take this 10 ampere upward. 10 ampere upward. Okay. So it means the power factor will be leading. So first of all, we know that this current will lead this V1. So it means the power factor of this linear circuit, the voltage across this linear circuit is 0 degree. V1 is at 0 degree and the current 10 ampere is leading. That's why the power factor will be leading. So either D is correct or B is correct. Either B is correct or D is correct. Now, what should be the power factor? We need to calculate the power factor. How to calculate? We know that the resultant current should be in this direction. The resultant current, the sum of this 5 and 10 should be at 0 degree. Take this angle as theta. If you take this angle as theta, then you can say that the projection of this 10 ampere on this side, the projection of this 10 ampere on this side will be 10 sine theta. And I know that to make the resultant current at 0 degree, this has to cancel with this. It means this 10 sine theta must be equal to 5. So this theta came out to be 30 degree. This theta should be 30 degree. Is it fine? If theta is 30 degree, then you can say that this current, the voltage across the linear circuit is V1 and the current is leading by 30 degree. So you can say that the power factor of this linear circuit is cos 30 degree leading, and cos 30 degree is root 3 by 2, 0.866. Answer is Bombay. Okay, so answer is Bombay. Very good. So many students have given correct answer. Ravi, Surjit, Subham, Abdul Razak, Ashok. Yes, good. Let's move to the next question. Let's move to the next question, guys. So this is the question. Here you have three-phase circuit. For a three-phase circuit shown below, IN, this current is given as 10 ampere. This current is given as 10 ampere, and VAN means this voltage. This voltage is 100 sine omega t. So let's call it 100 angle 0. Take sine as reference. So VAN is 100 sine omega t and the phase sequence is ABC. It means the B phase voltage will be 100 angle minus 120 and C phase voltage will be 100 angle plus 120. Okay, is it fine? So this way you can write. Now this is R, this is X, this is R1, this is R naught. Please write it R naught. Okay, this is R naught. Now the question is, it is given that this is 10 ampere and this IN is also 10 ampere. It is also given that X is equal to R by root 3. Here in this equation, X is R by root 3. Okay, it is given. Find the value of XC. We need to calculate this XC if R naught is 5 ohm. If R naught is 5 ohm, we need to calculate the value of XC. Okay, so again it's a simple question. Now, first of all, let's plot the phasor of these three voltage source. Okay, so VAN is at 0 degree, VBN is at minus 120 and VCN is at plus 120. Okay, so again this is VAN, this is VBN and this is VCN. Now we know that this current is 10 ampere. It means this current will be in phase with VAN. So I can say that, let me change the color. So I can say that this current 10 ampere is in this direction. This current 10 ampere is in phase with the voltage VAN. Okay, this current 10 ampere is in phase with VAN. Okay, now this is RX. This is connected across VBN because this is in parallel with VBN now. So you can say that VBN is applied across this RX load, this inductive load, and in inductive load current will lag. Current will lag the voltage. It means this current will lag this voltage by how much angle? What is the angle of this impedance? Angle of this impedance is, because this is R plus JX, and angle of this impedance is tan inverse X by R. You can calculate the angle like this, impedance angle theta Z. So tan inverse X by R, if you do X is equal to R by root 3, no? So if you put X, then you will get tan inverse of 1 by root 3. Now what is the value of tan inverse of 1 by root 3? That is 30 degree. It means you can say that this current IB will lag VBN by 30 degree. Is it fine, guys? Is it fine? So it will lag. Lagging means it should be in this direction. Should be in this direction. Okay? Lag means clockwise. So if I plot this current, this current should lag 30 degree. I'm not sure about this current value, but this angle is 30 degree. This angle is 30 degree. Okay, it is given that this angle is 30 degree because it's like in this direction, clockwise direction. Okay, so clockwise direction means it's lagging by 30 degree. Okay, so we calculated this current. This current is IB. Now we have this impedance now, R0 and JXC. We want the resultant to be 10 ampere. If the resultant is 10 ampere, then this current, IC current, should be opposite to this. Should be opposite to this. Is it fine? If this is 30 and this current is IB, this current should be equal to, this IC should be equal to IB, and it should be opposite so that they can cancel and the resultant current remains at 10 ampere. Is it fine? Is it fine? This way we can solve it. Tell me guys. Tell me guys. I think this way we can solve it. So the result, this current and this current will cancel and the resultant current will be, then you can say the resultant will be 10 ampere only. Now the question is, IC, what is this IC? How much angle it will lag from this VCN? How much angle it will lag? Because it is again clockwise direction. Clockwise direction means lagging. So tell me by how much angle it will lag. If this is 30 degree, then this angle is 90 degree, we know that, because the angle between VBN and VCN is 120. If this is 30, this should be 90. If it is 90, then it should also be at 90 degree. Is it fine guys? It means this current IC should lag VCN by 90 degree. Lag VCN by 90 degree. Now, it is not possible. Why? Because in this circuit, in this C phase, R0 is given as 5 ohm. R0 is given as 5 ohm. If it means there is a real resistance, there is a resistance. If you want that the current of this C phase lag by 90 degree, then it should be purely inductive load. Purely inductive load. It should be purely inductive load. It means this XC should come out to be minus of infinite. If XC is of minus of infinite, then you can say that it will become purely inductive. It will become plus J infinite. It will become plus J infinite. Okay? Because if you put XC equal to minus infinite, then it will become plus J infinite. So R is 5 ohm and X is plus J infinite. Then the angle will become 90. And the current will lag by 90 degree. Okay? So you can say that XC should be minus infinite. So what should be the value of XC? It should be minus infinite. Answer should be minus infinite. It will not be finite value. Okay? Answer should be minus infinite. Okay guys? So answer should be minus infinite. There is no other way to solve this question. In this question, if I place capacitor here, if this is negative, then it will be a good question. If I place minus XC here, if I place capacitor here, then it will be a good question. But anyway, this is the question and this is how it is, and the value of this XC should be minus infinite. Answer is minus infinite. Let's come to the next question guys. Let's come to the next question. Sir, VBN and VCN is of opposite polarity. No, VBN and VCN, you can say that they are 120 degree apart, na? Because phase sequence is ABC. Phase sequence is ABC. That's why they are 120 apart. Okay? So this way we can solve it. Anyway, let's move to the next question. Question number 27. Look at this question guys. So in this question, what we have is, we have a three-phase inductive, balanced inductive load, and capacitors are connected in delta. Look, capacitors are connected in delta, and the capacitance is 1/6 farad, and this star connected load is connected in, you can say it's again balanced, it's inductive load, and it is connected in star. This is connected in delta. We need to calculate the resonance frequency. So what we need to do is, we can make it simple. If somehow we can convert this in delta, if somehow we can convert this in equivalent delta, then this will be in equivalent delta, this load will be in delta, this load will be in delta, and in parallel, this capacitive load is again in delta. So you can say that the capacitor is also connected here. One capacitor is connected between A and B, one capacitor is connected between B and C, and one capacitor is connected in C and A. So this will be the circuit guys. Okay, if somehow we can convert this in delta, equivalent delta, then this capacitive load will be in parallel with this delta. Capacitive load will be in parallel with this delta equivalent. Okay, and then you can calculate the resonance frequency. The resonance frequency 1 by root L equivalent into C. This L equivalent we need to calculate. So we need to convert this star into delta. If we know how to convert this star into delta, this coupled circuit into a star into delta, then we can easily calculate the resonance frequency. I think it's easy. Okay. Now how to convert this star into delta? Sir, you have not mentioned the angle of neutral current. It seems RMS value of the current is given in the question. Yes, RMS value is given, and this current is also RMS current, because I have not mentioned the angle of the current. So it means I can say that this current is, because I have not mentioned the angle, it means you can assume that this current is same as this current, na? Because we can cancel this current. You can cancel this current. There is no other possibility otherwise. Otherwise, there is no other possibility, because this current itself is a 10 ampere current. Now, is there any way such that this current came out to be a different angle and the resultant of this current and this current came out to be 10 ampere again? No. They has to cancel one another. Then only the resultant current will be 10 ampere. If it is if there is any possibility such that this current came out to be at some, if you can take in different direction, and then also the resultant came out to be 10, then please tell me, please let me know that situation, okay? But according to me, this can be the possible situation, and according to this situation, the value of xc will be minus infinity. Now let's come to this question. So I told you that we need to convert this star into delta. Now how to convert this star into delta? Tell me guys, how to convert this star into delta? This is a coupled circuit. So I need to apply the basic rule to convert this star into delta. This is 4 Henry, 4 Henry and 4 Henry, and dot, dot, dot. This is 2 Henry, this is again 2 Henry, and this is again 2 Henry, okay? I need to convert this in delta, like this. Now how to convert it? It's very simple guys. A, B and C. This is called L equivalent, okay? Now what is this L equivalent? How to calculate this L equivalent? If this is L equivalent, this is also L equivalent, this is also, because the load is balanced, no? Now what we can do is we can calculate the equivalent inductance between A and B in this circuit. In this circuit, if you want to calculate the equivalent inductance, then that equivalent inductance will be L equivalent in parallel with 2L equivalent. Between A and B, you will see the equivalent, the inductance LAB, you can say. LAB will be equal to L equivalent in parallel with 2L equivalent. So it will be L equivalent into 2L equivalent divided by 3L equivalent. Is it fine? So you can say that LAB will be equal to 2 by 3L equivalent. Is it fine? So we have calculated LAB, inductance between A and B in this circuit. Now same you can calculate here. A is this and B is this, and we can connect this branch with a source, and we need to calculate the equivalent inductance A and B. Open it, open this C should remain open. Now if you keep this C open and if you try to calculate the equivalent inductance LAB in this star circuit, then it will be, because you can say that the current will flow only in this path. So there is no need of this inductance. There is no coupling with this inductance, because there is no current in this inductance now. So there is no need for this inductance. So what we can do is we can calculate the equivalent inductance by just taking series. So LA plus LB, so it's 4 plus 4, that is 8. Since one side dot is leaving, the current is leaving from the dot, and on the other coil the current is entering in the dot. So LA plus LB minus 2M, minus 2M. This will be the LAB in this star connection. So you can calculate this LAB as 4 Henry, okay? So this LAB came out to be 4 Henry in this star, and from delta you can say that this LAB came out to be 4 Henry. So from here L equivalent will be equal to 6 Henry. Is it fine guys? I hope it is correct. So you can say that this L equivalent, this in delta connection, this L equivalent came out to be 6. So this is 6 and this C is 1 by 6. C is 1 by 6. So you can put this value, and resonance frequency came out to be 1 radian per second. 1 radian per second. Is it fine guys? Is it fine? The answer is 1. Answer is 1. I don't know how many of you are able to solve it. This is 1 mark question. You should know how to convert this equivalent star into equivalent delta. Why you need to convert this in equivalent delta? The problem is this capacitor is given in delta form. Capacitor is given in, so better you convert this inductor also in delta form. So you can convert this inductor connection in equivalent delta. So we have calculated this L equivalent. Every phase has the same inductance. Every phase has same inductance. So how to calculate this L equivalent? You convert this in delta and calculate LAB in delta, and here also you calculate LAB. Okay, and then this LAB and this LAB should be equal. So I made them equal and then calculated L equivalent. So L equivalent came out to be 6. If L equivalent is 6, C is 1 by 6. So you can say that the resonance frequency would be 1 radian per second. Let's come to the next question. This question is MSQ. This question is MSQ. Which of the following statements are not true? Not true. Okay. Which of the following statements are not true? We need to calculate the statement which is not true. Which is not true. Tell me, guys. Tell me which statement is not true. First statement, look at this. And this is MSQ question for 2 marks. First statement, the power in the load resistance can be superposed if the sources are of different frequency. The power in the load resistance can be superposed if the sources are of different frequency. If the sources are of different frequency, then you can say that the power in the load resistance can be superposed. That's correct. That's correct. It is based on the power superposition. I told you, whenever you have RLC circuit or any circuit, and in that circuit, if the sources are of different frequency, then sure, it is 100% sure that the power in the load can be superposed. You can calculate the power due to one source and then calculate the power due to other source, and then the total power will be P1 plus P2. You can directly add them. So this is correct, but we don't want the correct solution. We want the not true solution. So this is true actually. This is true. So this cannot be the correct answer. Now come to the second part. If the sources are of same frequency, then the power can never be superposed. If the sources are of same frequency, then power can never be superposed. No, power can be superposed. If the sources are of same frequency, then also power can be superposed. How? It might be possible that, let's say, there are 2 sources. One source connected at some other position, one source connected at some other position. Let's say we have this circuit. This circuit is RLC. In this RLC, we have 2 sources. Okay, we have 2 sources and they have same frequency. And let's say the load is resistive. Now, due to first source, let's say the current is IM1 sine of omega t plus theta 1. Let's say this is the current due to first source. And the current due to the second source is IM2 sine of omega t plus theta 2. Let's say this is the current due to the second source. Frequency is same because the source has the same frequency, but it might be possible that the phase difference theta 1 minus theta 2 came out to be plus minus 90. It might be possible that the phase difference between this current and this current, the current due to this source and due to this source, have phase difference 90 degree. If the current has phase difference of 90 degree, then you can say that the power can be superposed. Whether you have the same frequency of the sources, there is no problem. If the sources have same frequency, but the current has 90 degree phase difference, then also the power will be superposed. So the never word is not correct. If the sources are of same frequency, then power can never be superposed. It is not true. It may be superposed. It depends on the value of L and C, R, L and C. What is the phase difference here? So it might be possible. If RLC is not known to us, then you can assume that the phase difference came out to be 90, plus 90 or minus 90. So power can be superposed. So this is, again, this is not true. So this should be the answer. This should be the answer, but there can be multiple answers. So let's check the next option. Power can be superposed if the sources are of same frequency, but 90 degree out of phase. This is again wrong. Why it is wrong? Let's say the power, the sources are of 90 degree phase difference. This is sine wave, this is cosine wave. The sources are not important for us. Actually, the current due to the sources are important for us. It might be possible that the sources are 90 degree phase difference, they have same frequency and they have 90 degree phase difference. But the current due to these sources came out to be of same frequency, but the phase difference is not 90 degree. Then you can't superpose the power. So it means this option, C option, is again not true. This option is again not true. Okay, this is not true. So it should be the correct answer because not true are asked now. So in this option, power can be superposed if sources are of same frequency. Sources are of same frequency and 90 degree out of phase. If the sources are of same frequency and 90 degree out of phase, it doesn't mean that the current will also be at 90 degree out of phase, because the load is RLC. If the load is pure, if the circuit is purely resistive, then you can say that. But since the circuit is RLC, then you can't say that. If the sources have 90 degree out of phase, then the current will also be at 90 degree out of phase. No, sir, it's not true. So you can't say that. This is not correct. Okay, so the not true option is C is also not true. So this should be in the option. Let's come to the D option. For same frequency sources, now the frequency is same. The load current due to individual sources, let's say only two sources are there. There are two sources of same frequency, and the load current due to the individual sources must be 90 degree out of phase. It means the current has the phase difference of 90 degree this time. They have the same frequency and current is 90 degree out of phase. Out of phase for power superposition. It is correct. I mean, this is true. So this should not be the correct. This should not be the option which I want to select, because I want to select the wrong option. So this option is correct. If the sources are of same frequency, but due to the same frequency sources, if the current came out to be 90 degree to one another, then power superposition will take place. Then you can superpose the power. So D option is correct. But we want not true options. So not true options are B and C. I hope you understood it. Okay, so the not true option is B and C. Yes, Sujit, the response must be 90 degree out of phase of similar frequency. Yes, if the sources are of same frequency and whether they are 90 degree or not 90 degree, it doesn't matter. If the sources are of same frequency, then their current should be at 90 degree out of phase. The response due to these sources should be at 90 degree. Then only power can be superposed. It doesn't matter what phase difference these sources has. They may be at 90 degree out of phase, or they may be other than 90 degree out of phase. It doesn't matter. Ultimate thing is this current, the current in the load. If they have same frequency, the current will also have same frequency, but they should be at 90 degree. Then only power can be superposed. But if the circuit is resistive, let's say, if the circuit is resistive, then the source must have phase difference of 90 degree. Because in the resistive circuit, whatever the phase difference the sources has, the same phase difference will be reflected here. So it means in resistive circuit, you can say that if the circuit is resistive, then you can, including the load obviously, if the circuit is resistive, then you can say that if the phase difference between the sources is 90 degree, then the phase difference in the current will also be at 90 degree and power can be superposed. Okay? So you have to remember this point. It's again very important point. I hope you understood it. So this is again MSQ, and B and C are not correct. Let's move to the next subject, guys. Now the subject is power electronics. So you ready? Tell me. So this was about network theory. I hope you solved these questions because these questions were very important. And let's move to the next question, guys. Next is power electronics. So in power electronics, the first question is this. This is again a network theory question actually. This is again a network theory question. So please tell me, for the circuit shown below, the load current wave shape is provided in figure 2. This is the load current wave shape. There is a load current wave shape. It is provided in figure. Which of the following statement is R true? And this is the load. This current is IL, and IL shape is provided to you. And these instants are provided. This instant is alpha 1, this is alpha 2, this is alpha 3, alpha 4, alpha 5, alpha 6. Which option is correct among them? This is MSQ question. 1 mark MSQ question. Tell me, guys. Again, it's a network theory question. It's a network theory question. So please tell me, it's based on the inductor statement, inductor condition. Tell me which options are correct. This is again MSQ. This is inductor current, and this current is aperiodic. It is given that the current ILT is aperiodic. Now, how to check which option is correct? It's very simple. Let me tell you guys, in inductor, look, this is inductor and this is VLT and this is ILT. In inductor, remember one point. Let's say the current started at this value and it again come to this value at this point. At this point, it again reached to that value. If the current is repeated, it means the same value is repeated. It means up to this point, the VLT area will be 0. Remember this point in inductor. In inductor, remember, if the current come to the previous value, if current repeat the previous value, let's say the previous value is, let's say 0. And if current repeat the 0 value again, at this point it came out to be 0 again. or let's say this is 5 ampere. Now at this instant it came out to be 5 ampere again. It means up to this point, from this point to this point, up to this point, you can say during this range, if you calculate VLT area in this range, it will be 0. Let's say this is 0 and let's call it some angle. I don't know, whatever angle. So it will be 0. The area will be 0. Okay. Simple idea is this. This is the simple idea in inductor. You have to remember. Okay. You have to remember this point. Now, let's look at this question. Let's try to look at this question. Now in this question, first alpha 3 to alpha 4. And he's telling about the VLT, area of this VLT. Now alpha 3 to alpha 4. At alpha 3, the current amplitude is this. Current amplitude is this. And at alpha 4, the current amplitude is same. It means between alpha 3 and alpha 4, the current is same. The same current is repeated here. So you can say that the area will be 0. A is correct. Now let's come to B. In B, you are moving from 0 to alpha 3, alpha 6, 0 to alpha 6. So at 0, the current has this amplitude. And at alpha 6, the current has the same amplitude. At alpha 6, the current has the same amplitude. So it means again, the VLT area is 0. Okay? The VLT area is 0. Answer Bombay is also correct. Now let's come to option C. In option C, you are moving from alpha 2 to alpha 5. Now tell me, at alpha 2, it is 0. And at alpha 5, it is positive. Look, at alpha 2, current is 0. At an alpha 5, current is positive. If current become positive, then this area will also be positive. Remember this point. It means C is also correct. If current is positive now, the current has increased now. If current has increased, remember this point. From this point to this point, if current has increased, then this area will be positive. If current has decreased, then the area will be negative. Okay, this is the inductor condition. So you can say that from alpha 2 to alpha 5, current has increased. At this point it is 0, at this point it is positive. So this is correct. Now alpha 2 to alpha 4. At alpha 2, current is 0. At alpha 4, current is negative. So you can say that the current has decreased. From alpha 2 to alpha 4, current has decreased. It means this area will be negative. During this interval, if you calculate the VLT area, voltage across the inductor, area across, VLT area, if you want to calculate, it will be negative. So D answer is correct. So you can say that all the options are correct. A, B, C, D. Okay. I hope you understood this question. This was again very good question. Let's move to the next question. Now it's a hardcore power electronics. So look, it's a single phase controlled rectifier. For a single phase full wave controlled rectifier shown below, find the maximum value of R. We need to calculate the maximum value of R so that the output current remains continuous. Output current should remain continuous. What should be the maximum value of R? L is given to us and omega is given as 100 pi. We need to calculate the maximum value of R. Up to what value we can increase the value of R such that current remain continuous. It means if you keep on increasing the value of R, at some point of time, what will happen is the current will become just continuous. If you further increase the value of R, current will become discontinuous. Now, we want to calculate what is the maximum value of R for which the current becomes just continuous. Because beyond that point, current will become discontinuous. So, for what value of R the current will be just continuous? We know that for just continuous condition in RL load, for just continuous condition, for just continuous condition, alpha must be equal to theta z. And alpha is fixed, 60 degrees. So theta z must be 60 degree. If you want that at this alpha, the current becomes just continuous, then alpha must be equal to theta z and theta z must be 60 degree because alpha is fixed at 60. So theta z should also be at 60 degree. Okay. So we can increase the value of R up to the point such that this angle, this theta z, impedance angle, came out to be 60 degree. Now what is the impedance angle? Impedance angle is tan inverse of omega L by R. This came out to be 60 degree. If you further increase the value of R, what will happen? Theta z will decrease. Theta z will decrease. Alpha will greater than theta z. Alpha will become greater than theta z and the conduction will become discontinuous. So at this 60 degree value, whenever this theta z is 60 degree, you can say that whenever this theta z is 60, it is equal to alpha, and at this condition, conduction is just continuous. So you can calculate the value of R. So from here, omega L by R is equal to 1060. 1060 is root 3. So R will be equal to omega L, 100 pi into L. L is 0.05 divided by root 3. This is the maximum value of R, guys. This is the maximum value of R. Let's calculate this value. This value came out to be, Ashish is saying 9.08. Okay, let me check. Let me check, Ashish. This value is 100 pi into 0.05 divided by root 3. This came out to be 9.068. That's correct. 9.068. This is correct answer, guys. Okay. I hope you understood it. For up to 2 decimal, you can make it 9.07. Okay. So this is the correct answer, guys. Let's move to the next question. In this question, we have 3-phase controlled rectifier. Okay. And this is A, this is B, this is C. It is given that a 3-phase controlled rectifier is shown below. Given that the firing angle is 90. Alpha is given as 90 degree. If the input of the 3-phase controlled rectifier is connected to secondary of star delta, it means the input of this 3-phase controlled rectifier, this input is connected to the delta side of the transformer, because delta is secondary now. So you can say that the transformer is like this. Primary side is star, and the secondary side is delta. Secondary side is like this, delta. Okay. This point, let's say A, this point is B, and this point is C. Okay. So it is connected like this. The A, B, C are connected here. Okay. And it is 1:2. The turn ratio is 1:2. Now, find the RMS line current of the primary side. We need to calculate this RMS. Let's call it IA. So we need to calculate the RMS value of this line current. How to calculate this RMS value of the line current? It's very simple. Let me solve. First of all, you need to draw this current IA. You need to draw this current IA and IB and IC. We need to draw this current IA, IB and IC. Once you get this IA, obviously IB and IC will be very easy because you can shift them by 120, and for IB you can shift this IA by 120 degree and then advance the current, this current by 120 degree, you will get this current. So first of all, we need to calculate this current, and let me take the dot also. Let me take the dot also. At this point dot, at this point dot, and at this point dot. So these are the dot points. Okay. Now, this coil is coupled with this coil. Okay. Now look at this carefully. I can say that if somehow we can calculate this current, the double current will flow here. Whatever this current is, double of that current will flow here. So if we can calculate the RMS value of this current, you take the double of that and you will get the RMS current of this current. Is it fine? Because this coil is coupled with this coil. So if somehow you can calculate the RMS value of this current, you just simply double it. You will get the RMS value of this current. It's very simple. Now, how to calculate the RMS value of this current? Let's try to solve it. Now, I know that the alpha is 90 degree. So for alpha equal to 90 degree, first I need to draw this current, and this current. It means this current, and this current. How to draw it? It's very simple. First, what I need to do is I need to draw the line voltage. Here. Remember, freewheeling diode is connected. Okay, freewheeling diode is also connected. So first of all, let me draw the line voltage at the output point. This is the line voltage. Don't remember anything. Don't try to cram anything. First of all, let's plot the line voltage at the output. And every interval is 60 degree. So you can say this is 60, 60, 60, 60, 60, 60. Now, what you can do is you can connect these caps. Okay. You can connect these points like this. Now come to this side. These are the 3-phase line voltages. Okay. These are the 3-phase line voltages. Now you can see that, let's take it origin. Because if you take it origin, this wave will lead by 30 degrees. So we call it VAB. This is VAB. And then after VAB, we have VAC. This is VAC. If this is VAB, this is VAC. Now this is VBC, and this is, if this is VBC, this way will be, tell me guys, this way will be VBA, and the next will be VCA. This next will be VCA. Okay. Anyway, this is VCA. I hope you understood it. VAB, then VAC, VBC, VBA, and VCA. Now, since alpha is 90 degree, if you look at the output voltage, then for alpha equal to 90 degree, if you look at the output voltage, then the output voltage should start from here for alpha 0. But since alpha is 90 degree, so you can say that at this point VAB will appear only during this interval. VAB will appear only during this interval, because alpha is measured from this instant. Everyone know that. So if alpha is measured from this instant, then you can say that if you go 90 degree, then at this point VAB will start. So this is VAB, and output voltage can never be negative. Output voltage, because freewheeling diode is there. So you can say that from this point to this point, output voltage will remain 0, and then you'll get VAC. You'll get VAC. So you can say that the VAB will appear only for 30 degree. And then for next 30 degree, it will be 0. And then for next 30 degree, you have VAC. And then for next 30 degree, you have 0. And then you have VBC. And then next 30 degree, you have 0. And then you have VBA. Okay. So this is my output voltage. This is my output voltage. Now, using this output voltage, we can plot this A phase current. Let's call it IA. We can plot this IA and this IB and this IC. You can plot them easily. Let's try to plot it. Let's try to plot the IA current. So put these interval 30-30. Let's say these are 30-30 degree interval. These are 30-30 degree interval. Okay. Now, look, this is VAB. This is VAB. Now, what is this? What is this? Can you tell me? Before VAB, which voltage we have? What is this wave name? What is the output voltage name? Before this VAB, this wave is there, na? And we know that this should be VCB. This should be VCB. This is VCB. This is VCB. Okay. Now, before VCB, we have this wave. Before VCB, we have this wave. Can you tell me the name of this voltage? It should be VC. Tell me guys, VCA. Is it fine? This should be VCA. If you can use this subscript, na, then you can easily say that. Or remember this point, this AB, ABC. So you can say this is AB. Oh, wait a minute. There is one more way to remember it. And the way to remember it, you can call it AB, BC, CA. This is AB, BC, and this is CA. If it is AB, then it will be VBA. It will be VBA. It will be AC. It will be CB. So you can say that after AB you have AC. After AB you have AC. If you are going in this direction. If you are going backward, before AB you have VCB. Before AB you have VCB. And before VCB you have VCA. So this wave is VCA. This wave is VCA. So the output voltage will look like this, and this is VCA. Okay. This is VCA and then 0. Okay. This is VCA. This is 0. This is VCB. Then this is 0. Then this is VAB. Is it fine, guys? Then 0. And then this is VAC. So this is my output voltage. Now, using the output voltage, I can plot the current. Using the output voltage, I can plot the current. How? How to plot the current? Put the 30-30 degree interval. First of all, let's plot the IA current. In first 30 degree, you can see that the output voltage is CA. It means the upper point is connected at C and the lower point is connected at A. Now tell me how the lower point is connected at A. There is only one way. If T4 is conducting, then only you'll get the lower point as A. The lower point should be at A, the upper point should be at C in first 30 degree. In first 30 degree, you have VCA. VCA means the lower point is at C, is at A, and the upper point is at C. The lower point is at A means this T4 is conducting. If T4 is conducting, then the current is coming backward. It means IA is negative. This 5 ampere is coming backward. So IA is negative. During this first 30 degree, IA is minus 5. In the next 30 degree, it is not conducting. So it is 0. In the next, it is 0. In the next 30 degree, you have VCB. Again, A is not there. A is not at the output. So it means neither T1 is conducting nor T4 is conducting. Because A phase is not available at the upper point or at the lower point. Because the output voltage is VCB. CB does not have A subscript. It means A phase is not available here, not available here. It means neither T1 conducting nor T4 is conducting. So current will remain 0. IA will remain 0 during the next 30 degree. Now, let's come to this. Again 0. So again 0. There is 0 next. Next, at this point, what will happen? At this point, you have VAB. AB means A point is upper and B point is lower. Upper point is A. It means T1 is conducting. So 5 ampere is current coming from this T1 thyristor and IA is positive. So you can say that now IA is positive. Now IA is positive at 5 ampere. Is it fine? Up to this point. And then 0. After VAB, we have 0. And then we have VAC. VAC means again you have upper point A. So current is positive. Okay. So the current is positive. Is it fine? Now come to the next. After VAC, you have 0 again. After VAC for 30 degree, you have 0. And then you have this voltage, VBC. After VAC, you have VBC. You can also see that after VAB, after VAC, this is VAC, no? After VAC, you have VBC. This is VAC and then 0 and then VBC. VBC is 0 again. Okay. And then after VBC, we have VBA again. VBA means negative. Here you have the negative sign. Okay. Here you have the negative. Okay. Let me tell you guys how. In VAB, we have positive and then 30 degree it's 0. It's 0. And then next 30 degree A is also there. So again positive. After VAC, we have 0. After VAC, we have 0. And then we have VBC. Then again 0. After VBC, we have again 0. And then we have VBA. VBA means negative. And then 0. After VBA, we have VCA. So it will be negative again. And then 0. Okay. So this will be the wave shape of IA. I don't know how many of you have understood it. This is the wave shape for current IA. We have plotted this current IA. It's easy. Now, if you have plotted this IA, IB and IC are very simple. Now you can easily plot IB and IC. Let me plot IB and IC. Let me plot the current IB and IC. Again 30-30 interval. You have to make 30-30 interval. How to make IB and IC? Tell me guys. To make IB and IC, you just delay it. You just delay it by 120 degree. You know that this is 60 and this is also 60. So if you delay it by 120 degree, so this is 60, this is 60. At this point, this wave again will repeat. I have delayed it. I have delayed this wave by 60 degree. So this point will come to, this point will come at this point, na? At this point. Is it fine guys? This wave will come at this point. This block will come at this point because the 0 point will be delayed by 120 degree. You can see that this is 60, this is 60. So it is 120. So at this point, this block will start and then again 3 blocks are 0 and then again positive, 0, positive, 0 and then 3 block will be 0. Okay. 3 block will be 0, 0, 0 and 0 and then negative. Okay. Okay. So we have plotted this IB, but the problem is, what is, we have started from here. What should I write it here at 0? Look, if 2 blocks are upward, then 2 blocks are downward after 3 points. So here you have only 1 block. So here you should have 1 more block. Now, 2 blocks should be upward. Then before 2 blocks, we have 3, 0 and then 2 block downward. The symmetry should be there, na? Symmetry should be there. And then again, you have 3 blocks should be 0. So only 2 blocks are there, na? These blocks should be 0 here. Okay, so you can say this is my IB. Now let's come to IC. Let's come to IC. Let's come to IC. Again, you have 30-30 interval. First you draw 30-30 interval. Is it fine? First you draw 30-30 interval and advance this wave. If you are going to advance it by 120 degree, then this point will come to 0. So initially you have 0 block, and then again this block, and then 3 0, 1 2 3, and then downward, 2 downward, okay, and then 3 0, and then again upward. Okay, so this way we have plotted IA, IB, IC. Okay, this way we have plotted IA, IB, IC. We have plotted IA, IB, and IC. Now, if you have plotted this current, or this current, then it is easy to plot this current, easy to calculate this current. Now let's plot this current. Let's call it I1. Let's call it I1. Now we can plot this I1 current. How to plot this I1 current? It's very simple. Now I'm ready to plot this current I1. How to plot it? At this point, let me plot the I1 current. I1, because once you get this I1, double of that will be IA. Okay, you get the line current. It's very simple. So again you show 30-30 interval. So I have shown the 30-30 interval. Okay, now in the first 30 you can see that this current is negative. It means in this phase the current is coming back, and via C phase it is going back. Here it is coming 5 and here it is going 5. So you can say that the 5 is coming and 5 is going. Now it has two paths. One is this path and one is this path. In this path it will see Z impedance, and via this path it will see 2Z impedance. So you can say that this 5 ampere will divide in two paths. One is this path, one is this path. In this path it will see Z impedance. In this path it will see 2Z impedance, and again 5 ampere will go back like this. So you can say that now this 5 ampere will divide in this and in this path. So this current will be 5 into 2 by 3. 2/3 of this current will go like this, and 1/3 will go like this, because it has large impedance, not double impedance. So you can say that 5 into 2 by 3 will go from this coil, and 5 into 2 by 3 is 10 by 3. It means 10 by 3 will go downward, but we are looking upward direction current. So you can say that the downward current we call negative current. So first 30 degree you have minus 10 by 3. Minus 10 by 3. Okay, now let's come to the next 30 degree. In the next 30 degree you have 0 in A phase, 0 in B phase, and 0 in C phase. So it means the current will remain 0. Okay, first 30 degree you have minus 10, then 0. Next 30 degree, in next 30 degree IA is 0, IB is negative. Now the current IB is coming like this and IC is going like this. It means what will happen now? Let me erase this point. Now what will happen is current from IB is coming like this and IC is going like this. So it has one this path and one this path. So you can say that it has one third of current will pass through this and 2/3 of the current will pass through this. This current is 5 ampere, we know that, and 1/3 of this will be 5 by 3, and since it is going downward, so it will be minus 5 by 3. So now the current will be minus 5 by 3. Is it fine? This current is minus 5 by 3. Next 30 degree. What about the next 30? Okay, next 30 again we have done this. Again IA is 0, IB is 0, IC is 0. So the current will remain 0. Now what about the next 30? Next 30 IA is positive. IA positive means current is going like this. Let me remove this. Let me remove this. Let me remove this. Okay, now let's see. Now IA is positive. IA positive means current is going like this, and IB is negative. In B phase it is coming like this. C phase is 0. Okay, it means from B it is coming like this, and from C it is going back. So this IB has two paths. One is this path and one is this path. Obviously it has large impedance. So this 5 will be 1/3 of that current will go like this. So if this current is 5, then this current will be 5 by 3. This current will be 5 by 3. So you can say that now the current will be 5 by 3. This current will be 5 by 3. Okay. Now what about the next 30 degree? Next 30 degree, A is 0, B is 0, and C is 0. So you can say 0 ampere will flow. What about the next 30? Next 30, A is positive. It means this current is positive, and C is negative. You can say that C is negative. It means C current is coming like this. So 5 ampere is coming like this and 5 is going like this. Now we have two paths. One path is this, one path is this. This path has large impedance. This path has low impedance. So you can say that this 5 ampere is coming. 2/3 of this current will go like this. So it will be 10 by 3. Now during this interval it will be 10 by 3. Is it fine? It will be 10 by 3. for next 60 degree, for next 30 degree. Now let's come to the next 30. Next 30, A is 0, B is 0, C is 0. So 0 ampere. What about the next? The next will be A is 0, B is positive. So now B is positive. Let me erase this. Now B is positive. Let's see, A is 0, A is 0, B is positive. A is 0, B is positive. B positive means current is going like this. And C is negative. Current is coming like this. So 5 ampere is coming like this and 5 is going like this. So 2/3 will go like this and 1/3 will go like this. Okay. So again the current will be 1/3. Again the current will be 1/3. Is it fine? The current will be 1/3. Now next 30. Next 30 it is 0. Next 30. Wait a minute. It is 0 and it is also 0. It is also 0. Okay. This I have already covered now in the previous one. 0, positive and negative. Positive was this, negative was this. Now 0, 0, 0. Now A is negative. A is negative, current is coming like this, and B is positive, current is going like this. Okay, and C is 0. Now if it is positive, if it is negative, if it is negative, if it is positive, then you can say that 5 will go 10/3 like this and 5/3 like this downward. So now you have downward current. I hope you understood the wave. Now using the symmetry you can complete this wave. Using the symmetry you can complete this wave. So you can say that now onward at this point it has negative and then it is like this. So again 3 pulse positive, 3 pulse negative. We have plotted this current. Now what you need to do is you need to take the RMS of this and take the double of it. RMS will be 5/3. If you calculate the RMS, take rectification now. If you try to calculate the RMS, take the rectification. RMS will be 5/3 and double of that will be 10/3. Answer is Bombay. Answer is Bombay. Okay. Answer is Bombay. I don't know how many of you have understood it. This is again very large question and very beautiful question. This type of question already came into exam. In that question there was no freewheeling diode. Okay. In that question there was no freewheeling diode. I have connected a freewheeling diode also and then I try to solve this question. It is again a very good question, guys. You can plot this current and then refer that, calculate the RMS value of this current and then refer to this side now. You can double it. The RMS value of this current is 5/3. I have already calculated. You can assume that this is the origin line. If it is origin for 180 degree, you can say that this is 60, 60, 60. Here it is 180, half cycle. Half cycle is this. So if you rectify it, the same wave will repeat. So you can say that the period is pi. So 1/pi integration 0 to pi/6 5/3 square plus, now this is pi/3, from pi/3 to 90, pi/2, 10/3 square plus, and this is 120. 120 is 2 pi/3 to 150, 5 pi/3. You have 5/3 square. This way you can calculate the RMS value and take the root. So you will get 5/3 and you double it. Because you are looking on this side. So you'll get the answer 10/3. Okay. So there is no √3 factor. There is no √3 factor. Remember this point. Let's come to the next question. Okay. This question is again very good. This question is again very good. How to solve this question? Look at this question, guys. Again, this is MSQ question. How to solve this question? Let me try this question. For a DC-DC converter shown below, V0 is fixed at 40. This voltage is fixed at 40 volt. This is fixed at 40 volt. Okay. V0 is fixed at 40 volt and VD varies from 60 to 80. 60 volt to 80 volt. This is variable. 60 volt to 80 volt. Okay. And assume C is very large. The C is very large and R is 10 ohm. This is 10 ohm. Okay. And switching frequency is 50 kilohertz. Switching frequency is 50 kilohertz. Now, which statement is R correct? He's asking about the critical value of inductance. Maximum value of L for discontinuous conduction is this. Okay. If L is greater than this, conduction will always be continuous. It means he's discussing about L now. In every option, L is there. Critical value of L is there. So what we need to do is we need to calculate the critical value of L. How to calculate the critical value of L for continuous and discontinuous conduction? We know that V naught is 40 and Vd is varying like this, and it's a buck converter. Switching frequency is this. First of all, calculate the I naught. I naught will be equal to 40 by 10, 4 ampere. This is the actual current which is flowing, because this voltage is constant and Vd is varying. Now assume the conduction to be continuous. Step 1 is assume continuous conduction. Assume continuous conduction. Continuous conduction. If you assume continuous conduction, duty ratio D will be equal to, tell me guys, D will be equal to V naught by Vd. In the first case we have 40 by 60. In the second case we have 40 by 80. So this will be 2 by 3 and this will be 1 by 2. So we have two Ds. One is 1 by 2 and one is 2 by 3. Okay, we have one this D and one is this D. Now what I need to do is I need to calculate the critical value of L. How to calculate the critical value of L? You just calculate IL min. If you remember how to calculate IL min was I naught minus delta IL by 2. Now what is this delta IL? Look, if you plot the inductor voltage, whenever the diode is on, or whenever the switch is on, the voltage across the inductor was Vd minus V naught. This voltage was Vd minus V naught, okay? Vd minus V naught. And the current will rise like this. Because the upper point is not visible, so let's make it like this. So current will rise like this. Now from T on to T, the voltage will be negative and the current will fall. The inductor current will fall like this and then it will rise again. We need to calculate this change, IL min and IL max. What is this difference? We call it delta IL. And the average current is I naught. I naught minus this half of this delta IL is IL min. This way you can calculate the IL min. If somehow you can calculate the IL min, then you can calculate the critical value of L. Okay. If somehow you can calculate the critical value, the delta IL value, then you can calculate the critical value of L. Now how to calculate this delta IL? This delta IL is very simple. Let me write this delta IL. Let me write in red color. So delta IL will be equal to 1 by L. Delta IL means I max minus I min. So 1 by L, so it will be 1 by L integration 0 to T on, and the voltage across the inductor is Vd minus V naught into dt. This is the change in current. From this point to this point, the voltage across the inductor is Vd minus V naught. You integrate it from 0 to L and 1 by L. This will be delta IL. So if you calculate this delta IL, it will be Vd minus V naught divided by L into T on. This will be my delta IL. So if you put this V naught as dVd, if I put V naught is equal to dVd, then you will get 1 minus d into Vd, or rather Vd equal to, you can put Vd or V naught, whatever. Okay, let's put V naught equal to dVd. Wait a minute guys, wait a minute, let me connect this mic again, because this is removed. Okay, wait a minute. Yes, it is now connected. I hope I am audible. Okay, so now you make this V naught equal to dVd. So take this Vd common. So 1 minus d into Vd into T on divided by L. And T on is d into T. So you can replace this T on as d into T. You can replace this T on as d into T. dt. Is it fine guys? Okay, I think it is fine. Now you replace this dVd as V naught. dVd as V naught. So you can say that the delta IL will be I naught minus 1 by 2 into, what is this delta IL? delta IL is 1 minus D into V naught into T by L. 1 minus D into V naught into T by L. This is my I naught. This is my IL min. Now, using this IL min, you can calculate the critical value of inductance. How to calculate the critical value of inductance? We have calculated this delta IL, the ripple in the current. We have calculated the ripple. And I told you the I min will be equal to, this minimum current will be equal to whatever the average current, whatever the average inductor current minus delta IL by 2. This will be my IL min. Now, we know that for just continuous conduction, this IL min has to be 0. This IL min has to be 0. So if I make it equal to 0, then you can calculate the value of L for just continuous case, just critical value of L. So the L will be equal to, if you make it equal to 0, then the L will be equal to 1 minus D into V naught into T divided by 2 I naught. This will be the critical value of L. At this value of L, this difference will be 0. If you further increase the value of L, this will become positive and conduction will become continuous. If you increase the value of L, this will decrease, na? So this will become positive. If IL min is positive, conduction is continuous. Okay? So you can say this is the minimum value of L. If you further increase it, it will become continuous. If you decrease the value of L, then it will increase and this IL min become negative. Negative is not possible. If IL min is negative, it means discontinuous conduction. Okay? So you can say that from here you can calculate the critical value of L. Below this L, conduction is discontinuous. Above this L, conduction is continuous. So now tell me, what is this critical value of L? There are two cases. There are two D's. V naught is fixed, T is fixed. I naught is fixed. But there are two D's. So according to D value, just calculate the L critical. In the first case, the L critical will be, if I put D equal to 2 by 3, then this 1 minus 2 by 3 is 1 by 3. 1 by 3 into V naught. What is this V naught? V naught is 40. V naught is 40. Divide by 2 I naught. I naught. What is this I naught? I naught is 4 ampere. I naught is fixed at 4 ampere. And T is 1 by F. So 1 by 50 kilohertz. Kilohertz is, kilowatt is 10 to the power 3 become millihenry. So using the first case at this D, if this voltage is 60 volt, then this L came out to be, this is cancelled, this 4 is cancelled. So you can get this 1 by 30, if you can see. Is it correct, guys? Please check it. I think it's 1 by 30. Yes, 1 by 30. So L came out to be 1 by 30 millihenry. Is it correct, guys? Please check it. 2 I naught is 4. I think I naught is correct. And T is 1 by 50. Okay, 1 minus D is 1 by 3. V naught is 40. Okay, that's fine. 0 is cancelled, 4 is cancelled, and here you have 3, here you have 10. So it's 1 by 30 millihenry. So from the first case, you have 1 by 30 millihenry. From the second case, in place of 3, you have 2. In place of 3, you have 2. So if I put 2 here, so it will be 1 by 20. In second case, L came out to be 1 by 20 millihenry. Okay, 1 by 20 millihenry. In first case, we have this. In second case, we have this. If you take L below this value, conduction will be discontinuous. Okay, below this value, but now which L is correct? So that in this range, if VD is changing from 60 to 80, in this range, conduction remains always discontinuous, because the first question is, first option, look at the first option. Maximum value of L for discontinuous conduction is this. We want discontinuous conduction in this entire range. We want discontinuous conduction. So L should be less than this and less than this. For 60 volt, L should be less than this. For 80 volt, L should be less than this. But we want that L in which in entire range conduction remain discontinuous. For 60 volt, it is given that L should be less than 0.0. L should be less than 0.03, right? 1 by 30 is 0.03, na? 0.033. Is it fine, guys? 0.1 divided by 3. 0.1 divided by 3 is 0.033 millihenry. So in 60 volt case, L should be less than this. And in 80 volt case, L should be less than 0.05 millihenry. So tell me, if I take this as the value, this as the final value, then it is also less than this. For discontinuous conduction, for 60 volt, L should be less than this. And for 80 volt, L should be less than this. So if I take L less than this value, then it will also satisfy for 80 volt. For 80 volt, L should be less than this, and this is already less than this. So what we can select is the maximum value of L such that the conduction become discontinuous and entire range is this value. If you take below this, then this will be satisfied and this condition is also satisfied. 80 volt condition is also satisfied, 60 volt condition is also satisfied. So you can say that L must be less than 0.33, but this is not 0.33. This is 0.6, so this option is wrong. Okay, this option is wrong. Now let's come to this. If L is greater than 0.1 millihenry, then the conduction will always continuous. If you look at the continuous conduction, so in continuous conduction for 60 volt, L should be greater than this, and for 80 volt, L should be greater than this. Now, what should I select? Such that conduction remain always continuous. Tell me guys, in entire range, for 60 volt, for continuous conduction, L should be greater than this. For 80 volt, L should be greater than this. If I take greater than this value, if I take greater than this value, then it will also be greater than this, na? So you can say that if I take greater than 0.05 millihenry, then this condition, 60 volt condition is also satisfied, because in 60 volt case, L should be greater than this, and 0.05 is already greater than 0.03. So you can say that if I take L greater than this, then the conduction will be continuous, greater than this value, 0.5, and he is saying 0.1. He is saying 0.05, greater than 0.05 millihenry, and in this option it is 0.1. So if L is greater than 0. For sure, in this case conduction is continuous, in this case conduction is continuous, because 0.1, this range is greater than this, and greater than case will always be continuous. So you can say that L greater than 0.1 millihenry will always be continuous. Okay, so B answer is correct. Now let's come to the next. He's saying that if L is fixed at 0.2 millihenry, if I put L equal to 0.2 millihenry, if L is fixed at 0.2 millihenry, okay, if L is fixed at 0.2 millihenry, the maximum frequency for which conduction always remain continuous is 25 kilohertz. Now critical frequency is asked. Now this time it has fixed L. It has fixed L. We need to calculate frequency. Now let's write this T as 1 by F. If I write this T as 1 by F, then I can calculate the critical frequency also. 1 by F. Is it fine? Here in place of T, you can write 1 by F. 1 by F. Now you can see that we can calculate the critical value of F. So the critical value of F will be, take this F in the numerator and L in the denominator. 1 minus D into V naught divide by 2 I naught L. Okay, this way you can calculate the critical frequency. Now tell me, if D is 2 by 3, what is the critical value of frequency? If D is 2 by 3, if you put it here, it will be 1 minus 2 by 3. 1 minus 2 by 3 is 1 by 3 into V naught. V naught is 40 divided by 2 I naught. I naught is 4 L. L is given as 0.2 millihenry. 0.2 millihenry. So milli will become kilohertz. Okay, milli will become kilohertz. So 4 is cancelled with this 10. Okay, and this 2 will become 50. This 2, if you divide 25 by 3, so this will become 25 by 3. 25 by 3 kilohertz. Okay, this is 25 by 3 kilohertz. If D is 2 by 3 and if D is 1 by 2, then it will become 25 by 2 kilohertz. It will become 25 by 2 kilohertz. So this is the critical frequency, guys. This is the critical frequency. So we found the critical frequency at which the conduction is just continuous. In first case you have 25 by 3 kilohertz. In second case you have 25 by 2 kilohertz. Now if you further increase the frequency, at this frequency this Imin is 0. If you increase the frequency, Imin will become positive. It means if frequency is greater than this value, conduction will become continuous for 60 volt case. And if frequency is greater than this value, conduction will become continuous for 80 volt. Okay. Now this came out to be 12.5 and this is less than 12.5. 8 point something. But what I want is, I want the maximum frequency for which the conduction remain discontinuous. We want discontinuous conduction. For discontinuous conduction, frequency should be less than this and less than this. Less than this and less than this. So the overall less region will be such that both are satisfied. The overall less region will be 25 by 3. This is not 25 kilohertz. It should be less than 25 by 3 kilohertz. So C is not correct. It should be less than 25 by 3 kilohertz. Then the conduction will be discontinuous in 60 and discontinuous in 80 also. Because for 80 you need 12.5, less than 12.5, and 25 by 3 is already less than 12.5. So you can say that if I take F less than 25 by 3, it is already satisfying the 80 volt condition. So that's why C is wrong. Now let's come to the D. For continuous conduction, L min is 0.1 Henry. For continuous conduction, tell me, what is the L min? L minimum should be 0.05. Because if L is greater than this value, conduction is continuous. Now you'll ask me, sir, but L is greater than this value, then again conduction is continuous. This conduction is continuous for 60 volt case. I want conduction to be continuous in entire range. So L should be such that it should satisfy this condition also and this condition also. It means greater than this value and greater than this value. So if I take the overall value of L, what overall value I need to select? Obviously, I should select this 0.05. If L is greater than 0.05, it will also be greater than 0.03. Na? So you can say that for L should be greater than 0.05, not 0.1 millihenry. So answer D is again wrong. Only B answer is correct. Only B answer is correct. This is again a very good question, guys. I don't know how many of you have understood it, but this is very good, very fine question. Okay, so answer is Bombay. Only Bombay is correct. You can check how I have calculated, how I have done the calculation, and how I have solved it. Please check the calculation. Please check the calculation. Otherwise, everything is fine. Check the calculation, I think. Otherwise, everything is fine. You check the calculation only. Okay. So let's further move to the next question. The next question is this. I think this is the second last question, and then we'll complete this part. Okay, look at this question. This is again 1 mark question. This is very simple question. What is this? We have a voltage source inverter, single phase voltage source inverter with unipolar PWM switching. Unipolar PWM switching is provided to you, and the control signal for leg A and leg B are given like this. This is for control A, and this is for control. This is the control signal for leg B. Now tell me, MA for leg A, MA is given like this, and for leg B, this is the modulation index for leg B. Okay. Now, if you look at the fundamental component, if you look at this voltage. If you look at this voltage, and if you look at the fundamental component of this voltage, the fundamental component of this voltage VA with respect to ground point, let's say VAT, VA1T, the fundamental component will be M modulation index of A into VDC by 2. This will be the fundamental component of this voltage. Now, what is the fundamental component of this voltage? It will be MA of leg B into VDC by 2. Okay. So this way you can calculate the fundamental component of this voltage and the fundamental component of this voltage. It is the peak value. Now what is this value? What is this value, guys? MA. What is MA? MA is 0.6. So if you take 0.6, then you will get 0.6 into VDC by 2. VDC is 100. So 100 by 2 is 50. Okay. So you will get 50 into 0.6. 50 into 0.6 is, can you tell me, 50 into 0.6 is 30 volt. So here you will have 30 volt peak value. 30 sine of omega t, you can say. Now what is the peak value here? The peak value here will be MAB into VDC by 2. MAB is 0.8. 0.8 into VDC by 2. VDC by 2 is 50. So it will be 40 volt. Okay. So you can say that at this point you have 40 volt. 40 sine of omega t. But they are 180 degree apart. If it is sine like this, then this point voltage will be opposite. But we have 80 volt, 40 volt here and 30 volt here. So if you take the difference, you will get 70 volt. 30, this is already minus, na? And if you take the difference, it will add it to, na? Add it to this value. So the peak value will become 70 volt. Okay? Amplitude of fundamental peak value is 70 volt. I don't know if you have studied this unipolar PWM. This question is based on unipolar PWM. Okay? So in this unipolar PWM, you have to calculate this voltage and this voltage separately. They are 180 degree apart, but here the voltage is whatever this MA with leg A, you calculate this MA for leg A into VDC by 2, you will get the voltage here, fundamental voltage here, peak value of the fundamental voltage. Similarly, MAB into VDC by 2, you will get the peak value fundamental voltage here. So you get the fundamental voltage here 30 and you will get the fundamental voltage here 40, but this voltage is 180 degree apart. It means if it is 30, it is minus 40 sin omega t. This is 30 sin omega t, this is minus 40 sin. You take the difference, it will become 70 sin of omega t. So the peak amplitude will be 70 volt. Okay, so this is again a very good question. Let's say this modulation index for both the legs are same. Let's say the modulation index is for both, then if it is 30, it will also be 30. If it is 0.6 and this is also 0.6, then it is 30, then it is also 30. Then if you take the difference, it will become 60. Okay, so this is very simple, but this time the modulation index for each leg is different. So that's why we will solve like this. So it's a simple question. I hope you understand it. Now, this is the last question, guys. This is the last question for power electronics. A three-phase voltage source inverter is shown below. For 120 degree conduction mode, find the power absorbed by the load due to the fundamental component of the output. We need to calculate the power absorbed by the load due to fundamental component only. Now, what should I do? It's 120 degree conduction mode. So what? There is no problem. Look, this point is A and this point is O, because this is O, na? Ground point we call it O. So this will become O also. What I need to do is I need to calculate this VAO. So first let's plot VAO. Voltage of A point with respect to O. O means ground, with respect to ground. If this is 100 volt, this will be 50, this will also be 50. With respect to 0 volt, it will become 50 volt and this will become minus 50 volt. Now if the switch is on, let's say SA plus is on first. For first 120 degree, let's make these interval are of each of 60 degree. Each interval is of 60 degree. For first 120 degree, SA is on. It means this voltage is 50 volt with respect to ground. So you can say that the phase voltage is 50 volt for 120 degree, and then for next 60 degree it is 0. And then for next 120 degree, this lower point is on. It means minus 50 will be on. This point is not connected here. It should be connected here. Okay, please check the connection. This A point should be connected from here. Let me remove this. It should not be there, na? Okay. Yes. So now tell me. Now the voltage for voltage VAO will look like this. For 120 degree conduction mode, this will be the wave shape for VAO. Okay. This is my VAO, guys. Now I need to look at the fundamental component of this voltage. If you want to calculate the fundamental amplitude, because I want the power absorbed by the load due to the fundamental component of this. Now how to calculate the fundamental? Using quarter wave symmetry. Let's assume that this point is origin. Let's assume that, because wherever you take origin, fundamental component will remain same. The amplitude of the fundamental will remain same. It doesn't depend on the origin point. So I took origin here. If I took origin here, then this wave will contain quarter wave symmetry. This wave will contain quarter wave symmetry, and this will be the fundamental component. Now I need to calculate this amplitude, fundamental amplitude. So what you can do is, if this is the origin, then this will be pi by 6 point and this will be pi by 2 point. Okay, I need to get the fundamental component. So for fundamental component, peak value of the fundamental, you can apply the quarter wave symmetry. So if you apply the quarter wave symmetry, it is 4 by pi integration from pi by 6 to pi by 2. I don't know how many of you know the quarter wave symmetry. Pi by 6 to pi by 2, the amplitude of this function is 50 into sine of omega naught t into d omega naught t. This is the peak value of the fundamental component using Fourier, okay, quarter wave symmetry. So I took this 50 outside, so it will become 200 upon pi, and the integration of sine is minus cos. Upper limit is 0 and the lower limit is cos 30 degree. Okay, this will be the amplitude of the fundamental component. Now this is the fundamental voltage across this phase, pi ohm. Now what is the RMS value? RMS value will be 200 by pi, cos 30 is root 3 by 2, For RMS value, I divided with 1 by root 2 further. I divided with root 2. So this is the RMS voltage across, fundamental RMS voltage across this 5 ohm. Take the RMS square, divide by 5. This is the power loss in this phase due to fundamental component. Multiply by 3. Multiply by 3. This is the overall power loss, and I have taken the square of it. Okay. So this is the overall power loss due to the fundamental component. Okay, guys. This is the overall power loss due to the fundamental component. Now you can calculate this value. You can calculate this value. This came out to be 3 by 5 into 200 root 3 divided by pi into 2 root 2. I think this is fine, and take the square of it. Okay. So this came out to be 911.89. 911.89 watt. Okay, please check the calculation. So this much of power is, you can say, the output power due to the fundamental component. You should know how to calculate the fundamental peak value of the output voltage, and then take the RMS value, take the square of it, divide by 5, multiply by 3, because there are 3 phases. So this question was again easy. Now it's time for the measurement. There are 2 questions from the measurement. I have selected 2 questions from the measurement. So let's solve these questions. First question is this. This is 2-mark question. Okay, in this question, a wattmeter reads 5.54 kilowatt when the current coil is connected in red phase, and its voltage coil is connected between the neutral and the red phase. Okay, so let's say I have a load. 3-phase load is there. Red, yellow, blue, and this is the neutral point. He is saying that the current coil is connected in the red phase. This is the current coil, and the potential coil is connected in the neutral and the red phase. Red phase and the neutral. This is my wattmeter, and this wattmeter is 5.54 kilowatt. Okay, this is the question which is provided to us, given in the statement. Now, okay, symmetric 3-phase system is there, supplying a balanced load of now the current is 30 ampere. He is saying that the current is 30 ampere and the line voltage is 400 volt. So the phase voltage will become 400 by root 3. Okay. So this situation is given to you. Line voltage is 400 volt and the load current is 30 ampere. It means the line current is 30 ampere. It is given to the balanced load. What will be the reading of the instrument if the current coil remains unchanged? Now what I did is, current coil is connected here. There is no change with the current coil, but the potential coil is connected between the blue and the yellow phase. Okay, so this is red, this is yellow, and this is blue. Okay, now the potential coil is connected between blue and the yellow phase. Okay, so here we have the current coil, but the potential coil is connected between blue and the red point. This is my potential coil. It is connected between blue and yellow. Now I need to calculate what should be the reading. What should be the reading of this wattmeter? Okay, the phase sequence is RYB. So this is the question, guys. So this is the question. We need to calculate what is the reading of this wattmeter. Previously it was connected like this. So now from here we can say that this power is active power. So 5.54 into 10 to the power 3 is equal to, this is the power which will be equal to the current in the current coil, which is 30, into the voltage across the potential coil, which is 400 by root 3, into cos of phi. Cos phi is the phase difference of voltage and current. It means you can say that it is the phase difference of the impedance angle of this load. Whatever the impedance angle of this load, that will be the phase difference between this voltage and this current. So I have taken the power factor of this. Okay, so from here you can calculate cos phi. So cos phi came out to be, now let's calculate this cos phi. So it will be equal to 5.54 into 10 to the power 3 divided by 30 into 400. 30 into 400 into root 3. Okay, so this came out to be 0.799. It means 0.8. Cos phi came out to be 0.8. Okay, guys. So we have calculated the power factor of the load. Now, look, the current coil is connected here. It means this current is 30 again, 30 ampere. Okay. And the potential coil is between B and Y. It means YB voltage is here. Here the potential coil will read YB voltage, VYB. And the current is IR. So first, let's plot the phasor. It is VR, VY, VB. It is VR, VY, and VB. These were three phase voltages. In the first case, the current was lagging by this angle, cos inverse of 0.8. If you take the cos inverse, then you will get what is that cos inverse of 0.8? Tell me, guys. Tell me. Cos inverse of 0.8. It will be 36.86. So you can say that in red phase, the current was lagging 36. This current is 36.86. And this is 30 ampere. Okay. This was the current which was lagging the VR voltage, phase voltage by this angle. Now, the potential coil is reading YB voltage. YB. Now, what is YB? RYB. VRY, YB. We need to calculate YB voltage. YB voltage will look like this. This will be VYB. And the value will be 400 volt. This is the line voltage. So, the potential coil will read the line voltage and the angle is at 90 degree. This angle is at 90 degree. Okay. So now the reading of the voltmeter will be, the current is 30, RMS current is 30 into the voltage read by the potential coil is 400. And what is the angle between this current and this voltage? The current is this direction 36.86 and the voltage is at 90 degrees. So this angle is 90 minus 36.86. So 90 minus 36.86 is 53.10. So cos of 53.10. You can say it is 0.6. This value came out to be 0.6. So you just multiply and calculate the reading of the voltmeter. So now the reading of the voltmeter will be 400 into 30. Is it fine, guys? So this came out to be 7200. Okay, 7200. Is it fine, guys? 70. It means 77.2 kilowatt. This will be the new reading, 7.20 kilowatt or 7200 watt. If it is asked in watt, then you can write like this. Okay. So I told you how the voltmeter will read now. The voltmeter will read the line voltage now. Line voltage is 400, and since it is reading YB means 90 degree like this, and the current it reads is again 30 ampere. So the angle between this voltage and the current is 90 minus 36.86. So you can calculate this 53.10, and if you take cosine of that, you'll get 7200 watt. Okay. So this is very simple, guys. I hope you can calculate this. Now let's come to the last question. So let me check. You tell me the answer. What is the answer? And let me tell to the next faculty. And the next faculty is Ankit Joshi sir. So Ankit Joshi sir, your favorite will take the session now. So yeah, let me contact sir so that he can join. Let's wait, guys. I think let's wait whether sir is I think he will join within like 2-3 minutes. Okay, I think sir is ready. Okay, just solve this last question, guys. Tell me, the Maxwell's inductance capacitance bridge is used to measure the inductance of. Now tell me, for which coil this bridge is used? Tell me, guys, for which coil this bridge is used? Tell me, everyone. Okay. Thank you, Ankit sir. Thank you. So tell me, guys, for which coil this bridge is used? Now it's a memory based question. It's a memory based question, and I think you can easily solve if you remember. If you remember, then you can easily, because this type of question can come into your exam. Okay, so you have to remember. So now, according to this, the Maxwell inductance capacitance bridge is used for medium Q coils. Just remember this point. This way you can solve it. Okay, so there was no need to understand anything. Just remember this point, otherwise it will be difficult for you. Okay, so that's all for these three subjects. So I have covered network theory, and then power electronics, and then so first I have taken the network theory questions, and then power electronics, and then instrumentation. So I have selected only 2 questions from instrumentation. Now you will continue with Ankit Joshi sir. So Ankit Joshi sir will continue with you, and you will now you'll start, I think, analog electronics. Okay, so analog electronics will be started now. Okay, so you'll see a glitch for 10 seconds. So don't worry, guys, and you can start with Ankit Joshi sir, analog electronics. Okay, so sir.
Have your response. So students, can you hear me? This is Ankit Joshi. I welcome you all on this session, and I just say heads off for your patience, dedication towards such kind of sessions. Very nice. It's really very nice, and I think best wishes are with you. So students, after a very energetic session from Ashu Jangla sir, I am continuing this session. Hope all will be present till the end of this session, because after me, your favorite Ashutosh Saxena sir will be joining with questions from electrical machines and power system. So here I will be covering the questions from analog electronics and engineering mathematics. So we are having yes, questions from engineering maths. Then we are having yes 5 questions from signals and system. Then we have questions from analog circuits. So stay tuned, and here I am showing the that an announcement as Rakesh sir in the morning itself they announced that yes, on 18th of December at 12:30 noon he will be taking a mega workshop on our BYJU'S Exam Prep app. Don't forget to. Then there is an announcement regarding the GATE PYQ series which is going to live this channel, that will be starting from tomorrow. So don't forget to subscribe our channel if you have not done so. If you have not done so, please subscribe our channel. Then already we have announced that mock tests for GATE 2020 from between 13th of December to 20th. And yes, please note down the dates are hidden behind me. 13th of December to 20th of December. Please make a note of this. Thanks a lot. So first section we will be having questions from engineering mathematics. So be on lighter note, and I will be covering my subject. I will be covering my subject matter in the upcoming 5 minutes. Students, here comes our first question. Yes, good afternoon, Akila. How are you? I just request all of you to stay tuned, and if you have not liked this session till now, requesting all of you to hit the like button. Yes. So students, here we have got let A equal to A of ij. There is a matrix which is represented by A of ij, and they have given certain conditions. I less than equal, yes, 1 less than equal to I, j less than equal to n, and what about n? N is greater than equal to 3. So this n I'm assuming to be 3. I'm assuming this order n to be 3. My assumption as per the given condition. Then what else is given? J should be less than or equal to N. You have the authority of selecting J. It should be less than or equal to N. So N is 3. I am assuming J to be very simple and let it be say 2. And I should be greater than or equal to 1. So I am assuming I to be 2. So I am getting a matrix A whose elements are represented by A of ij. I and J both are selected as 2. My matrix will be cross 2. We will get a matrix of order 2 cross 2. Say yes or no. So the elements will be A11, A12, A21 and A2. Yes, have your response. Students, each of the element is compiled by using this formula mentioned in the question. I is the row number, J is the 1 into 1 will give you 1. 1 into 2 will give you 2. 2 into 1 again give you 2. These are 4. So students, as we can say that the two rows in this matrix are proportional, and that's why the rank will be simply equal to 1. Rank of A, rank of such a matrix E. So option correct one. So I just wanted to know how many of you got this answer. How many of you have got this answer? So I can see Shubham Dayal. Very good. Kila has got the answer. Anyone else? Try to be active in the comment box with your answers. Then I move to the next question. Yes, coming on to the next question. The next question is again from linear algebra, and this question is from system of linear equations. And as on the right hand side, you can see a non-zero matrix, non-null matrix, means an example of non-homogeneous system. All my dear students can be approximated as Ax equal to B, where B is not equal to 0. You can say that it is a non-homogeneous system. Non-homogeneous system. For this non-homogeneous system, what is the condition for no solution? Condition for no solution is rank of C, that is the augmented matrix, should not be equal to rank of A. This is the condition for no solution. This is the condition for no solution, that is R should not be equal to rho. Okay. Students, let us write the augmented matrix. Let us write the augmented matrix. What is the augmented matrix? Augmented matrix is equal to A colon B. A combined with B. Friends, Amar. Anji. So here the elements of A. What are the elements of A? 1, 2, minus 8. 1, 2, minus 8. Then 4, 3, minus 12. 2, 1, minus 4. Are you all following? Then this right hand side matrix is matrix B. Elements are 7, 5 and D. Now students, I will be marking this diagonal and I will be applying row echelon form method, and I will try to make these two positions 0. I mean को 0 बनाएंगे. This is row number 2. Row number 2 subjected to the operation R2 minus 4 times R1. This is row number 3. What steps to be applied in row number 3? R3 tending to R3 minus 2, 1 minus 2. Let us apply this. Just hiding myself that complete screen should be visible to you. Students, are you all following? So after doing this operation, you will get equivalent to C. Are you all following? First row, there is no change. So 1, 2, minus 8 and 7. Second row, R2 minus 4 R1. So 4 minus 4. 3 minus 8 will be minus 5. Then minus 12 minus minus plus 32. 20. 5 minus 5 minus. Then R2 minus R1. R2 minus R1. R2 minus sorry, R3. R3 is R3 minus 2 R1. 2. Then 1 minus 4 will be minus 3. Then minus 4 and plus 16. Minus 4 plus 16 will be 12. And then we have D minus 4. D minus 16. Then further I am marking this diagonal and I will make this position 0. This position को 0 बना. Will make this position 0. What to do for it? क्या करना होगा? R3 tending to, हाँ जी, 5 times R3 minus 3 times R2. That we need equivalent to C. What you will get here? Any changes in R1? No, sir. No changes in R1. So 1, minus 8 and 7. Stay tuned. Students who just joined, kind information for all of you that here mathematics questions, then you will be having questions from signals and system, then analog circuits, and then your favorite Rakesh Sir will be joining with questions from your core subjects, electrical machines and power systems. 0, yes, R2 also no change. 0, minus 5, 20 and minus 20. And what changes you have done in R3? Sir, R3, 5 R3 minus 3 R2. This is 0, 0. 5 R3, 5 R3, 60, and then again 60, 0. All my dear students, D minus 14 multiplied by 5, that will be 5D minus 70, and then what? Minus 3 R2, so plus 63, 69, 5D minus 1. Is it? D minus 1, 5D minus 70 minus 60, minus plus 5D minus. Now students, if 5D minus 1 is 0, if 5D minus 1 is 0, then rank of C will be equal to rank of A. But we want ranks to be unequal. So 5D minus 1 not be equal to 0. 5D minus 1 should not be equal to 0 means D should not be equal to 1 by 5. So apart from 1 by 5, how many values are available? There are infinite values of D are available which can give you no solution. Understood? Option D will be the correct answer. How many of you got this option D? Cosmos, yes, anybody else? Out of this, I'm again coming on your screen. All fine, students. When rank of C is not equal to rank of A, you are going to get no solution. So 5D minus 1 should not be equal to 0. That is, D should not be equal to 1 by 5. D not equal to 1 by 5 means apart from 1 by 5, you can take infinite set of values. Ultimately, that there are infinite values of D, there are infinite number can give you no. Let us move to the next question. Students, this is that question, numerical answer type question. Yes, the number of independent eigenvectors corresponding to the real eigenvalue of the following matrix. Students, this is an upper triangular matrix. क्या है upper triangular matrix? In an upper triangular matrix, eigenvalues are straight away the diagonal elements. You can say that eigenvalues are 1, eigenvalue 5 is repeated twice. All my dear students, when eigenvalues are distinct, each of the eigenvalue will be having one eigenvector associated with it. So lambda 1 equal to 1 will be having one eigenvector. Lambda 2 equal to 2 will be having one corresponding. And for this repeated eigenvalue, how many eigenvectors will exist? That can be obtained by the concept of geometric multiplicity. Geometric multiplicity determines the number of independent eigenvectors associated with particular repeated eigenvalue, and this is also called as nullity or degeneracy, equal to n minus rank of A minus lambda suffix small I capital. Students may be thinking, what is this n? So n is the order of this matrix. What is the order for this matrix? 4. Rank A minus, what is this lambda I? Lambda I is nothing but the value of this repeated eigenvalue. Here repeated eigenvalue is 5. A minus 5i. Students, 4 minus rank of A minus 5i. How we are going to construct a minus 5i? Just you subtract 5 from the diagonal. Are the subtract 5 from each of the diagonal elements, and remaining elements will be as it is. So, अरे भाई 5 minus 5 will give you 0. Remaining values as it is. Then 0. 5 minus 5 is 0. 0. 0. 0. 2 minus 5 will be minus 3. Then we have 1. 0. 1 minus 5 will give. Students, have you all got this? Now, q equal to 4 minus rank of. Now, I am doing certain manipulations to find the rank. Students, come on. So, I am just replacing what second row with the fourth. First row as it is 1. Second row replaced with the row minus 1. Then 0, 0. Second row is replaced with the R1 as it is. Then R4 is coming in the place of R2 minus 4. And just R3 is last row. Friends, say that you can see here that first row and second row are proportional, so one more 0 row can be obtained. Okay, so clearly we can say that the rank of this matrix will be 2. Just by observation we can see that, and that's why q is geometric multiplicity will be eigenvalues. Eigenvalues will have 2 independent eigenvectors. Independent eigenvectors for this repeated eigenvalue and 2 independent eigenvectors for eigenvalue 1 and 2. So overall there will be 4 eigenvectors. Yes, Shubham Dayal, are you following? How many eigenvectors will get here? 4 eigenvectors. Answer to this question. Any confusion? Please let me know. Let us proceed. Here. Now the first question from calculus section. The function f of x 3x raised to 4 minus 4x cube plus 2 has minimum value at x equal to. What we are going to do here, first of all we will be applying the first. What is the first step? Find the first derivative. First derivative is yes 12x cube minus 12x square. That's it. Second step will be we are going to form an equation by equating this first derivative to 0. 12x square is common. Then x minus 1 equal to. I am getting stationary. Now I am performing the third step, that is second derivative. Second derivative is nothing but 36x square minus. Students, for x equal to 1, when I put x equal to 1, I will get 36 minus 20, that is 2, which is greater than 0. Double derivative is greater than 0 will give you minima. So we can say that function is minimum at x equal to 1. 1 mark NAT question, numerical answer type question. Answer is understood everyone. Keep moving. This is a very beautiful question. In this particular question, what we are doing, we are assuming this question to be I. Okay, and we are following one property here. What is that property? That the same integration I can be written as 0 to pi. Wherever you have x, that x can be replaced by pi minus x. Without affecting the value of this integration. Sec pi minus x and pi minus. Further, we have a dx here. Students, this I 0 to pi minus x. Now see here, by allied angle, tan 1 minus x, pi minus x minus tan x. Similarly, sec of pi minus x is minus sec x, then pi minus x is minus tan x. 1 minus common from the denominator and 1 minus sign is from the numerator. Both will cancel each other. We are going to get this bracket followed by tan x upon sec x. Students, the given question is say equation number 1 and this equation is say equation number 2. If we add these two, what you are going to get? We will get twice I on the left hand side and if you observe closely, you can just take tan x common from the numerator. So x plus pi minus x I. Then outside this bracket you are having tan x. The denominator you are having sec x plus. Comfortable with this? Students, yes, bacha log, pi will be out. Tan x can be written as sine upon cos. Sec x is 1 by cos, tan x is 1 by sine by cos, will be given 1 plus. So 1 cos x from numerator and 1 cos x from denominator are striked out, cancelled. What to do, sir? क्या करें? Twice I 0 to pi. Let us do one thing. Let us rationalize this denominator. 1 plus sin x is already there. Multiplied by 1 minus on 1 minus. What you will get twice I just sin x sin square x 1. 1 plus sin x 1 minus sin x kitna hoga? How much it will be? Plus b to a minus b. This will be giving you 1 minus sin square x, that is cos. So students, what can be done now? You can separate these two terms and form two separate. I equal to pi. Sin x upon cos square x. So sin by cos is tan and 1 by cos is tan x into. One more integration, right? Sin square upon cos square is tan square. But tan square can be written minus 1. Now simplify this. Yes, come on everyone. Integration of sec x tan x is sec x. Integration of this sec square x is simply tan x. Minus minus plus integration of 1. Apply the limit 0 to pi. When you put pi, sec pi, of cos in minus tan pi will lower limits sec 0, reciprocal of cos 0 in 1, tan 0 is 0. All my dear students are getting twice I equal to minus 1 I minus. So we are getting pi into pi minus as the value of this I, and I is nothing but your integration. Correct? Option C. Everyone should respond. Yeah. Let's move to the next question. This question is from probability. On an average, 2 COVID positive cases are received per day in a hospital. This is average universal statement given. Positive cases per. On an average, 2 COVID positive cases are received per day in a hospital. The ratio of the probability of 2 of or less COVID positive cases in 2 countries, the probability of exactly 2 cases in a given day. You have to find out. Please try to understand that this particular equation will be solved using Poisson's distribution with 2 different values of lambda. Listen carefully. So here we are going to calculate the ratio, but before calculating the ratio, try to understand that while calculating this probability of or less COVID positive cases in consecutive days, this probability for this particular probability, lambda will be different. So alpha is 2 and 2 consecutive days means number of units of time, the delta t will be 2. So lambda is nothing but alpha into delta t. Lambda क्या है? Alpha into delta t. 2 2s are 4. With this value of lambda, we are going to construct p of x. Lambda raised to x raised to minus lambda upon factor. And in this, you have to by using this, you have to calculate this numerator. That is supposed to calculate probability for x less than equal to. Friends, I'm going to hide myself for see here. E raised to minus 4 will be out, and all my students 4 raised. In order to solve this, values of x 0, 1 and 2. X less than equal to 2 means what? 0, 1 and 2. Yes? Come on, respond कीजिए. Ashok, you can download this PDF from our Telegram channel, Electronics by Ankit Joshi, or from any faculty's Telegram channel. That you can links can be downloaded. X equal to 0, 1, 2. E raised to minus 4 is out. Students, e raised to minus 4 will be out. Put x equal to 0 here. So 4 raised to below this remaining part, you have to substitute x equal to 0, 1 and 2. E raised to minus 4 is out. Put x equal to 0, you will get 1. Put x equal to 1, you will get upon 1, that is 4. When you put x equal to 2, you will get 4 square, that is 16. 16 upon 2 is 8. So students, this is 13 times e raised to minus 4. Probability for x less than equal to 2 consecutive. Coming on to the second part. Second part क्या है भाई? Second part is here. Second part is the probability of exactly 2 cases. Ashok bhai, concentrate. Probability of exactly 2 cases on a given day. Students, alpha is nothing but 2. But on a given day means number of units of time will be 1. Number of units of time will be 1. So lambda is nothing but alpha into delta t. Come on, yaar, respond. Probability distribution using Poisson's will be lambda raised to x e raised to minus lambda upon factorial x. Okay, sir. From here, we want to calculate our probability P2. Nothing but probability exactly 2 cases. So here in this distribution, you have to substitute x equal to 2. So put x equal to 2, you will be getting 2 square e raised to minus 2 upon factorial 2. Ultimately, this will be 4 by 2, that is raised to minus 2. The student, we want to find out the ratio of these calculated probability. This is one is the moment. This one is 13 times e raised to minus 4. Okay, sir. minus 4, 13 minus 4 on, what is this probability, times e minus 2, this is 6.5 e raised to minus 2. Find it. 0.5 e raised to minus 2. Option B is the correct answer. Option B is the correct answer. How many of you have got this answer? कितने बच्चों का ये आंसर आया है? Let me know in the comment box. Everyone should respond. A lot of energy is already nurtured in this session. First faculty Rakesh Talreja sir, and then Ashu Jangra sir, and we are also trying to do the similar type of effort, and followed by me, your favorite Ashu sir. Let's move to the next question. Students, how is the Josh? Come on, respond in the comment box. Don't let yourself down. It's a matter of next the entire set of questions. A unit normal vector to the surface z equal to 2xy at the point 214. We are assuming this phi, we are bringing all the terms to the left hand side. This is our phi. What is gradient phi? Gradient phi is the normal to the surface phi. Gradient phi is normal to the surface phi. Thank you, Ashok. Thanks for your appreciation. What about others? What do you feel? Del phi I, del phi by del x, j, del phi by del y, k, del phi by del z. Friends, I cap del phi by del x will del phi by del y will be k cap del phi by del z. This is gradient phi. So students, at this point, once a point at 214, at 214, what you will get? You will get normal vector del phi. Y coordinate is 1, so I. The next coordinate is 2, so 2 2s are 4j minus k. So students, this is n vector. What we want? We want n cap, unit normal vector. Unit normal vector is n vector upon its magnitude. So magnitude will be of 21, and the vector is 2i plus 4j minus k, and option C is the correct answer. 2i plus 4j minus k, 2i plus 4j minus k. Come on, moving to the next. All of you got this? Students, when you have phi, when you have a surface phi, then its gradient always represents a vector normal to that surface. Okay, so here we required unit normal vector, and that's why we have just taken the vector in the direction of del phi at the prescribed point 14. So here comes the last question from engineering maths, then we'll move towards the signals and system and analog circuits question. Students, if dy by dx plus 7x square y equal to 0 means this 7x square y can be brought to the other side. G sir. Separate the variables dy upon y equal to minus 7x square dx. Now what to do? After separating the variables, integrate both sides. So you will get log y minus 7 x cubed by 3 plus, you can add a constant here. So student, this is our general solution. General solution. Apply this initial condition. So I'm going to put this initial condition here. So when you put x equal to 1, y of 1 is okay. Y of 0, we have to follow this. Put x equal to 0. Put x equal to 0. X equal to 0. Y of 0 is 3 by 7. Y of value of y is 3 by 7. Okay, sir. X is 0, so this term will vanish. obtain the value of log 3 on 7. अब क्या करें? What to do next? Put this in equation 1. Is in equation number 1. Equation number 1. Equation number log y equal to minus 7 by 3 x cube plus c. C is log 3 by 7. Log 3 by 7. Yes, sir. So bring both the log terms on the one side. Log y upon 3 by 7 होगा. Log 7y upon 3 equal to minus x. Taking anti-log, we'll get 7y upon 3 to the power minus 7 by 3. So y is nothing but by 7 e to the power minus. What we want y of 1. So y of 1 3 by 7 e to the power minus, and they have given this as a e raised to minus 73. On solving this, on comparing both sides, you are getting 3 by 7. A equal to 3 by 7 should be our answer. Shubham, very good, beta, shabash. A equal to 3 by 7. A equal to 7. This was it. We have covered engineering mathematics section, and now we are moving towards signals and system. All set. Once need your comments, some motivation. Here comes the first question. Here comes the first question from your signals and system. For which of the following signals Fourier transform can be obtained from Laplace transform? Laplace of x of t. Ashok, is that the case? Am I audible? I believe that everything is fine from my end. I've just checked on the parallel system. Refresh your system once. If you would have connected some mics or Bluetooth, reconnect it. Laplace of x of t denoted by x of s. This is minus infinity to infinity e raised to minus st of t dt. Correct. At the same time, what is Fourier transform? In Fourier transform of x denoted by capital X e raised to is minus infinity to infinity x of t e raised to minus j omega t. So by comparing these two formulae, any of you can come to the conclusion that Fourier transform can be obtained from Laplace transform by just, yes, that is true, but this is true only for those signals which are absolutely integrable. This relation is true only for those signals which are absolutely integrable. Okay, which are absolutely integrable. Friends, if I draw the graph of 5 times delta t minus 3, so at the instance t equal to 3, we are going to get an impulse length 5. This is x1t. You can say that yes, this x1t is absolutely integrable, Yes, so that's why Fourier transform can be obtained from its Laplace transform. Option A is the correct one. Option C. Option C is a टेंट signal. टेंट signal है बेटा ये. Both sided exponential. Both sided exponential. We can say that it's again absolutely integrable. Also, its Fourier transform can also be obtained from Laplace. X4. X4 is signum function. Yeah, 2 of t minus 1 is nothing but signum function. Signum function is not absolutely integrable. Signum function is not absolute. Cannot obtain its Fourier transform from the result of Laplace. Option B. It is exponential rise. Exponential rise. You cannot Laplace. Cannot obtain its Fourier transform from the result of A and C are the correct ones. Since A and C are the correct ones. Shubham, very good response. Students, are you all following? Can I have your response? फटाफट respond कीजिए. Next. Which of the following impulse response is non-causal? Non-causal. Non-causal. An MSQ question. Delta t minus 3. The right side. Causal. This is located at t equal to minus 10. This is non-causal. U of t minus 3 minus u of t plus 4 is also available on the left side. So this is non-causal. Folding is involved. If folding is involved, it represents non-causal. So students, B, C and D are the correct. They are non-causal. Come on, respond. Moving to the next. B is also non-causal, beta. B is anti-causal. B is anti-causal, and anti-causal is a special case of non-causal. Delta t plus 10. So this is an impulse at minus 10. If your signal is present on the left side of 0, it is non-causal. Come on, respond fast. Everyone. Anti-causal is not a separate class. Anti-causal is a special case of non-causal only. Okay. Students, this is a question coming from FT. So x of e raised to j omega summation from n equal to minus j omega. We want x of e raised to j0. When you put x of e raised to j0, you will get summation n equal to minus in of n. This summation will go 1, will become 1. So we want x of e raised to j0, which is nothing but addition of all the samples of x. Here are x of x. Add all these samples. Add all these. Let's see what we are getting. Anji, -1 plus 0 plus 1, 1 and 2, 6, 7, 7 minus 1. This term is option A is the correct. Okay. So when option A 6, correct one. Now here we require x of e raised to j omega modulus square. It means this is a question associated with Parseval's theorem. Parseval's theorem states that minus infinity to infinity summation n equal to minus infinity to infinity mod to minus for 1 x of modulus. We want minus pi to plus pi. Yes, cross multiply by 2 pi on the side. Pi times summation minus in of n modulus. The students want this, want this, want this. What we have to do? We have to square these values of x of n and add them together. So squaring and adding 1 plus 1 2 plus 4 6 6 plus 1 7 plus 1 8 plus 4 12 plus 1 13 plus 1 15 2 pi into 8 pi 28 pi. Even this one is wrong, this one. So okay, let us check option C as well, since it is an MSQ question. Let us check the validity for option C. Minus pi to pi x of e raised to j omega d omega. Let us find. As DTFT formula, this can be obtained. Let us do that. Here, x of n is 1 by 2 minus pi to plus pi of e raised to j omega multiplied as d omega. Then you put n equal to e raised to, this integration is what we want. Pi x of 0. What is x of 0, bacha? X of 0 is 2. Take 4. Take our answer is 4. The correct answer. Pi is missing. Have your response. Come on, fast. Let's move to the next. See this question. Consider the following signals. Y of t equal to x of t. This symbol stands for convolution. X of t convolution h of t. G of t is x of t into h of t. So student, let us first construct this y of t. Okay, y of t convolution between convolution of t and h of t. Okay, Students, I am going to give you a trick. Find the convolution between rectangular. You already know width of same. The result of convolution will be a triangle. If the width of the two rectangular pulses are different, then the result will be trapezium. Okay, so we know that y of t will be triangular shaped. So in order to draw this y of t, we must be having its starting point and end point. So a starting point can be obtained by adding the starting points of the two rectangular pulses. 0 plus 2 will be giving you 2, and 4 plus 6 will be giving you 10. Their midpoint will be nothing but 6. Okay, so what is the other breakpoint? 4 plus 2 or 2 plus 4 will give you 6 only. Okay, these are the breakpoints. So we will get triangle shaped pulse by convolving x of t and h of t. Now the question arises, what is this amplitude? This amplitude can be obtained by a short trick without integration, without doing anything else. So what is the amplitude of this first pulse? 1. What is the amplitude of the second pulse? 1. And yes, what is the width? So when the widths are different, just take the width of the smaller pulse, smaller width. When the widths are same, then obviously the width can be same if you take from x of t or h of t. Here width is 4. So 1, 1, 2, width of the smaller pulse, that is 4. 4 will be the height of this triangle. So this is the result of convolution between x of t and h of t. So we already obtained y of t. Now let us determine g of t. G of t find करना है. G of t. G of t is nothing but the product of these two rectangular pulses. Product of two functions will be always carried the common interval. So 0 to 4 and 2 to 6. Common interval will be obviously 2. In the interval 2 to 4, all my dear students will be getting 1 into 1, that will be 8, 1, 1. Now, what is the domain of the signal g of t? Domain of the signal g of t is the span of the signal g of t. 4. Lying between 4. Yes, this option is absolutely correct. Option A is absolutely correct. Energy of the signal y of t. And y of t is a triangular pulse. For a triangular pulse, what is the formula for energy? Triangular pulse formula for energy: amplitude square multiplied by duration divided by 3. So amplitude, that is 4 square. What is the duration? 2 to 10. 8 to 10. What is the width of this triangular pulse? 10 minus 2, that is 8 upon 3. 8 into 15 upon 3. Obviously not equal to 8 joules. Option B is the wrong one. Wrong. Moving on to area of g of t multiplied by area of y of t. Arey bhai, what is the area of y of t? Half base height. Half base is 8 unit, height is 4 unit. So 8 fours are 30 on 2. What is the area of g of t? Area of rectangle. Height is 1, that is 2. We want area of g of t multiplied by area of y of t, that is 60. Multiplied by 2. They have mentioned it as 8 square units, so again a wrong one. Yes sir. Then energy of g of t is 8 joules. Energy of g of t is 8 joules. So energy of this rectangular pulse, simply a square t, that is already we have got the one, right? This, yes, come on, respond fast. Everyone enjoyed this question. Moving to the next. Which of the following signal operations affects the Nyquist state of the signal? MCQ. Which of the following signals are going to affect the Nyquist rate? Nyquist rate is affected by time scaling. Time shifting does not affect. Time folding does not affect. Amplitude scaling does not affect. Only scaling, because by time scaling operation, the compression or expansion is done in time domain. A reverse frequency scaling is done in frequency domain. Compression in time domain corresponds to expansion in frequency domain and vice versa. If signal is expanded or compressed, if the spectrum is expanded or compressed, then obviously its Nyquist rate will get affected, as its maximum frequency also gets changed. Comfortable, everyone? So let's move towards the questions from analog circuits. So we have got some 3 questions from analog circuits. All set? Yes, students, can I have your response? Come on, fast, yaar. Show some Josh in the comment box. Express your Josh. Can you see this? The transistor. Hi, Vishnu Gupta. Oh, thank you, Akila, Vishnu, Shubham, Ashok. Very nice of you. After this set of questions, your favorite Ashutosh Saxena sir will be joining. So 5 to 10 minutes from now, he will be joining with you, and just be ready for welcoming him. Yes, because he will be giving you your core subjects, electrical machines and power system, taking the questions from that particular. Students, Ashutosh Saxena sir is here here with us. You can just see his comment as well. Let's welcome him. Welcome, sir. Question once. Question पढ़ो ना भाई. Oh, thank you, Ashu. So, students, transistor in BJT amplifier circuit shown below has beta equal to R naught S 20 kilo ohms and thermal, that is VTS 20. Friends, what formula you can apply here in order to calculate IB and ICQ? You need to apply the DC analysis. DC analysis apply करेंगे. DC analysis, just for DC analysis, these capacitors will be open circuited. When these capacitors are open circuited, we are going to apply a KVL. Okay, sir, I'm going to hide myself for seconds. Anji, come on, fast, respond. Am I visible? No, sir, because my solution will be visible now. What is this KVL? KVL says that 12-volt battery will be equal to the current flowing through this 220 kilo. Current flowing through this will be Q, IB kilo ohm, multiplied by IB plus, yes, 0.7 volt. That is a drop between base and emitter. And IB, just work out and comment in the comment box. 7.3 upon 2 kilo. After getting IBQ, you need to work out on ICQ. ICQ will be simply ICQ simply beta times IBQ, as your transistor is operating as an amplifier. Beta is given as 60. 60 multiplied by this 11.1220. Of course, you will answer in milliamperes. It will be 0.4. Just make a note of this. 8.4. Comfortable, everyone? ICQ is 8.44 milliampere. Now, we are supposed to find out the value of RE. RE will be E upon ICQ. Formula wise approach. E is 26 millivolts divided by ICQ, that is 8.4 milli and milli, answer in ohm. Just a moment. This one is 3.082. Just work out 0.08. RE should be 8.4. You have pre-calculated results for you. Your time 8 point the value of RE. You got the value of RE. After getting the value of RE, you can proceed for calculation of AV, that is the voltage gain. Voltage gain is minus R naught parallel with R. Calculate this. Similarly, calculate the output impedance. Hello Vicky, how are you? Vicky Gamer here with us. Output impedance will be R naught parallel with RC. This is the formula wise approach. The same can be obtained in the analysis also. Analysis, if you want to perform, then you need to draw the AC. R naught parallel with RC. R naught, is it given in the problem? Yes, of course. 3 kilo. Parallel with, what is RC? RC is 2.2 divided by RE. RE is, student, this minus sign indicates that say inverting amplifier. Okay, work on this calculation and let me know the answer for what is Z naught. R naught parallel with RC. R naught कितना है भाई? R naught what is RC? RC, friends, here are your options. What are the answers? Let me know please. Z naught is 1.98. Yes, obviously it should be 2.2. 1.98 and no other option matching AV. Obviously option A will be the minus 238. Comfortable everyone? Moving to the next. You can see here the upper part is representing an amplifier and the lower part is representing the tank circuit of an oscillator. Friends, they have mentioned that it is an Hartley oscillator. For Hartley oscillator, they want the oscillation frequency of oscillation for Hartley oscillator 1 upon 5 of L. Okay. L equivalent will be the addition of these 0.78, 0.7. micro multiplied by capacitor. Capacitor 1 micro. Just work out this calculation and let me know on wage oscillator order of megahertz. Why of the order of megahertz? Because the oscillator, radio frequency oscillator. So I'm having answer is 800 kilohertz, 0.8 megahertz, nearly 800 kilohertz. Have you got this answer? Yes, 795. Perfect, perfect, Shubham Dayal. So frequency of oscillation is coming out to be 800 kilohertz. Students, I just remind you that there are two types of oscillator. Number one, RC oscillators. Number two is LC oscillators. For RC oscillators, you have the examples as RC phase shift oscillator and Vane's bridge oscillator. And in case of RF oscillators, you can have crystal oscillator, Hartley oscillator, and yes, Claps oscillator is also modification of Colpitt's oscillator. So here comes the last question from my side, and then your favorite Ashutosh sir will be joining. If the forward bias diode voltage VD is 0.7 volts, potential is diode current ID is diode current. Very simple. We are assuming this diode to be forward biased, and let Vx will be voltage divided. X will be total voltage in volt divided by same impedance divided by total impedance 20k plus 10k, that is 30. Just cancel this 10 numerator and denominator. Get 30 by 3, that is 10 volts. Correct? 10 volts. Vx is 10 volts. Is 10 and this 0.7. We can apply the key. 10 equal to 0.7 20k times ID. What is ID? ID will be 10 minus 0.7, that is hello 9. Obviously your answer in 0.47 amperes. Yes, correct. Answer type question. I hope you all have enjoyed the set of questions my side as well, and just welcome your favorite Ashutosh Saxena sir. And here I am stopping my part. Thank you, students.
Hello friends, I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. Thank you so much Rakesh Sir, Ashu Sir and Ankit Joshi Sir. आई होप कि आप लोगों ने बहुत जबरदस्त तरीके से इस सेशन को अटेंड किया होगा दोस्तों, और विश्वास मानिए कि इस तरीके के सेशंस बायजूस एग्जाम प्रेप आपके लिए लास्ट जब तक आपका एग्जाम है लाता रहेगा। और हमने बहुत सारे और भी कुछ सेशंस प्लान कर रखे हैं, इतने इंपॉर्टेंट सेशंस हैं। आप चुपचाप शांति से अपनी सेल्फ स्टडी करते रहिए और बायजूस एग्जाम प्रेप पे जो सेशंस आ रहे हैं, जो सीरीज आ रही हैं, उनको रिलीजियसली ऑनेस्टली अटेंड करते रहिए और आप देखेंगे कि आपके स्कोर में, रैंक में कितना इंप्रूवमेंट होगा। तो एक बार जल्दी से मुझे सब लोग बता दीजिए ऑडियो विजुअल क्लियर है। एंड एक चीज मैं क्लियर कर दूं, आई विल बी स्पीकिंग बोथ इन इंग्लिश एंड हिंदी इक्वली। हिंदी वाले लोग भी हैं यहाँ पर? एक्साइटेड? यस। शुभम, बनोत। तो चलो सेशन की शुरुआत थोड़ी मस्ती से करते हैं। एक छोटी सी शायरी मैं अभी लिख रहा था जब अंकित सर आपकी क्लास ले रहे थे, मैंने सोचा थोड़ा मजेदार करते हैं सेशन को। तो शायरी तो हिंदी में ही हो सकती है, थोड़ी बहुत उर्दू मिक्स होगी, ठीक है? तो तय है तुम्हारा एग्जाम में सिलेक्शन होना। तय है तुम्हारा एग्जाम में सिलेक्शन होना, बस अगले 1-2 महीने मत करना मेरा बाबू मेरा सोना। So just remove every single deviation from your mind and be as focused as possible. And this is going to be your year, your exam, and definitely you will get a good rank. So let us start with the session. We are starting with power system and then we will be talking about machines. Power system, we have 7 questions, 3 questions of 1 mark and 4 questions of 2 marks, and we have all the MSQs, NATs and MCQs questions. And for machines also, we have 3 questions of 1 mark and 3 questions of 2 marks, so total 6 questions for machines. So just once everybody just share the session with your friends and colleagues. एक बार जल्दी से share कर दीजिए। अगर आपने सब्सक्राइब नहीं किया है तो सब्सक्राइब कर दीजिए and let us start. Let us see the first question. 1 mark question, very easy question. Single phase load supplied by a single phase voltage source if the current flowing from load to source is 10 angle minus 160 and if the voltage at the load terminal is 100 angle 60, what is the nature of power? उसने आपको लोड के टर्मिनल का वोल्टेज दे दिया है और लोड से सोर्स की तरफ जाती हुई करंट दे दी है और वो पूछ रहा है कि लोड का नेचर क्या है, रियल और रिएक्टिव पावर का, एब्जॉर्ब कर रहा है या सप्लाई कर रहा है। तो इस क्वेश्चन को सबसे पहले हम डायग्राम बनाएंगे। सपोज ये आपका सिंगल फेज लोड है और सिंगल फेज सोर्स है। यस अशोक, प्लीज वेट। और ये हो गया सिंगल फेज सोर्स। वोल्टेज टर्मिनल कितना दे रखा है? टर्मिनल का वोल्टेज 100 एंगल 60 डिग्री, तो ये हो गया 100 एंगल 60 डिग्री। और लोड से सोर्स की तरफ जाती हुई करंट कितनी दे रखी है? इट इज करंट इज गिवन एज 10 एंगल माइनस 160। इट इज 10 एंगल माइनस 160 डिग्री। Suppose you want to write the complex power for the load, so you can write it as VI complex conjugate. Now here, what is this current I? This current I is the current taken by the load, because what is the basic nature of load? The basic nature of load is to take the current, to absorb the power. Yes or no? Yes or no? So this I is going to be minus of 10 angle minus 160 degrees. So this is the current you have to apply here. Now use the phasor diagram. Use the phasor diagram. Suppose this is your reference. What is the voltage? Voltage is 100 angle 60 degree and the current is 10 angle minus 160. So let me use another color. It is 10 angle minus 160 degree. But the current which is taken by the load from the source is going to be opposite to this. So just reverse it. Just reverse this current. So this is going to be your current I, which is minus of 10 angle minus 160 degree. Now you have to mark the angles. अब जल्दी से आपको एंगल बताना है इसमें. ये एंगल तो 60 डिग्री है. This is the 60 degree angle for voltage. This angle is 160 degree. It is given. This total angle is 180 degree. So this angle becomes 20 degree. So if you rewrite this current I, it is going to be magnitude same, 10 angle 20 degree. Yes or no? Yes. Now you can write the complex power for the load. It is going to be S is equal to VI complex conjugate. V is 100 angle 60 degree. Current is 10 angle 20 degree, but you have to take the complex conjugate. So it becomes 100 angle 60 degree, and this is 10 angle minus 20 degree because complex conjugate is there. Now multiply. Magnitude becomes 1000 and phase angle becomes 60 minus 20 degree, so it is 40 degree. Now you can simplify it as 1000 cos 40 degree plus J sine J it is 1000 sine of 40 degree. So this is also a positive quantity and this is also a positive quantity. So you say the load absorbs both real and reactive powers. Is it clear for everybody? किसी को कोई दिक्कत? शुभम सी कैसे आ रहा था? अभी तो किसी ने ए लिखा था. अभी किसी ने ए लिखा था, फिर सी कैसे हो गया? एग्जाम में मत करना ए का सी का ए. Everybody is comfortable with the question? Yes, Ashok? Anywhere if you have any problem, कहीं पर भी कुछ भी डाउट लगे तो पूछ लीजिए. मैं किसी हड़बड़ी में नहीं हूँ. मेरा एम ये है कि आपको कॉन्सेप्ट समझ में आना चाहिए. एग्जैक्टली सेम क्वेश्चन तो दुनिया में कोई नहीं कह सकता कि भाई गेट में आएगा, बट कॉन्सेप्ट जरूर रिपीट होगा. और कॉन्सेप्ट अगर आपको समझ में आ गया तो फिर दुनिया की कोई ताकत आपका सिलेक्शन रोक नहीं सकती. कॉन्सेप्ट इंपॉर्टेंट है. चलिए दूसरे क्वेश्चन पे चलते हैं. लेट अस सी द नेक्स्ट क्वेश्चन. अ सिंगल फेज 50 हर्ट्ज जनरेटर सप्लाइज एन इंडक्टिव लोड ऑफ 5 मेगावाट एट अ पावर फैक्टर ऑफ 0.7 lagging by means of an overhead transmission line of 20 km long. The line resistances and inductances are mentioned as 0.019 ohms and 0.62 millihenry per kilometer. The voltage at the receiving end is required to be kept at 10 kilovolt. Now this is the MSQ question. MSQ question is going to be a fascinating thing for you in GATE 2023 because it is pretty sure that you will get significant number of MSQ questions this year. Be ready, all electricals. जितने भी लोग इलेक्ट्रिकल से हैं इस बात को अपने दिमाग में बिठा लो, मेंटली तैयार होकर एग्जाम में जाना कि मल्टीपल सेलेक्ट क्वेश्चन आपको 10 से 15 क्वेश्चन मल्टीपल सेलेक्ट क्वेश्चन इस बार मिल सकते हैं. और घबराने की कोई जरूरत नहीं है. मल्टीपल सेलेक्ट क्वेश्चन में सिर्फ एक चीज का ध्यान रखना है, किसी भी ऑप्शन को आप इग्नोर नहीं कर सकते. और एमएसक्यू क्वेश्चंस थोड़ा लेंदी होते हैं क्योंकि उसमें हर एक ऑप्शन में एक आंसर छुपा हो सकता है. सो इट वुड बी माय एडवाइस कि जहां तक हो सके एमएसक्यू क्वेश्चन को आप एंड में ही अटेम्प्ट करें तो अच्छा है. आर यू गेटिंग दिस? सो वंस यू आर एबल टू consolidate the MCQs and NATs questions and you have significant buffer of time, go for the MSQ. Because MSQ में अगर आपने एक भी ऑप्शन हड़बड़ी में जल्दबाजी में छोड़ दिया तो बना बनाया क्वेश्चन बिगड़ जाएगा. लिसन अशोक, आप शायद कर चुके हैं क्वेश्चन पहले इसलिए आपको तुरंत पता है. सी, if I have to write the magnitude of the sending end voltage for the short transmission line, you can write it as the receiving end voltage plus the voltage drop. What is going to be the voltage drop? It is going to be IR cos phi plus IX sin phi. This is the approximate relation, but it is valid here. This is the approximate relation. We have taken the reference from the voltage regulation, you can say. So I know what is the receiving end voltage. It is 10 kilovolt. I know what is the R value. it is 0.019 multiplied by what is the length of the transmission line? It is 20 kilometer long. It is 20 kilometer long. What is the X value? The X value is 0.62 millihenry. Okay, so X value is going to be 2 pi f, that is omega, into L, and this L is going to be 0.62 millihenry, so 10 to the power minus 3 multiplied by 20 kilometer. Put the value of 2 pi f. That is what I am telling you, how to handle the MSQ questions. Keep the MSQ questions in the later part of your examination, because MSQ question, every single option you have to weigh, every single option you have to see, analyze. It requires some time. MSQ questions are not at all different as per the conceptual base from MCQs or NATs. The approach is different. The approach is that whatever question is given, you have to analyze all the 4 options given. So it will take some more time. So it is better first you consolidate the MCQs and NATs, and then you go for MSQs. Okay. So you can put the R and X value. What is the power factor? Power factor is given cos phi as 0.7. Okay, so you can write what is sin phi. Sin phi becomes sine of cos inverse 0.7. Both of them you can calculate. Now the only thing remaining here is what is the current. So can you calculate the current? Yes. The load is given. Load is given. 5 megawatt load is being supplied at a power factor of 0.7 lagging, and the voltage is 10 kilovolt. So you can write the current here. It is 5 megawatt, 10 to the power 6. Voltage is 10 kilovolt. What is the power factor? 0.7. Let's calculate it. Calculate it and tell me what is the value you are getting. As for my reference, you must be getting 714. We are not interested in the phase angle here because we are dealing with the magnitude only. We are dealing with the magnitude only. Ashok, please calculate it. I think it should be 714. Anything wrong you are doing? Don't do these calculation mistakes. Somewhere around 714 amperes approximately you will be getting. Just put all the values. So you will be getting the sending end voltage. As per my reference, you must be getting, as per my reference, you must be getting 12.173 kilovolts. So in the question, let us see how to analyze MSQ questions. He is talking about 2 things: sending end voltage and the voltage regulation. So basically you have to find the sending end voltage and the voltage regulation. Sending end voltage we have found it is 12 point something, so option A is going to be the correct one. Let us see what is the voltage regulation. A becomes the correct answer here. What is the voltage regulation? For the short transmission line, if I have to write the voltage regulation, mod Vs mod A minus mod Vr upon mod Vr and multiplied by 100 if you want in the percentage. Now mod A value is going to be 1 for short transmission line, so simply you can write mod Vs minus mod Vr upon mod Vr multiplied by 100, so it becomes percentage. So you must be getting the voltage regulation as 21.73%. Everybody is getting that. Everybody is getting that. So A and B are going to be the correct options. Is it clear for everyone? Is it clear for everybody? Any doubt you have conceptually, any doubt, any problem you have, you can ask me. I'm ready to explain n number of times. I am not in hurry, and you should also not be in hurry. See the next question. A short transmission line has Z series impedance in per unit. Which of the following voltage regulation value is possible to get at leading power factor at full load condition? Very interesting question. This question gives you a complete idea. Yes, resistance is also in per unit length. Actually, the way it is given in the question is a little confusing, but you can understand with the value. From the value you can understand, Shubham. It should be ohms per kilometer separately. Okay. Let us see the next question. To answer this question, you must know the variation of voltage regulation with respect to the load power factor angle. With respect to the load power factor angle. Suppose this is the voltage regulation. This is the power factor angle connected to the receiving end. So for positive values of phi angle, it is about the lagging load, and for negative values, it is for the leading load. Let us take the case of lagging load. The voltage regulation you are writing as R per unit cos phi plus X per unit sin phi R. This is for the lagging load. Now suppose phi R is 0. When phi R is 0, cos 0 is 1, sin 0 is 0. So at this point, you are getting voltage regulation as R per unit. Voltage regulation is simply R per unit. Phi R is equal to 90 degree. Phi R is equal to 90 degree somewhere here. Here phi R is 0 degree. At phi R 90, cos 90 becomes 0, sin 90 becomes 1. So voltage regulation becomes X per unit. Now I am mentioning X somewhere here higher than R per unit because for transmission line X by R ratio is very high. So X is a greater value than R per unit. So you are getting this as the voltage regulation at phi R 90. Now in between 0 degree and 90 degree, there is one angle at which you get the maximum voltage regulation condition, and that angle is phi R is equal to theta, where theta is the impedance angle of the transmission line. Suppose somewhere here phi R is equal to theta, you are getting the maximum voltage regulation, and this maximum voltage regulation is value is Z per unit. Suppose you are getting Z per unit somewhere here. Z per unit somewhere here. Now, if I have to connect the dots, so it is going to be something like this. This is the variation of voltage regulation for the power factor angle. Now let us go to the leading load. For leading load, phi R becomes negative. Okay, phi R becomes negative. So you must be aware that in the leading load condition, somewhere phi R is equal to 90 minus theta. When phi R is 90 minus theta, you are getting 0 voltage regulation. So you are getting 0 voltage regulation at phi R is equal to 90 minus theta. For the leading load, the maximum value which you can go is minus 90 degree. So minus 90 degree voltage regulation comes out as minus X per unit. So it is somewhere here. This is phi R is equal to minus 90. And because you are using the lagging load voltage regulation formula for finding the voltage regulation for the leading load condition, that is the reason you are getting a negative value of the voltage regulation. So don't worry with the negative value. बात समझ में आ रही है सबको? Are you getting my point? Now this is going to be something like this. Please ensure that this point phi R minus 90 belongs to the negative peak of the voltage regulation. It should be the negative peak of the voltage regulation. Now there is something important for you to note down. If you closely observe this characteristic, you can see for all the lagging load condition, when it is a lagging load condition, voltage regulation is always greater than R per unit, and it is always positive. It is always positive. Whereas if you see for the leading load condition, voltage regulation is always less than R per unit. It can be positive also, it can be zero also, it can be negative also. Yes or no? Hello, are you able to follow this? Possible me I? Now, what is R per unit? R per unit is given as 0.08. If you write in percentage, you can write it as 8%. Now he is saying what is the possible voltage regulation for the leading power factor angle at full load condition. So in any case, for leading load, the voltage regulation must be less than R per unit. So if it is 8%, voltage regulation must be less than 8%. 20% not possible, 12% not possible, 8% not possible. Only possibility is 4%. Is it clear, everybody? Hello? Are you able to follow this? See the next question. See the next question. Very important question. 2 marks MCQ question. A 3-phase induction motor of 500 horsepower has 90% efficiency at 0.8 lagging. Now understand, whatever data you are getting in the question, that is not just data. That is like the GPS of the question. It gives you a direction where you have to go. The moment rated power of the motor is given, any motor is given in horsepower, you understand this is the output power, because for motor, the output power is always in the mechanical terms. So output power is given, efficiency is given, what you can find? Input power. Efficiency deals with real power. So you are getting real power from the efficiency. Why he is giving you power factor? Because you can find the reactive power input also. So from the very first statement of this question, you can find what is the real and reactive power taken by this motor from the system. Everybody just tell me yes or no. Are you able to follow this? From the very first statement you can understand. So if I say P induction motor plus JQ induction motor is the real and reactive power taken by this motor from the supply, then it is okay. Now, how you can write efficiency of the induction motor? Output power upon input power. From here you can write the input power as output power upon efficiency of the induction motor. Input power we are writing as P induction motor, that is the power taken, real power taken by the motor from the supply. What is P output? It is 500 horsepower. 1 horsepower is approximately equal to 746 watts of power. What is the efficiency given in the question? Efficiency given is 90%. Just put 90% here. Okay, put 90% here and tell me what is the value you are getting. The moment you get the real power from the power triangle for the induction motor, if this is P induction motor, this is Q induction motor, this will be the complex power. P induction motor is square plus Q induction motor is square. This will be the power factor angle of the induction motor. So can you tell me what is the Q induction motor? That is P induction motor than phi induction motor. What is the P value you are getting? 414.44, and this is kilowatt. Are you getting it in kilowatt? Yes. Just put it here, 414.44. And what is phi m? Phi im is cos inverse. What is the power factor of the induction motor? It is given. Power factor is 0.8. So just write it cos inverse 0.8. solve this, I think you must be getting somewhere around 310.83 something. This is kVAR, kilovolt ampere reactive. Yes or no? So you got the P and Q for the induction motor. Further, he is saying a loaded 120 kilowatt synchronous motor is connected so that the overall power factor becomes unity. Now you have connected a synchronous motor here. Okay, I think my head is coming in between. Now is it okay? Shubham, please check your calculation. Now you are able to see the synchronous motor. Now this synchronous motor is taking the real power from the supply and supplying back the reactive power. So basically it is a synchronous phase modifier. You getting this? This is what synchronous phase modifier does. It has some practical load connected to its shaft, and at the same time, because it is overexcited, so it supplies lagging reactive power to the system. That is how it improves the power factor. And synchronous phase modifier, we know, is the most practical device for power factor improvement. Now, listen very carefully. The important point is he is saying the amount of reactive power supplied by this synchronous phase modifier is such that you get a unity power factor. What is the meaning of unity power factor? Unity power factor becomes 1. What is the phi value? 0 degree. Now, if this is the real and reactive power coming from the supply side, for this system, if this is P, this is Q, this is P square plus Q square complex power, and this is phi. How phi becomes 0? Phi can become 0 if you keep on reducing the Q. The moment Q becomes 0, your phi becomes 0. So for unity power factor, the reactive power burden on the supply should be 0. This is the concept. The moment you have this statement in the question, in the GATE examination, the moment you have this statement in any question in the examination, that by doing such and such, the overall power factor becomes unity, right at that moment you understand that the reactive power burden or the responsibility on the supply is 0. So if the reactive power burden on the supply is 0, it means what? This Q must be 0. This Q must be 0 means whatever reactive power is supplied by the synchronous motor, that has to be satisfying the reactive power burden or the requirement of the induction motor. So can you tell me what is going to be Q synchronous motor? It is nothing but Q induction motor. That is 310.83 kVAR. The real power taken by the synchronous motor is given, that is 120 kilowatt. So if you draw the power triangle for the synchronous motor, this is P synchronous motor, this is Q synchronous motor, this is P synchronous motor is square plus Q synchronous motor is square under root. This is phi synchronous motor. So what is the power factor? Operating power factor of the synchronous motor, it is P synchronous motor divided by the total complex or apparent power. Just put the values and tell me what is the answer you are getting. One candidate has already solved it. It is 120 kilowatt divided by 120 10 to the power 3 you can avoid because all the values are in the kilowatt and kilovolt ampere itself. This is 310.83 10 to the power 3 whole square. So you must be getting somewhere around 0.36. But the question does not end here. You have to answer whether it is leading or lagging. Whether it is leading or lagging. You tell me. You tell me. I am giving you a very funny way of identifying whether it is lagging or leading. You are talking about synchronous motor. You are saying synchronous motor is supplying the reactive power to the system. Which reactive power it is supplying? It is supplying lagging reactive power to the system. But what is the basic nature of motor? The basic nature of motor is to absorb power. So if this motor is supplying lagging reactive power to the system, this whole idea you can represent it as the system is supplying leading reactive power to the motor. This is the basic nature of motor. So what is the operating power factor? It is leading. What is the operating power factor? It is leading. So it has to be lead. It has to be lead. What is the correct answer? 0.36 leading. Is it clear everybody? Let us go to the next question. चलिए दूसरे क्वेश्चन पे चलते हैं. Four identical insulated discs are connected in the form of a suspension type string insulator. The ratio of shunt and the mutual capacitance is 0.2. If the total string voltage is 40 kilovolt, then the string efficiency will be if the static shielding is connected with the bottom two units. Very interesting, very smart question. Suppose this is the situation. This is the situation. How many insulated discs are there? First thing you have to identify. There are four identical insulated discs. So just draw the equivalent circuit. These are the mutual capacitances. If there are four insulated discs, so number of mutual capacitances will also be 4. And the number of shunt or stray capacitances will be 1 less. This is your conductor. So this is your C dash. So this is, my dear, C dash, C dash, C dash, that is the shunt or stray capacitance. And this is the mutual capacitance C, 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 C. Now, he's saying there is a static shielding or guard wire, and it is only compensating the bottom two units. What is the meaning of providing static shielding? Static shielding basically compensate for the charging current. What are the charging currents? This is I4, this is I3, this is I2, this is I1. Here it is I1 dash, here it is I2 dash, here it is I3 dash. So why you are getting the non-uniform voltage distribution across the various units? The reason is I1 dash, I2 dash and I3 dash. And I1 dash, I2 dash and I3 dash, because of the stray capacitances, they are having the same nature as if they are charging current for your transmission line, sent from the sending end but does not reach to the receiving end. Whereas I1, I2, I3, I4, they are the leakage current from the live conductor. This is your guard wire. This is your guard wire. So what this guard wire does, it exactly compensates for these charging currents so that the voltage distribution becomes same. Now question is saying only the bottom two units are being compensated. So now open your brain and understand something very crucial I'm going to discuss here. Something very, very crucial. If I'm saying the voltage across the first unit is V1, voltage across the second unit is V2. Now please understand, if I2 dash is compensated, I3 dash is compensated because bottom two units are compensated, so these two charging currents are compensated. So can I write I2 is equal to I3 is equal to I4? If yes, so can I write V2 is equal to V3 is equal to V4? Yes. What is V2? V2 is V1 1 plus K. What is the K value? K is C dash upon C, that is 0.2. So it becomes 1.2 V, which is equal to 1.2. If you have V2, V3, V4 all related with the V1, you can very easily write the string efficiency. Now there is nothing left. Now the string efficiency becomes the voltage across the string V1 plus V2 plus V3 plus V4. divided by number of insulated units multiplied by the voltage across the unit nearest to the conductor, that is V4. You can write it as V1 plus 1.2 V1 multiplied by 3 divided by N was 4 and V4 was 1.2, that is V1. Just multiplied by 100 and tell me what is the percentage you are getting for the string efficiency. Yes, everyone. Yes, everybody, tell me. What is the answer you are getting? Tell me faster. I don't have a reference for this. You have to solve it. And I don't know why only 2 people are responding. Ashok, Shubham. बाकी बच्चे सीधे एग्जाम में करना है, उससे पहले कोई क्वेश्चन नहीं. Solve it and tell me what is the answer you are getting. Any one of you. What is the answer you are getting? None? You are getting 95.8. Shubham is getting 95.8. What about Mr. Ashok? Ashok, are you also getting 95.8? And see, this question basically tells you the basic idea that for static shielding, it is so effective that you need not compensate all the disk. Only the bottommost units, 2-3 units, if you compensate, it is going to be much effective. The reason is most of the non-uniform distribution of the voltages across the units, bottom units, that is the units nearest to the conductor. Is it clear, everybody? See the next question. This question belongs to the fault analysis, symmetrical fault analysis. A 50 Hz alternator is rated 500 megavolt ampere, 20 kilovolt. The direct axis and steady state and subtransient values of the reactances are mentioned. It supplies a purely resistive load of 400 megawatts at 20 kilovolt. The load is directly connected across the generator terminals when a symmetrical fault occurs at the load terminal. So basically you have to find the symmetrical fault at loaded condition. Loaded condition. Now take this analogy. एक छोटी सी बात से हम इसको समझेंगे. मान लीजिए एक छोटा सा एग्जाम्पल देते हैं कि एक कोई भाई साहब हैं, गेट की तैयारी कर रहे हैं, उनको किसी से प्यार हो गया. प्यार हो गया तो घर में बताना पड़ेगा, बात बढ़ सकती है. ठीक है, तो घर में जब वो बताएंगे भाई साहब, तो सबसे मुश्किल किसको मनाना होता है? फादर को. फादर को मनाना सबसे मुश्किल होता है. फादर इतनी जल्दी अपना माइंडसेट चेंज नहीं करते, और खासतौर से यूपी बिहार के जो फादर है वो बहुत ही खतरनाक टाइप के फादर होते हैं. उसी तरह से कुछ हो रहा है आपके जनरेटर में जब फॉल्ट होता है. When the symmetrical fault happens, there is one thing which does not change instantly before the fault and after the fault, and that is the EMF excitation, EMF in the alternator. That cannot suddenly change because that depends upon flux and the speed. Speed you cannot suddenly change. Flux you are not suddenly changing. Are you getting that? So the first thing in the loaded condition symmetrical fault analysis you have to do is you have to anyhow find what is EG double dash, because we are talking about the subtransient case. Just after the fault, it is initial RMS current he is asking. So we are interested in the subtransient case. So you find what is the excitation EMF during the subtransient case, and this is what you find is pre-fault. just before the fault has occurred, you find it. And this EG double dash is going to decide what is going to be the current. Okay, what is going to be the current supplied. So let us first draw the diagram here. You understand that this is your generator. This is the direct axis sub-transient reactance of the generator, and this is the generator terminal where load is connected. And there is a three-phase symmetrical fault happening like this. Is it clear? Now, what we are going to do is, first we will find what is EG double dash. This is given as JXD double dash. Okay. Load is given as 400 megawatt. In the question, it is given that it is a purely resistive load. It is a purely resistive load. Supplies a purely resistive load, 400 watts, megawatts, 20 kilowatt. Purely resistive load, so it is basically a unity power factor load. Cos phi is 1. Cos phi is 1. Is it clear, everybody? Now, suppose just before the fault, how you can write EG double dash? Pre-fault, EG double dash becomes pre-fault voltage, pre-fault current, and this is JXD double dash. What is pre-fault current and voltage? Now see, let us do it in the per unit. So we are assuming the MVA base to be the rating, that is the 500 MVA, and suppose the kilovolt base of the generator side is 20 kilovolt. Is it clear? So what is going to be V0? Now the pre-fault voltage becomes 20 upon 20, so it becomes 1 per unit. What about I0? What about I0? I0 you can find as the load. If you write the load in the per unit, it is 400 watts divided by 500, that is the MVA base, divided by the per unit voltage, that is nothing but the 1 per unit. So if you solve this, you will be getting I0 as 0.8 per unit. And because it is unity power factor, so no need to worry about the phase angle, it is simply 0.8 angle 0. So you can write the sub-transient excitation EMF as 1 plus, this is 0.8, this is J, this is 0.2. The sub-transient reactance given is 0.2 per unit. So in per unit, okay, in per unit, I'm writing in the next page, you will be getting EG double dash. Just tell me what is the value you are getting. I'm telling you from my reference, you also cross check it. Just solve this and tell me what is the value you are getting for EG double dash. I'm checking my reference for that. As for my reference, you must be getting it as 1.28 angle 38.65 degrees, and this is in per unit. I'm getting is 1.28, just confirm it. Oh, sorry, we have done a mistake. Sorry. Listen. this should not be xd double dash because this is pre-fault na. This is pre-fault, so pre-fault you have to use the steady state value na. So just put the steady state value here. Steady state value is how much? It is 1 per unit. Just put 1 per unit, okay? So this becomes J1 simply. This becomes J1. Now you find EG. Then you will be getting this value. Okay. Now you will be getting 1.28 angle 38.65 degrees in per unit. Now if you see the circuit for the generator, when the fault happened, post fault, the fault current is being decided by this only, that is EG double dash. So fault current will be EG double dash divided by JXD double dash. So this is 1.28 angle 38.65 divided by XD is 0.2 angle 90 degree. As per my reference, you must be getting somewhere around 6.4 angle minus 51.35 per unit. Are you getting that? Everybody just confirm. So you must be getting 6.4 per unit as the initial RMS current in the generator. Is it clear, everybody? Okay. See the next question. Now the next question belongs to the bias differential relay. Okay. So he's saying there is a high resistance fault occurred near the neutral end with the given current distributions. Slope of the relay is 10% and the pickup current of the relay is 0.15 ampere. CT ratio is mentioned 500 upon 5. He's asking determine whether the relay will operate or not. Okay. So let us see the circuit. Let me just make a little correction in this circuit. This is your line. Okay, this is your line. And this is being protected by using two current transformers. These are two current transformers, CT1 and CT2. Now, if you see the currents, current I1 is flowing here is 435 amperes and current I2 flowing here is 400 amperes. So if you see the reflections of the current in the secondary of the current transformer, then this is small I1 is going to be a small value of current. So 435 you have to divide by 500 and multiply by 5. You will get 4.35 ampere. This is how you get the current in the secondary of CT1. Current in the secondary of CT2 is 400 divided by 500 into 5. It becomes 4 ampere like this. If a small I1 and a small I2 currents you know, so this becomes 4.35, this becomes 4, so their difference comes out to be 0.35 and this is the current flowing in the operating coil. This is the operating coil of the relay operating coil, and this is the restraining coil. Operating coil gives you the operating force and restraining coil gives you the restraining force. In the bias differential relay, just a moment. Yes, in the bias differential relay, if it is without bias, then how you do it? How do you come to know whether the relay will operate or not? So what you do is you find the relay operating current and you say if it is more than the pickup current, then relay operates. This is the basic idea for differential relay. Yes or no? The differential current flowing in the relay operating coil, if it is more than the pickup value of the current, the relay operates. This is without restraining coil. When you have the restraining coil, with restraining coil, the current in the ROC, it has to handle two responsibilities. Number one, to become more than the pickup value, but also it has to compensate for the ampere turns of the restraining coil, because restraining coil is producing some restraining force not to operate. So if the relay has to operate, it has to first compensate for the restraining coil ampere turns, and then it should be more than the pickup value. So with restraining coil, the equation becomes IROC should be greater than the pickup current plus, for the restraining coil, it is K I1 plus I2 by 2. Okay, are you getting that? Hello, everybody is getting that? How I have written this equation? The relay operating coil current, it is simply I1 minus I2 magnitude. If it is no restraining coil, then this current has to satisfy only the pickup current. But because restraining coil is also there, so this is the amount of current in the relay operating coil which is going to compensate for the restraining force or ampere turns of the restraining coil. Is it clear now? What is this K value? This K value is the slope of the differential relay, and slope of the differential relay is given as 10%. That is nothing but I1 minus I2 magnitude divided by I1 plus I2 divided by 2 and magnitude. This is 0.1. 10% becomes 0.1. This is nothing but the K value, slope of the differential relay. Just put all the values. What is IROC? We have just seen it is 0.35. Then what is pickup current? Pickup current is 0.15. Then what is I1 plus I2 by 2? Put the values, 4.35 plus 4 divided by 2. Okay. So if you observe, you will see that left hand side you are getting 0.35 and it should be greater than 0.15 plus 4.35 plus 4 divided by 2, which is not possible. If it is not possible, hence the relay will not operate. Everybody just tell me in the comment section, are you able to follow this or not? Are you getting the idea of bias differential relay or not? So the relay will operate or not? No, the relay will not operate. Let us see the next question. So let us come to the electrical machines part. Let us see the first question. The first question talks about the reactance voltage. How you define the reactance voltage? Yes. How you write the reactance voltage? Reactance voltage you are defining as L di by dt. Now L is the self-inductance of the commutating coil. Self-inductance of the commutating coil. Now Di is the total change in the current in the commutation period, so it is 2IC. From plus IC to minus IC, it is 2IC. Total time of the change is TC, that is the commutation period. Commutation period. So in the question, L value is mentioned. L value is given 153 10 to the power minus 6 Henry. What is current? What is current IC? IC is nothing but the current in the parallel path. So total armature current divided by number of parallel paths is going to be the current in the parallel path. So this is 108. Number of parallel path is equal to number of pole because it is a lap bound machine. So if you solve it, 27 amperes. Is it clear, everybody? Now, the only thing we have to do is we have to find the commutation period. He is saying the generator is running at 900 RPM. Number of commutator segments are 55 and width of the brush is 1.74 segments. So if the speed is 900 RPM, what does it mean? It means 1 minute you are making 900 revolutions. Yes or no? Can you tell me what is the time for one revolution? It is 1 upon 900 minutes, but I want in seconds, so it is 60 upon 900 seconds. Now this is the time for one revolution. If you closely observe your DC generator, something like this. This is north, this is south, these are the brushes. Something like this. Suppose the generator is rotating in this direction and you are the stationary observer standing here. So in one complete revolution, how many commutator segments you are going to see? All the commutator segments? You will see all the commutator segments in one revolution. How many commutator segments are there? Total 55 commutator segments are there. So for 55 commutator segments, the time for one revolution, that is 60 upon what is the time for one revolution? 900 divided by 900. Okay, but for crossing the brush width, only 1.74 commutator segments has to be passed. 1.74 segments has to be passed. So what is the time for one commutator segment? It is going to be 60 upon 900 divided by, sorry, it is not 50, it is 55. It is 55. So how many commutator segments are equivalent for the brush width? It is 1.74. For 1.74 segments, what is the time? It is 60 upon 900 and this is 55 multiplied by 1.74. Just find this value and this is going to be your commutation period. Put this value in this equation. And you will be getting the reactance voltage. as for my reference, let me check as for my reference what is the answer. It should be 3.915. 3.915 volts. Anybody is getting that? So the basic tip for this question was that how to deal with the commutation period from the given data. So B is the correct option, 3.915. See the next question. A 6-pole 148 ampere DC shunt generator has 480 conductors and is wave bound. Its field current is 2 ampere. Find the cross magnetizing ampere turns per pole at full load if the brushes are along GNA. Now you know just a moment. Just a moment. The screen is clear now? Yes. Suppose this is your DC generator. These are the brushes. Okay. These are the armature conductors. This is north pole, this is south pole. He's saying the brushes are along geometrical neutral axis. Geometrical neutral axis is the axis which is always perpendicular to the main field flux. So this is going to be your GNA. When brushes are along GNA, then all these armature conductors are only and only going to give you cross magnetizing effect, no other effect. Hello? So in this case, the total cross magnetizing ampere turns are going to be nothing but the ampere turns of the armature winding per pole, that is nothing but IAZ upon 2AP. Okay, let's put the values. What is IA? He's saying it is a DC shunt generator. So how you make the DC shunt generator? Just see here. This is your shunt generator. This is armature resistance, shunt field resistance, and this is a generator, a motor. This is generator. So definitely this terminal, some load is going to be connected. This generator is going to be supplying some load if it is connected. So this is the load current supplied. This is the armature current, and this is the shunt field current. Now the current mentioned here, he is saying it is a 148 ampere DC shunt generator. So this is the load current. This is the load current supplied by this generator. Field current is 2 ampere. So IA becomes 148 plus 2, that is 150 amperes. So armature current is 150. Total number of conductors Total number of conductors are mentioned as 480. So this is 480. 2 number of parallel path, because it is a 6-pole and it is a wave bound. So for wave bound, the number of parallel path is always by default 2. So it is 2 and number of poles are 6. Just solve this. So you must be getting 3000 ampere turns. And all these are for cross magnetizing. So what is the correct answer you are getting here? 300. See the next question. Now this is for the induction motor. This is for the induction motor. He's saying there is a 3-phase induction motor having the starting torque as 1.5 times the full load torque. 1.5 times the, it is 1.5 times the full load torque, like this. In the second case, he's saying the maximum torque is 2.5 times the full load torque. So now the maximum torque is 2.5 times the full load torque. He's asking calculate the starting current in per unit. What is the meaning of finding the starting current in the per unit? So basically starting current divided by the full load current is going to be the starting current in per unit. Okay. So how you write the torque equation? Now starting torque divided by full load torque is given as full load slip, and this is the starting current divided by the full load current, and do the square. This is the formula basically you have to follow here. Full load slip, starting current, and full load current square. Is it clear? So what is the full load slip? What is the full load slip? We have to identify. And what is the starting current and full load current ratio? Now this starting current to full load current value is basically asked in the question. Do you have the ratio of starting torque and full load torque? Starting torque and full load torque, yes, it is 1.5. Starting torque to full load torque, it is directly mentioned, it is 1.5. So anyhow, if you can find the full load slip, very easily you can find what is this I starting per unit. Yes or no? Say yes. Now let us see what are the equations we are having. Let us first relate the full load torque and the maximum torque. Just a moment. Yes. So what is the expression for full load torque upon maximum torque? It is 2SSN upon 2SSN divided by S square divided by S square plus Sn square. S is the full load slip here, and Sm is the slip at maximum torque condition. Maximum torque condition. Is it clear? Now The same thing you can write for the starting torque with respect to the maximum torque. Just put S is equal to 1 because at the time of starting, S becomes slip becomes 1. So it is 2Sm upon 1 plus Sm square. What is the starting torque and maximum torque ratio? What is the starting torque and maximum torque ratio? For the starting torque and maximum torque ratio, say this is equation number 1, this is equation number 2, and just divide equation number 1 by equation number 2. So you will get a starting torque with respect to the maximum torque as 1.5 divided by 2.5. Yes or no? So just put the value. If you put the value starting torque upon maximum torque 1.5 upon 2.5, you can find what is the value of maximum slip. Sorry, slip at which you get the maximum torque. You will be getting two values because it is a quadratic equation and you have to identify. You will be getting 1 by 3 and you will be getting 3 also, 3.0. So basically slip cannot be more than 1. So we have to choose 1 by 3. So the slip at which maximum torque occurs is 1 by 3. Suppose this is equation number 3. What you are getting is 0.6. Are you getting that? Now you can write for the full load torque, and this is the maximum torque. So this is 2SSM, S square plus Sm square. What is the value of full load torque and maximum torque? Full load torque and maximum torque, just reverse it. It is 1 upon 2.5. Yes or no? What is the full load torque and maximum torque? It is 1 upon 2.5. Just put it here. Sm you have got as 1 by 3. So can you calculate from here S value? Again you will get two values, 0.06969 per unit and 1.597 per unit. Again it cannot be more than 1. So we have to go with this value. So you got the full load slip as 0.069. Now put this value in the initial expression here. 0.06969. Okay, starting and full load torque ratio has 1.5. So can you find what is I starting per unit? Just tell me whether you are able to follow this or not. You must be getting the answer as 4.642. 4.642. बात समझ में आ रही है? It was a good question. See the next question. The next question also belongs to the induction motor, and it is saying the motor is operating at full load with a slip of 3%. Synchronous speed is 1800 rpm if it is driving a load whose load requirement is independent of the speed. It means torque is constant. If the load requirement is independent of the speed, so torque is constant. For some reason, if the line voltage drops to 90% of the rated value, determined by what percentage the motor turns hotter or cooler. The first thing you have to understand here is that how you are going to relate the drop in the voltage with the slip. Just a moment. Suppose you are sitting in your home and there is a voltage drop. So what is the first thing you are going to observe? If it is a voltage drop, what is the first thing you are going to observe? If you are sitting in your room idle, watching the TV, and suppose there is a lesser voltage coming to your home, what you will do? Lesser voltage coming to your home, the first thing you will observe is that your lights will be little less bright and your fans are going to be moving with a less speed. So can I say less voltage coming means speed becomes less? Rotor speed becomes less. Rotor speed becomes less means slip becomes more. Slip becomes more means what about the rotor copper losses? It is slip times the air gap power. What is the air gap power? Air gap power is you are defining as the developed torque multiplied by 2 pi ns upon 60, that is omega s. Now ns you are not changing, it is a constant, 120 f upon p. Torque developed you are saying is a constant because it is in torque requirement is independent of the speed, so it is constant. It means your air gap power is also going to be constant. Now when air gap power is constant and your slip is increased, definitely the rotor copper losses will also be increasing. Yes or no? Say yes or no. Just a moment. Is it clear or not? Now if you write the torque, how you are writing the torque for the induction motor? You are writing the torque for the induction motor as 3 times E2 naught square 2 pi ns upon 60 slip times R2 upon R2 square plus Sx2 naught whole square. Yes or no? This is how we write the torque equation. But you know that slip is very small. So when S is tending towards 0, R2 becomes R2 square becomes very high in comparison to Sx2 naught whole square. So you can write the torque as being directly proportional to slip V square and R2, but R2 we are not interested because we are not changing the R2. So simply you can write torque is directly proportional to slip and voltage square. So can I write T2 is equal to T1? Yes. So it becomes S2 V2 whole square is equal to S1 V1 whole square. Yes or no? Is it clear or not? Now if you see the rotor copper losses, just wait here at this equation. If you see the rotor copper losses, they are slip times the air gap power. Air gap power is constant, we have just seen. So can I say rotor copper losses are directly proportional to S? Yes. Rotor copper losses higher means more and more amount of heat dissipation means more and more temperature. So temperature or heat is going to be directly proportional to slip? Yes. So now you can correlate that if I have to write the percentage change in the temperature, so it is going to be T1 minus T2 upon T1. Yes or no? But they are directly proportional to the slip, so you can write S1 minus S2 upon S1. So what is the slip value for S1? Is it mentioned? (1800) is the synchronous speed. Initially slip S1 is given as 3%. Okay. So can you calculate from this equation what is going to be S2? This is going to be S1 square. This is V1 upon V2 whole square. This is S1 square. Sorry, something wrong I have done. Huh? This is S1 V1 square. Okay. Also, it will be like this only. How much voltage is reduced? It is saying it is 90%. 0.9 V1 to the square. So you can find S2 value also easily. You can find the S2 value easily. So you must be getting it somewhere around 0.037 as per my reference. You got S1 also. S1 is given 3%, 0.03, and this is S2. So now if you find the percentage change in the temperature, you will see somewhere around 25% hotter. Okay. I think it should be S2 minus S1. It should be temperature increases now. So it is T2 minus T1. It is S2 minus S1. Just change this. 24 point something you must be getting. So that is going to be approximately 25% hotter. Is it clear, everybody? Are you getting the idea? Is it clear? Yes, 25% hotter. Let us see the next question. The next question belongs to the synchronous alternator. There is a star connected 11 kilovolt turbo alternator with synchronous impedance 1 plus J10 ohms per phase is connected to an infinite bus. At the rated voltage, the alternator delivers an armature current of 100 ampere at unity power factor to the bus bar. The alternator output remaining constant, the alternator excitation increased by 15%. Listen very carefully. In the first case, he is telling you what is the armature current. It is 100 ampere and unity power factor, so it is 0 degree ampere. You have the synchronous impedance, you have the terminal voltage because it is connected to the infinite bus at the rated voltage. Yes or no? So can you tell me what is going to be the excitation EMF in the first case? Because he is saying it is increased by 15%, so I must know the first case value. So this is going to be terminal voltage plus this is IA and this is ZS. Just put the values in. Tell me what is the answer you are getting for EF1. As for my reference, I am telling you. Let me write in the next page. EF1 11 kilovolt divided by under root 3 because it has to be per phase plus first case armature current is 100 ampere 0 degree and the synchronous impedance is 1 plus J10. Simplify this. As for my reference, you must be getting 6527.89 angle 8.81 degrees. This is volts. Say this is equation number 1. So you got the excitation EMF for the first case. In the second case, In the second case, he is saying it is 15% increased. It is 15% increased. Okay, it is 15% increased. Now we have to find the corresponding armature current in the second case when the excitation is increased by 15%, and this armature current we can relate with the EF2, yes or no? But at the same time he is giving a condition that the alternator output remains a constant. What is the meaning of this? If you have, this is a infinite bus and you have a synchronous generator connected to this infinite bus like this. So this synchronous generator is supplying some real power to this. What is the expression for this real power? Do you remember? The general expression was, if this is EF and this is V, mod EF mod B upon mod B cos of beta minus del minus mod A mod B mod V square cos of beta minus alpha. This was the general expression that we were using for the transmission line. Let us make some small changes. Here alpha becomes 0, beta becomes theta, synchronous impedance angle, A becomes 1, B becomes simply the magnitude of Z, yes or no? Magnitude of Z, and this beta becomes theta S. So this theta is very close to the 90 degrees, so you can ignore the second term. Second term becomes 0 almost, and we are interested in this equation, that is mod EF mod V upon mod Z. This is cos theta S minus del. If this is a constant value and you are not changing the terminal value, Z is also not being changed. So can I write the condition that mod EF cos of theta S minus del is going to be constant? Yes. So this is the equation you have to use. So you can write mod EF2 cos of theta S minus del 2 is equal to mod EF1 cos of theta S minus del 1. So you know EF2 and EF1 related because mod EF2 is going to be 1.15 times mod EF1. Del 1 you have already calculated, yes or no? EF1 angle. So del 1 is 8.81 degrees. So this is 8.81 degrees. Okay. So you know all the values, EF2, EF1 you can correlate, theta S you can get because the synchronous impedance is given. It is 1 plus J10. From here you can calculate theta S as tan inverse 10 by 1. Just calculate it and put in the equation. So from here you can get what is del 2. Yes or no? Can you get del 2 from here? Let me check as to my reference what we are getting. You cross check it, the calculation will be a little lengthy. It must be coming somewhere around 6.88 degrees. This is the del 2 angle you will be getting. So you know what is del 2 angle. You know what is magnitude EF2 because EF1 magnitude already known, 1.15 multiplied, you can get it. If you have both the values, the next thing you have to do is you have to find the corresponding armature current. As for my reference, just I'm giving you the value. Yes. I'm writing here. So how you are going to calculate the armature current IA2 in the second case, it will be mod EF2 angle del 2 minus mod V angle 0 degree divided by ZS angle theta. Are you getting the point? So if you solve it, put the values, you will be getting IA2 as 141.54 angle minus 45.08 degrees amperes. So this is going to give you the operating power factor. Just find cos of 45.08 degrees, and it is going to be lagging with the terminal voltage because of the negative sign. So you must be getting 0.7061 as the power factor, 0.7061, and that was lag. This was a little lengthy question, but a very good question. So load angle you got is 6.88, so it was MSQ question, and the power factor is 0.7061 lagging. Is it clear, everybody? Let us see the last question. That is a one marker question from transformer. He's saying the percentage resistance and percentage reactance of a 10 kVA 400 or 200 volts three-phase transformers are given. This is R per unit. This is X per unit. R per unit and X per unit. If the constant losses, that is the core losses, are mentioned as 1%, the maximum possible percentage efficiency of the transformer will be. How you are writing the maximum efficiency? You are writing the loading for the maximum efficiency condition S cos phi divided by X for eta max S cos phi plus 2 times the core losses. What is going to be this X for the maximum efficiency condition? This is under root PC upon PCU. Constant losses are given as 1%, 0.01. Copper losses, full load copper losses are nothing but the per unit value of the resistance. Per unit resistance is same as the full load copper losses. It is given as 2%, so 0.02. It becomes 1 upon under root 2, so this is 0.707. Just put the values. It is 0.707. S becomes 1, dealing with the per unit. Cos phi becomes 1 because we are talking about the maximum efficiency. No information given for the power factor. 0.707 into 1 plus 2 times the core losses, that is 1%, 0.01. So just multiply with 100, you will get the efficiency. Is it clear, everybody? Voice is less. Now it is okay. Mr. Mukund Chikal Thane, if I'm pronouncing it correctly. So this is all from my side, friends. Thank you so much for watching us live. I think this mock test, all the subjects completed, is going to give you a lot of motivation and going to channelize your energy in the right direction. So do not forget to subscribe to BYJU'S Exam Prep for all these important sessions and updates. And we are coming up with more and more important sessions for you. तो दोस्तों एक बार जल्दी से कमेंट सेक्शन में लिख के बताओ मजा आया आपको मॉक टेस्ट करने में मजा आया you got the spirit how you sit in the examination what should be your speed how you should go for the actual turns and tricks in the question paper yes and all those candidates who are watching it offline in the recorded form so do not forget to subscribe to BYJU'S Exam Prep and tell us your feedback that how you like this mock test. Thank you so much. Take care. All my best wishes from team BYJU'S Exam Prep. Thank you so much.